which means the mean is going to be the sum, which is 58554 divided by 15. And this gives me 570.27. Okay, so if you follow the procedure of punching this in the calculator using the mod and the start kind of direction. Then 1.2, they're asking us for the standard deviation. So the standard deviation that I'm having is a 29, it's 291, not a 29. Okay, so it's 291.03. That is still runs, but the units are not really relevant in this case, okay? Whether you put them or not, you'll still get your marks. Then 1.3, they're asking us to calculate the monthly premiums within one standard deviation, meaning that we must get the mean minus the standard deviation, and then we must get the mean plus the standard deviation. So if I get the mean, which is the 570.27 minus 291.03, my upper limit is 570.27 plus 291.03. This gives me a limit of 294.24. And then the upper limit is going to be 861.3. Okay, so how many data pieces are within this interval? Okay, so when I count between 294, that's from here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, below 100. So which means we have 10 premiums. Okay, so that is what we have for 1.3. All right, then. Okay, so 1.4, they're telling us that the insurance company decided to increase the monthly premiums. Okay. The monthly premiums that were less than 500, they were increased by 18%. And then those ones above or record 500, they were increased by a certain percentage, which is K. After the increments in the data, a new mean was determined as 686.44. They want us to get the value of K. All right, so what we're going to do there. So I know very many people might have different opinions on how to work this out, but I'm just going to use my format for as long as we get to the correct answer. So I need to add up all the amounts that are less than 500. So 134, 215, all these ones. So how many are they? 1, 2, 3, 4, 5, and 6. So these 6 amounts, when I add them up, I'm going to get 1,791. Then I'm going to multiply this by 118 over 100 so that I get the new total for those 6 amounts, okay? So when I do that, I'm getting 2113.38. Alternatively, somebody would have said 18% of this and then you plus again, okay? So we have this as our first total. Then the amounts above 500, okay, that's below 500. And then above 500, I can just subtract the total that we had, 8554, minus this total of ours, okay? So that gives me, I can do that. I can subtract this from that, but that would be suicidal. Let me rather add up. Okay, subtract 8554 minus 1791. Okay, this gives me 6763. Okay, so if I have a 6763, and then I'm gonna multiply it. Okay, plus 6763 times K%. Okay, this must give me the other total. Okay, which means I'm gonna have this. Alternatively, if this 1K, I don't want to say 1K, but you'll have 100 plus K, and then you multiply this with this entire thing, you'll end up still with the same thing. Okay, then after getting this, I need to plus the 2 and try to find the mean, okay? So I'll have 2113.38 plus the 6763 plus the 6763 K%, okay? And then I'm gonna divide this by 15 and then equate it to the new mean, which is 6,44. Okay, then I'll multiply both sides by 15 so that I get rid of the 15. So times 15, then times 15. So this cancels. 2113,38 plus, that's going to be 6763 plus the 6763K, the percentage should give me, what answer do I have there when I multiply? Boom, 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 boom. Okay, so when I multiply that, I'm ending up with a 10296,6. Okay, let's just confirm that 686,44 multiplied by 15. 10296,6. Okay, let's plus this together. We're gonna get 8876,38 plus the 6763K percent is equal to 10296,6. Let's move this that side. It will be a subtraction. 6763K percent should give us, when you do your subtraction, I'm ending up with a 1420,22 divided by 6763. Okay, so meaning that our K percent is something like a 0,20998. Multiplied through by 100, K is approximately 21%. Okay, so that's what I'm getting. Okay, you can use your short method that is quick and still get the same answer. But this is how I would have approached it in the longest format. Okay, then question number 2. Question number 2, they're telling us that the manager of a supermarket decided to do a survey on the number of items that a customer ordered online and the time in minutes that the packer took to have the order ready for delivery. So they have 10 online orders on a certain day, and then the information is for those 10 orders. Okay, so we have the bivariant type of data. Okay, they want us to draw a scatter plot. Can I draw it here? Okay, so let me just put it down here. Okay, so that's your Y, and that is your X. We don't have any negative numbers in this case, okay? So you guys had a graph book or graph page. So yours was kind of neater and slightly quicker. So with mine, what I'm going to do is, let me use X, okay? Because this X is representing the number of items. I believe that's what it was. And then this time we shall have the time. So if I have this as a 5, I can have a 10, a 15, a 20, and then lastly, I have a 25. Then up here, the highest value I'm getting, I think is it's a 12. So meaning that I'll have a 2, a 4, a 6, 8, 10, and probably a 12 somewhere there. So what we need is just the trend of how things are happening, okay? So 10 is going with 5. 10 is there, 5 is somewhere there. Then we have 3 is going with 5 again, 3 is somewhere there. 5 is more or less around there. Then 20 is going with 9. 9 is slightly before 10, okay. Then 14 is with 7. 14 is there. 7 is slightly between 6 and 8. And then 17 and 6. 17 is somewhere there. 6 is somewhere here. And then 9 and 6. 9 is there. 6 is somewhere there. Then 12 and 8. So 12 could be here. And then 8 should be somewhere there. Then 18 and 11. 18 and then 11 is somewhere there. Up. And then we have 15 and 10. And then we have it somewhere there. And then 19 and 12. 19 and then the last point, which is 12. So we must have this kind of shape that is having a positive sort of relationship, okay? So that is done. And then 2.2, they want us to get the equation of the least square regression line. So we know that that equation should be in the form of A plus BX. So my A that I have is a 3,079, or you can round it off to 3,08. And then the B, okay, the B I'm having is a 0,3 0.51, which is the same also as 0.35. So y is going to be 3.079 plus 0.351x. I'll use just 3 decimals. 2 decimals, perfect, well and good. Okay, then I need to find the correlation. So after punching all these numbers into the calculator, yes, that's how I obtained my A's and my B. So my correlation coefficient is 0.74 to 2 decimals. And then 2.4, they're telling us that the supermarket received 13 orders or an order of 13 items. Okay, can we predict how long in minutes? So we have to use this equation of ours, the regression equation, meaning that is 3.079 plus 0.351 multiplied by 13. If I were to use, let's say, that other one with just the 2 decimals, what would be my answer? So the answer I'm getting is 7.64 minutes if I use the 3 decimals. If I use just 2 decimals of the equation, I should be having something like 7.63, which is approximately 8 minutes. Okay, that's if I'm to round it off. Then 2.5, it's not a must to round off. Even these decimals are perfect. Then explain why the y-intercept of this line does not make sense. So meaning that the y-intercept, which is a 3.07 something, why doesn't it make any sense? Simply means that if we have an order with no items, that is going to take us 3 something minutes or 3 minutes to arrange that order. So that basically doesn't make sense because whenever an order is placed, there are items that have to be there, okay? So in other words, an order must have at least 1 or more items. You cannot make an order and then you don't, order. It's like calling pizza people and you're like, oh, I need a pizza. How many? 0 pizzas. Doesn't make sense. So the explanation should be around that. Okay, then question number 3. In the diagram below, this triangle is drawn where R lies on the x-axis, okay, and S lies on the left of R, okay, T lies on the y-axis, coordinates of that. The equation of RT is this, meaning that this equation is also the same as 2x plus 10. Okay, let's have it in a simplified version there. Then they want us to get the coordinates of R. So we know that R is the x-intercept, and then at this x-intercept, y is always a 0. So I'll come down and say that 0 is equivalent to x plus 10. Move the 2 that side, negative 2x is a 10, meaning that x is a negative 5. So R is going to be negative 5 and 0. Okay, that's how I get the 2 marks. And then 3.2, they want me to get the coordinates, sorry, the length of RT. I leave my answer in a third form. Now, given that the equation of RT is 2x plus 10, we know that this 10 is the y-intercept, simply telling us that the coordinates there are 0 and 10. Okay, they want us to find the length of RT. Since we've proved that this is a negative 5, and we know that this is a 90, we can use the Pythagoras, or you can use your distance formula. There is no problem with that, okay? So if I use the Pythagoras, that's a 10, that's a 5, meaning that my RT is going to be the square root of 10 squared plus 5 squared. Okay, said square root of 10 squared plus 5 squared gives me 5 root 5. Okay, 5 root 5 units. That is what we would have done to get that. Alternatively, use your distance formula. Okay, you still get the same answer. All right, then 3.3. Question 3.3. What do they need? They're asking us to determine the value of M if 2RT squared, okay, twice the RT squared, meaning that the 5 root 5, and then we square that, should give us 5 SR squared. So what is our SR? We don't know what SR is, but we're gonna use the coordinate or the distance formula to determine that. Okay, so where can I do this? Okay, I can write it here. Okay, so where we have the left-hand side, we shall have 2 into 5 root 5 squared should give us the SR, I'll say it is M minus 5, which is a plus 5 squared, plus, this is 1 minus 0 squared. This is our SR squared, okay, from the distance formula. So I'll replace that with, so M plus 5 squared plus the 1. I'll open up this bracket and also simplify this side. So the 250 here is going to be M squared plus 10M plus 25 plus 1. Let's move everything to one side of the equals. No, there's something I missed out. There's a 5 here. Okay, so we don't need to leave that 5 out. So meaning that this must be multiplied by the 5. Okay, so 250 is going to be 5M squared plus 50M, and then 26 times 5. What do we get? 26 times 5 gives me a 130. Then let me get the standard equation. So 5M squared plus 50M. So 130 minus 250 gives me a 120. I can divide through by 5, okay? So M squared plus 10M minus, what's 120 divided by 5? I'm getting a 24. Gives us a 0. Which two numbers can we look at? Factorize that. I'll have M minus 12. No, it's plus 12. And then M minus 2. Yeah, makes sense. Mean that either M is a negative 12 or M is a positive 2. But looking at the position of M, it's on the negative side, which means that our M should be a negative 12. Okay, so that is how we would have obtained those values, okay? We move on to the next one. Question 3.4. Okay, so 3.4, they're telling us if it's further given that V lies on the line ST, okay, such that VR is perpendicular to ST, can we determine the equation of VR in this form? So one thing we know is that for as long as lines are perpendicular, the product of their gradients must always be a negative 1. So we're saying this is a negative 12 and 1. Okay, that's a 0 and 10. So we can find the gradient of this line, ST. Okay, let me put it aside. So we said S is negative 12 and 1. T is 0 and 10. So gradient of ST is going to be 10 minus 1 over 0 minus 12. Okay, gradient is change in Y over change in X, meaning that we have a 9 over 12, which becomes a 3 over 4. Okay, that's the gradient of the line ST. Now, if they are perpendicular, meaning that the 3 over 4 multiplied by the gradient of V, is it VS? No, it's VR. Okay, gradient of VR must give us a negative 1. So the gradient of VR becomes negative 4 over 3. But VR is passing through negative 5 and 0. So for us to get the equation, y minus y1 is equal to m into x minus x1 is what I'm going to use. Okay, meaning that I have y minus 0 is equal to negative 4 over 3 into x minus minus, which gives me a plus 5. I open this up, I have a minus 4 over 3x minus 20 over 3. So that is the equation that the question wanted. Okay. Then 3.5, can we show, hence, can we show that the coordinates of V are negative 8 and 4? Okay, how do we prove that that's negative 4 negative 8 and 4. So what I'm going to do, 2 marks. What would people have done in this kind of scenario? Because the approach I have is kind of lengthy for 2 marks. Okay, because what I need is just more like the equation of this line, and then I'll solve the 2 simultaneously. Okay, that's the option that I have currently. Okay, so we know that the equation of this line, since we say that the gradient is gradient of ST, we got it as a 3/4. Yes, 3/4. Okay, so it's a 3/4 with x. The y-intercept is a 10. This is our equation. Okay, then we already have the equation of this other line that we found. So I'm just gonna solve them simultaneously there. This is question number 3.5, okay? So we're saying 3.5. We're saying y is a 3/4x plus 10. And then the other equation for the VR, we said it's a negative 4/3 x minus 20/3. Let's equate the two. 3/4x plus 10 should give us negative 4/3x minus 20/3. So I'm going to multiply through by 12 because I want to get rid of the denominators. So by 12, by 12, by 12, and then by 12. So that's going to give me a 9x plus a 120 is equivalent to negative 16x. That and that is going to give me minus 80. Okay, then I'll collect the like terms. I'll move the 16 that side. I have a 25x. And then 120 moving it that side, I'll have a negative 200, meaning that our x is a negative 8. Then get this negative 8, then I'll replace it into this equation. I mean, for 2 marks, something is fishy here. No? But we have the answer. Okay, there's no need to stress. We have the answer. So this is going to give us a negative 6 plus 10, which is a 4. Okay, so y becomes a 4. So that is how I would have proved it, okay? If you have a shorter way, please feel free to share with us in the comment section. All right, then 3.6. They're telling us that R prime is a reflection of R about the line x is equal to 0. Now, this line is the same as the y-axis. Okay, because along the y-axis, x is a 0. So where is R? Okay, let me just use a different color. Okay, so if we are reflecting it about the y-axis, which means instead of it being a negative 5, it's going to end up being a positive 5. Okay, rather let me erase this out. So if it's a positive 5, the question now wants us to determine the area. Are we looking for the area? I suppose. Okay, they want us now to find the area of the quadrilateral. Okay, this T, that point, this, that, and there we go, something like that. Okay, they want us to find the area of that quadrilateral. Okay, so for 5 marks. So the trick here is for us to understand that we have two triangles. I'll call this triangle A, and then I'll call this triangle B if I split it into 2. Okay, both of them are right angled because I already have a height here, because my height is going to be 10, because from here up to here is a 10, and then here up to here is also a 10. Okay, this one is automatically right angled. The only thing I need to find is the distance. Okay, find VT, and then I also find VR. If I do that, I'm good to go. All right, so let's get VT. Okay, so we said V is going to be negative 8 and 4. T is 0 and 10. Okay, so meaning that our VT, what is our VT? People with calculators, okay, is a 10 minus 4 squared. If we use the distance formula, 0 minus 8 squared under the square root. So 10 minus 4, that is a 6 and 8, meaning that this is 10 units. Okay. Then we said we also need which other distance? We need the distance VR. Okay. So VR, we know that our R is going to be a negative 5 and 0, meaning that it's going to be the square root of negative 8 minus 5 squared, then plus 4 minus 0 squared. Okay, when we punch this into the calculator, we have the square root of, that's going to be 3, which is a 9, plus a 16, meaning that it is 5 units. Okay, so I need to find the area of this. So this is a 5, this is a 10. We have this as a 10, we have that as a 10. So let's get the area of A plus the area of B. Okay, area of A plus the area of B. So that is a half. The base, let me have this as my base, which is a 10, and then let this be a height because these two are perpendicular. Okay, so it's 10 times 5, then plus a half. We said the base of B is this total distance, which is a 10. The height is also 10, okay? 10 times 10. Okay, so when we simplify the first part, that's gonna be a 25. And then this is going to be 100 divided by 2, which is 50, meaning that our answer is 75 units squared. So that is how we would have obtained those 5 marks. All right, then question number 4. The diagram, M is the center of the circle having this equation, okay, meaning that the coordinates of M here are 3 and 0. Okay, and then the radius is 5 based on this. Okay, so if that's a 5, meaning that this one is also a 5. Okay. Then E is negative 1, 3 tier points on the circle. EC is a tangent. Okay, so if it's a tangent, okay, there's something we're gonna see. E cuts at D, that's perfect. And then they're telling us the distance ED is 15 over 4. Then MT is produced to get point C. Perfect. They want the size of CEM. So CEM, this angle here. So we know that that angle is a 90. Why? Because it's a tangent perpendicular to the radius. Okay, tangent and the radius will be perpendicular. And then they want the equation of the tangent EC in the form of mx plus c. So what we need to know is that whenever they ask us for the equation of the tangent, we need to first of all get the gradient, okay, of the radius to the tangent. So gradient of the radius is going to be change in y over change in x, meaning that I'll get my 3 minus 0 over negative 1 minus 3. So this gives me a negative 3 over 4. Yeah? That is for the radius. Then we know that gradient of the radius times the gradient of the tangent must give us a negative 1, meaning that the gradient of the tangent is going to be a 4 over 3. Okay, so we have our gradient as a 4 over 3. Then we need to write down the equation using this point E. Okay, so I'll say y minus y1 is equal to m into x minus x1. So y minus 3, I'm using point E, is equal to 4 over 3 into x minus minus 1, which gives me a plus. Okay, open this up as you transpose. So it's a 4 over 3x. That's going to be a plus 4 over 3. When I move this 3 that side, becomes a positive 3. So it's a 4 over 3x. This is going to be 9, which is a 13 over 3. This is the equation that the question wanted. Okay. Then they want the length dm. Okay. The length dm. Now, since we've proved that this is a 90, we know that the radius is 5. We can find this using the theorem of Pythagoras. Okay. Meaning that our dm is the longest side, is opposite 90. It's going to be the square root of 5 squared plus the 15 over 4 squared. You punch that in the calculator. How many marks is it? It's 3 marks. Okay. When I punch that in the calculator, I'm getting 25 over 4 units. Okay. Alternatively, one would have started, since we already have this equation, you start by getting the coordinate of D, okay? And if you look for the coordinates of D, because at D, the Y is 0, you're gonna end up with a negative 13 over 4. And then you just plus this together. So it's gonna be 13 or 3 minus 13 over 4. So that should give you a 25 over 4 as that. Okay, so that is 4.3. And then can we show that P is negative 5? So we already have the equation here. And we already have the X value. So let's replace the X with a negative 7 and see. So 4 over 3 into negative 7 plus 13 over 3. When I punch that into the calculator, that's negative 28 over 3. Okay, plus 13 over 3. So perfect, it comes out as a negative 1. Then 4.5, can we calculate the coordinates of S? Okay, where SEMC is a parallelogram and the X coordinate of ACE is negative. Okay, it's less than 0. So they're telling us that there is a parallelogram, okay? In other words, there is some extra coordinate. So I'll just put that coordinate around here. I don't know, anyway. I'll call that S. And then I have my X and then my Y. So if I connect that and then connect that, I'll have some sort of a parallelogram. I know it's weird, it's ramshackle, but it's no big deal. Ne? What we need at the end of it is for us to come up with the correct answers, okay? So what I'm going to do there, okay, because I know the position is off, it might also be misleading. Let me just have it drawn somewhere, maybe here, so that it looks like a real parallelogram, okay? So that is X and Y. Okay, so X is on the other side. Now, whenever we have a parallelogram, the trick of determining the opposite sides or the missing, not sides, but the missing coordinates is for us to use what we call the midpoint formula, okay? So we need to use the midpoint formula. So we need to get the midpoint of each C, which must also be the same midpoint as SM, okay? So midpoint of EC. So it's saying the midpoint of EC, whereby we know that E is negative what? Negative 1 and 3. And then C, they said negative 7 and 5. Is that correct? Okay. So let's plus that and we see. So negative 1, also midpoint is x1 plus x2, divide by 2, y1 plus y2, divide by 2. So that's the formula, okay? So you're going to have a negative 1 plus a negative 7 divided by 2. 3 plus 5 divided by 2, meaning that our midpoint coordinates are going to be negative 4, as well as there's something wrong. This is a negative 5. I don't know why I'm using a positive. So negative 4 and negative 1. Okay, so those are the coordinates of the midpoint. Then we know that our S, which is xy, must also have the same midpoint as M with the 3, 0. SM must have the same midpoint. Okay, so if I use the midpoint formula again, I'll have x plus 3 over 2 should give me negative 4. And then when I cross multiply, that's going to be a negative 8. Move the 3 that side. X is a negative 11. Then y plus 0 over 2 must give me this y value of the midpoint. Then that our y is going to be a negative 2. So that is how I would have gone about answering that question. So they want the coordinates. Okay, so we said negative 11 and then negative 2. All right. And then 4.6. Okay. 4.6, they're telling us that if the radius of the circle that is centered at M is increased by 7. Okay. Now, if this radius is increased by 7, meaning that the new radius is going to have 12 what? 12 units. Good. Now, they're asking us, determine whether S lies inside or outside of the new circle. Support your answer with the necessary calculations. So when I look at the center, okay, so I'm going to look at this center and this coordinate ace and see what distance is here. So if the distance between S and M is smaller than 12, then it lies within. If the distance is bigger, then it lies outside. Okay, so we shall say that our S, which is -11 and -2, our M, which is 3 and 0. Okay, so we're going to say that the distance SM will be the square root of 3 minus -11 squared plus 0 minus -2 squared. Guys, I apologize for not writing the formulas, okay? But you know what we're doing, eh? Good. So this is going to be 14 squared plus F4. Okay, 14 squared plus 4 gives me 200. Then square root of 200, okay? So 14 squared and that gives me 200. And then square root of 200 gives me 14,14. Okay, alternatively, somebody would just compare the 200 and then the square root of, because the new radius, we said it is 5 plus 7, which is 12, which is a 12. And then 12 squared gives us 144. So we can see that the 200 is greater than the 144. Alternatively, you can say this one is still greater than the 12. Therefore, the point S lies outside of the circle. Okay, so whichever format you want, you can compare it using the 200 and the 144, or compare it using the actual values. Okay, so that is how we would have gone about with question number 4.6. All right, 4.7 for 5 marks. This question. Let's see if it makes sense. Okay, because me looking at it, I'm gonna do still a longer approach to get to the answer, which might annoy some people. Eh? But let's give it a try. So if we have a line that is being drawn for us, and then that line is being called P.2. They want us to find the equation, or they want us to find the angle, okay? Which angle is ETM, this angle here. So the only thing I know, okay, is that this is a 5. If that is a 5, how do we find this angle here for 5 marks? Do we have the equation of CM? Because I'm thinking of finding the equation of CM, but is it gonna help? Because we know this is a 90, which is fine, but does it help here? Guys, help, please. If I use the, okay, I could use the distance formula. So like I said, I'm just gonna go the longer route and try to establish, okay? So what I need is to get the coordinates of T. That's gonna make life a bit easier for me from my point of view, okay? So for me to get that, I need to find the gradient. Okay, let me just erase this and find the gradient of CM. Guys that worked out this thing in a shorter way, please help us. Ne? So that's gonna be -5 minus 0, which is a -5 over -7 minus 3, which gives us a positive 1/2, okay? So if it's positive 1/2, and then we use this point, it's gonna be y minus 0 is equal to 1/2 into x minus 3, meaning that our equation is 1/2 of x minus 3. Now let me solve this equation together with the equation of the circle for me to get these points of intersection. Does it make sense? It should make sense. Right, okay, let me give it a try that way. Let me give it a try. So we're saying that the equation of the circle is x minus 3 squared plus y squared gives us a 25. But our y is a half of x minus 3. No, it's a minus 3. Let me not, yes, minus 3. Okay, so where there is y, I'm going to put that, and then we see what happens. Okay, so x squared, no, let's say x minus 3 squared plus this is a half of x minus 3 squared gives us a 25. Okay, let's open it up. So that's x squared minus 6x plus 9 plus, that's going to be a quarter of x squared minus, that's going to be 3x because I multiply this and then times 2. And then this is going to be a plus 9 minus 25 becomes a 0. Okay, let me just collect my like terms quickly. So this becomes a 5 over 4 x squared. This and that is minus 9x. This and that is 18. What's 18 minus 25? That gives me negative 7 is equal to 0. Let's multiply through by 4. Yeah, which means it's 5x squared minus 36x minus 28 is 0. Okay, so if, let's say we are to solve this, this is lengthy. Let's hope we don't get lost with this. Okay, we're saying it's equal. So we can use the quadratic formula here to do the solving. Getting big answers here. Okay, so I'm getting something like a 7,9. I don't know what that is. Okay, and then I'm also getting a negative 0,71. Wow, why so big answers and funny answers? So the x of interest is this side, which is negative. But why is it a small value? Negative 0,71. Okay, so if it's a negative 0,71, let me punch it into that equation of the line. We said a half of x minus 3. So a half times 0,71 minus 3. Let's see. 0,71 minus 3, which is a negative 2,65. Okay. So let me get my, what do we call it? Because that is 5. This is also 5. Okay. So I'm saying, let me get my angle or my distance of ET. There's a shorter way, guys. No, man. For 5 marks. So ET, we're saying negative 0,71. This is a negative 2,65. Our E was negative 1 and 3. Okay. So the distance there is the square root of. Okay. So it's going to be x, which is negative 1 plus 0,71 squared plus 3 minus minus. So that's a plus. We square that. I'm having doubts with this answer of mine. So negative 1 plus 0,71 squared plus we're having a 3 plus 2,65 squared. That gives me a 5,66 units. Okay. So now if our triangle is in this format, this is 5,66, that's a 5, and that is also a 5. What do you think is going to be done? Because we know that this angle must be also the same as that. Something is off here, but it's fine. I'll find it out. So then I'm going to use the cosine rule to find this angle. So that is A, B, and C. We know that from the formula page, we know that the cos of A should be A squared. Okay. It's b squared plus c squared minus a squared over twice, something like that. Okay, let me just write it down the way it is on the formula page. Something is off here, but it's okay. So we're saying a squared, in this case, our a squared is equal to b squared minus, no, it's a plus, c squared minus 2bc cos of a, okay? So if this is our a, it's going to be 5 squared is equal to the 5,66 squared plus 5 squared minus 2 times 5,66 multiplied by 5. And then we're saying the cos of a. So this can cancel that. Okay, I'm going to move the 5,66 to that side. So 5,66 squared becomes 32,0356 negative is equal to 2 times 5,66 times 5, which becomes a 56,6 cos of a. It's also negative 56,6 over negative 56,6. My approach that I'm taking is worth 8 marks, not just 5, okay? When I simplify this, so I have a 32,0356. I'm dividing it by 56,6, which is a 0,566. And then I must find the arc cos of 0,566. Sure. So shift cos of 0,566. The answer I'm getting is a 55,53. Wow, what a lengthy approach. Okay, so alternatively, okay, the quicker way would have been to use the gradients. Okay, I think I'm getting back to my senses. For you to get the gradients, and how would that have worked? We know that this is a 5. This is also a 5. This angle will be the same as this angle here, okay? If we can find this angle and find this angle, whatever is left, we need to subtract it from 180. Okay, then we divide it by 2. So what is the gradient here? Okay, let's just confirm, guys, and we see. I'm sorry for boring you guys with my long method, but we could also use this, okay? So the gradient of EM, remember we said it is 3 minus 0 over negative 1 minus 3, which is basically 3 over 4 negative. No? That's the first question we started with. And then the shift tan, okay? The arc tan of negative 3 over 4 gives us a negative 36, 87. So meaning that this answer here, or the angle here, is a 36,87. You could find also the outside part, no stress. Then if we find the gradient of this, okay, so gradient of CP, which is gonna be 0 minus minus 5 over 3 minus minus 7, which we also found as what? A half. Okay, so the shift tan of a half gives us a 26,57. I'll have it as a 57 there. So meaning that this angle here is a 26,57. Even this one will be a 26,57. Then if you plus the 2, let's just confirm. Let's hope my answer with the longest method is correct. Okay, so we're saying that 26,57 plus the other one was 36,87. This we must subtract from 180. Then the answer we get, we divide by 2. Okay, so 180 minus the 26,57 plus the 36,87. Okay, I'm getting 116,56. We divide this by 2. Okay, I'm getting a 58. Hey, there's trouble in paradise. 58,28. This case, we had a 55. Okay, so I would vouch for the 58, guys. I would vouch for the 58 because it makes quite a lot of sense, because we know that this angle must be the same as that angle because those are angles that are opposite equal sides. Okay, then that is 4.7. Then question 5. They're telling us that the cos of theta is -5/13 within this. So if I'm to look at the quadrants, if this is negative, no, it's positive 180, this is a 360. Okay, where do we find cos to be negative within these two quadrants? Is the third quadrant. So I need to draw my sketch nicely and warmly. Okay, so cos is adjacent, which is a 5, of the hypotenuse, which is 13. So that's going to be a negative. Then I need to find my missing side using the theorem of Pythagoras. So 13 squared minus 5 squared. Okay, under square root. So when I do that, what do we end up with? So that's going to give us a 12 plus minus 12. But since the side is below the y-axis, so it's going to be a negative 12. So the triangle is complete. We go to the sine. So sine is opposite over hypotenuse. So -12/13, we square that, which is 144 divided by 169. Opposite over hypotenuse. So 169, no, 144 over 169. Okay, so that is that. And then tan 360 minus theta, which quadrant is this? That is the fourth quadrant. And the tan, because we know that the tan is negative in the fourth quadrant, so it's a negative tan theta, which is a negative. Our tan is opposite over adjacent, -12/5. That's going to be the answer, because the negative and negative will be a positive, but this negative makes the answer more negative. And then the cos of theta minus 135. Let's expand this using the compound angles. So that's going to be cos theta cos 135 plus the sine of theta and then the sine of 135. So we know that 135 is in quadrant 2, which will be 180 minus a 45. Okay. So we're going to reduce that, and it's going to be cos theta multiplied by the second quadrant. The cos is negative, so it's going to be negative cos 45. And then we are adding, okay, sine of theta and then the sine of 45. So we know that the cos of 45 is 1/√2. Is that correct? It's 1/√2. But then our theta from here, our cos theta is -5/13. Okay, -5/13. We're multiplying it by the -1/√2. Plus the sine is going to be opposite over hypotenuse, which is -12/13. We're multiplying it by 1/√2. Simplify this, that's going to be a 5/13√2. Okay. 5/13√2. And then I'm adding, no, I'm not adding, I'm subtracting. Okay, subtracting 12/13√2. So 7 minus 12, sorry, 5 minus 12, I'm gonna get -7/13 square root of 2. So guys, that is what I'm getting as my final answer. Okay, so that is 5.1.3. Then 5.2. Let's see. 5.2. We've been told that if we have two cos, okay, this is 180 minus x multiplied by the sine of -x, and then we are dividing this by the 1 minus 2 cos squared 90 minus x. Okay, so to answer this question very fast, we need to do the reduction. There's 2. This is second quadrant, the cos is negative, okay? So that's going to be a negative cos x And then that's also going to be a negative sine x over, this is a manipulated format of the double angle of cos. So if I introduce a negative, it's going to be 2 cos squared 90 minus x, okay, minus 1, something like that. Meaning that I'm just going to write it as negative cos twice of 90 minus x, something like that. Then I know that in the top, it's going to change to 2 cos x sine x over, this is going to be the cos of 180 minus 2x. Okay, so that is a positive. We have a negative down there. Then if we move on further, what we are observing is that we're just going to reduce this to a sine 2 theta or sine 2x. And then this cos is negative in the second quadrant, which is going to give us a positive. So negative and negative, we get a positive, so cos 2x. Simplify sine over cos, we get a tan 2x. Please, you'll help me identify this, because I'm not sure whether I left out a negative sign or because this negative here is what I'm carrying over to this point. But I already know that this and this is a positive. And if it's a 180 minus, then the negative will give me a positive. So that's what I have, guys. Let's confirm with the negative signs. Then 5.3. They want us to calculate the value of the following expression without necessarily getting a calculator. So what I'm going to do is when you look at this pattern, I'm going to look at the first and then the last, okay? So what is 92 plus 178? This is 178 and then 92, okay? So 178 plus 92, we have a 270. Now this 270, if you're looking for the tan, okay, let's say we have the tan of 270. How many 45s are in 270? So 270 divided by 45, we have 6 of them. So it would be the same as tan of 6 times 45s. And we know that the tan of 45 is just a 1, okay? Look at 94 and 176. So 176 plus 94, we still get a 270. 96 and whatever comes there, which is supposedly 174, you get a 270. Meaning that if we multiply these ones together, we're just going to end up with an answer of just a 1. Okay, so 6.1, can we prove that this is the same as that? So what I'm going to do, I'll just use the compound angles and open that up. So it's 2 into, we have cos 45, cos x, minus sine 45, sine of x, but this must be squared. Okay, we're starting with the left-hand side. Then we can change this, or let's open it up further. Does it make sense? Let's change that 2 into 1 over root 2 cos of x minus 1 over root 2 sine of x. This is squared. We can't factorize yet. Let's open that. That's going to be a half cos squared x minus, we know that a half and 1 over root 2 and 1 over root 2, we get a half. When you multiply by 2, you end up with 1. So I'm just going to have cos x and then the sine of x. And then this last part will give me a half sine squared of x. Okay. And then when I open this up, I'll have a cos squared x. That's going to be negative 2 cos x sine x. And then that is a sine squared x. So I know that sine squared and cos squared will give me a 1. And then I'm subtracting. This is a double angle of sine. So sine 2x, which is equal to the right-hand side. Okay, so that is question 6.1. 6.2, they want us to prove. We are given sine of this and that. Can we prove that it is equal to that? So still, we're going to do the same thing. The left-hand side first. Okay, so we have the sine of a minus b. minus the sine of, is it a minus first or a plus? It's a minus, and then we have a plus. This must give us 2 cos A sine B. Let's open up this. So you're going to have the sine of A cos of B minus sine of B cos of A, and then minus, okay, it's going to be sine of A cos of B plus sine of B cos of A. Let's open up here. Sine of A cos of B minus the sine of B cos of A. Open up this further, minus sine of A cos B minus sine of A cos of A. Okay, so this, let's see what we cancel out. We have sine A cos B positive, sine A cos B positive. So this cancels that. This is a sine B. Oh, why is this? This is a B and A. Okay, this sine B cos A, sine B cos A. So we're going to have a negative 2 cos A sine B, just the same thing, which is equal to the right-hand side. Okay, that we've proved. Then 6.2.3, we need to simplify. Now, the fact that this question is under what we're having here. So I'm going to let my 4x to be A minus B. And then this is going to be A plus B. So we're saying that A plus B is 4x. And then A minus B is a 6x. If I add these two equations, meaning that twice A is, are those numbers correct? We said 4 and 10. 4 and 10. Why am I saying 6? At the 2, we have 14x, which means that A is going to be a 7x. And then B is definitely going to be a 3x. Then what this means is that where I see the sign of 4x minus the sign of 10x, I'm just going to equate it to this whole thing and say that it's going to end up with negative 2, the cos of A, which is 7x, and then the sine of B, which is 3x. So that is what I would have done for that part. And then hence to determine the general solution, or the solution. They want the solution. Okay, so with the solution, we need to get the definite values of x between 0 and 30. So we're saying that where there is sine of x, okay, sine 4x minus sine of 10x should be equivalent to sine 3x. Okay, so let's replace this with that. So meaning that negative 2 cos 7x sine 3x is equivalent to the sine of 3x. Let's transpose and move it that side. Meaning that's a negative 2 cos 7x sine 3x minus the sine of 3x is equal to 0. Okay, take out the sine 3x. Let's take out the negative. We're going to be left with a negative 2 cos of 7x minus 1 is equal to 0. Okay, then either the sine 3x is 0, and we know that the reference angle shift cos of 0 is going to be 0. Then we're going to have also an 8 and probably 360, but we're focusing on 30. So the first solution is going to be 0 plus k times 360. K is an element of integers. Will that help us? 180 plus k times 360, k is an element of integers. So this may not really help. Gives me a 60. Okay, meaning that 7x is going to be a 60 plus k times 360. K is an element of integers. Divide through by 7. I'll just leave it as a 60 over, yeah, I can just change it. What is 60 divided by 7? That gives me 8,57 plus k times 360, k is an element of integers. So this is not going to help us because this is a quadrant 1 angle. We're focusing on quadrant 2, which is the 120. Okay, 7x is going to be a 120 plus k times 360, divide through by 7. So 120 divided by 7, we're getting 17,14 plus K. That is going to be 360 times, no, 360 divided by 7, which gives us a 51,43. K is an element of integers. So if I replace K with 0, I'm going to have a 17,14. If I replace K with a negative, it's going to give me a negative, which I don't want. So this is more or less the solution that I'm getting, 17,14. Okay. Okay, so we have that 17,14, but we can also include the 0 one that we had here, because these equations were giving us a 0 plus K. So if K is a 0, which means 0 will be a solution. So the best solutions will be 0 and then 17,14. All right, so we move on to question number 7. We have two graphs, F and G, okay? Then they want us to write down the range of F. So one thing we need to know is that initially, okay, if we have a 2 cos, the range was supposed to be -2 and +2. But now since we are adding a 1, it's more like +1, then +1. So it's a 3 and then -1. So meaning that Y is between -1 and the +3. That is it 7.1? Yes, that is 7.1. Then 7.2, they want the period of G. So when you look at G, how many graphs can we see? This is one graph. Those are two graphs, okay, in a space of just 360, meaning that our period is just 180. So it takes us just 180 degrees to get a full graph. Alternatively, get the 360 divided by this coefficient of X. We must get the same thing. And then 7.3, they want us to get the values of X in the interval for which F is increasing. So F is increasing from this point up to this point here. It's just increasing. So we're going to say that -180 is less X and then it's less 0. So we do not put the equal signs because at -180 and at 0, the graph is typically just changing the direction. All right. Then we have next 7.4. Use the graphs, okay, to determine values of X in which G of X times F prime of X is less than 0. So F prime is more like the first derivative or the gradient, okay, in this case. So if I have this as a plus and this as a minus, or if I have this as a minus and that's a plus, so where do I find the G to be above while F is decreasing? Above and decreasing. So it's decreasing in this area and it's above somewhere here, okay? Then the other section is where do I find the G below while this one is increasing? So G is below here while the other one is decreasing. So we can see the region of interest, this one and this one. But we know that if this is -180, this is supposed to be, this is the graph of G, which one is equivalent to 0, which is a 90. So this is going to be like a -90, and then this is going to be like a +90. So the answers for that is going to be -90 is less X is less +90. So that is how we would have answered that 7.4.1. Then 7.4.2, where do we find the cos of X to be less or equal to -1/2? Now, we're looking at the graph of cos, which is the F. So if this is a 1, -1, it should be somewhere here. Okay, we just want the X values. So when you punch that into your calculator, the shift cos of -1/2 okay, it's going to give us a 120. So if that's a 120, even this side, it must be a negative 120. So the region of interest is below, okay, below a half. So this area and this area. So the answers for that will be negative 180 is less or equal to x, less or equal to negative 120. And in that side, we shall have a 120 is less or equal to x, less or equal to positive 180. So that is how I would have obtained that. Then 7.5, the graph of G is shifted 45 degrees to the right. Can we determine the new graph of H in a simplified form? So what this means, we shifting G. And G is what? The sine 2x. So it's going to be the sine of 2 into x minus 45. Change this or simplify that, we're going to have the sine of 2x minus 90. When you take out the negative, it's going to be 90 minus 2x. Then it's going to be negative sine of 90 minus 2x. This is a complementary angle, meaning that our h of x should be negative cos of 2x. And then this is what the question wanted for that part. All right, then question number 8, in the diagram A, B, C lie in the same horizontal plane with AB being the same as AC. D is directly above A such that twice AD, okay? So in other words, if we have 2P is the same as a BC, then they want us to express AB in terms of P and Y. This is AP, but we're seeing that this is a right angle triangle, so we can use our trig ratios. And the ratio that combines adjacent and the opposite is the tan. So I would say that the tan of Y is equivalent to the opposite, which is P, over the adjacent, which is AB. Let's make AB the subject. AB is going to be P over the tan of Y. That is 8.1. Then 8.2, they're asking us to show that cos of X is equivalent to the tan of Y. So cos of X being equivalent to the tan of Y, meaning that I'm going to use AB, okay? Because I know that this is X, this must also be X, meaning that this entire thing should be the same as 180 minus 2X. So we're gonna say that BAC is 180 minus 2X, angles in a triangle, okay? So if I use BC over BAC, it should give me the same as AB over ACB. This is the sign. I'm using the sign rule, guys, forgive me. Okay, so our BC, they told us is twice what? P. So twice P over the sine of 180 minus 2x is equivalent to AB, which we found as a P over the tan of Y. You're dividing it by the sine of X. Okay, let's simplify this. So 2P is going to be equal to the sine 2x is equal to P over the tan of Y and then the sine of X. We can cancel this P and that P. We can do the cross multiplication, meaning that twice tan Y sine X is the same as sine 2x. Let's break down the sine 2x, which is going to be 2 sine X cos X. Okay, then from that point, we can see that the 2 cancels the 2. This sine X cancels the sine X. We have the tan Y being equal to the cos of X. That's what we had to do. Then 8.3, they want us to get the size of Y if X is 60. So meaning that the tan of Y is equal to the cos of 60. So tan Y gives us a half, okay? Then for us to get Y, it must be the arctan. Okay, shift tan over half. Okay, so shift tan over half, which is 26, that's gonna be 57 degrees. Okay, so that is what I'm getting for 8.3. All right, then we move on to the last question 9, okay? Provide reasons for the statements. For question 9, and 10. Where is question 10? These people, where did they get this paper from? Same for question 9 and 10. Hey, did we miss out a question? But the page numbers are just in order. We move on. So in the diagram, DEF is drawn, line GH, okay, is parallel and intersects that, blah, blah, blah. They are parallel, perfect. DG is 2 to 5, okay? Then they want us to write down the ratio with reasons of HF to EF. So we know that if we have GF over DG must be the same as HF over EH, proportionality theorem. So that's also going to be the same as 2 over 5. Okay, so proportionality theorem, because these lines are parallel. Then they want us to find EH if EF is 21. So we're saying if the whole of this is a 21, can we find EH? So there are two ways of doing this, but let me choose the longer way, or the shorter way, sorry. So I'm going to say we're looking for EH. So I'll say 5 over this entire thing, which is a 7. So 5 over 7 is equal to our EH over 21. So EH becomes 5 over 7 times 21, and that becomes 15 centimeters. Okay, so that is how I would have approached it. Alternatively, people would have said this is X, and then that is 21 minus X, and then you solve it. You're still gonna end up with the same thing. Then write down the triangle, which is similar to FGH, FGH. So this big triangle, the Makul one, because this is common, this is the same as that, that is the same as that. So since they started with F, I will also start with F. G must go with D, and then H must go with E. So that is the triangle because of angles. Then hence, I'll calculate the value of GH over DE. GH over DE. So we're looking at the shorter side over the longer side. So we're comparing the triangles. Okay, so what I can do, I can look at this and say that if I have 2 over 7, okay, just looking at 2 divided by entire side, which is 7, should be equivalent to the shorter side, which is GH, over the longer side, which is DE. So the ratio that they want is 2 over 7. Okay, so that is 9.1.4. Then 9.2. Okay, the diagram, POL is a diameter of a larger circle with center O. TMR is the diameter of the smaller circle with center M. The two circles intersect at L and R. PLK is a tangent, okay. The smaller circle, and TR is a tangent to the larger circle. Okay, the larger circle is having this tangent. Okay, and then the other one is having a tangent at this point. Then the question is, can we prove that LT is parallel to PR? LT, okay, let me just highlight this. LT is parallel to PR. Okay, so for us to have parallel lines, remember what we need to look out for. We need to look for corresponding angles, alternating angles, as well as the co-interior. But in this case, the co-interior will not apply. So let me use the tan code, because I know that this angle is going to be the same as that. Okay, so I'll say that L1 is the same as R1. Reason, that's a tan code. Then if I look at the bigger circle, we're saying that R1 is going to be the same as P. That's also a tan code theorem. And then we can say that since L1 is the same as P, therefore LR must be parallel, no, it's LT. Okay, so LT must be parallel to PR. Reason is the converse of the corresponding angles. So that is what we had to do with 9.2.1. And then 9.2.2, okay, 9.2.2, they are telling us that LORM is a cyclic chord. We must prove that L, O, R, and M. Okay, so if I connect this, so the only thing I need to do in this case is that I need to prove either this angle is the same as this, or this angle is the same as that. So whichever one that I prove, I should be able to get that. I don't know why they're giving it 5 marks. They're telling us that this line is LT, okay, is parallel to OM. So these lines are parallel. So if they are parallel, what do we see? So you're gonna say that this angle here is also gonna be the same as O1, okay? So what I'm saying is that P, okay, P is the same as O1. Reason those are corresponding angles because OM is parallel to PR. Okay, so if this angle is the same as that, we can also see, or we proved that R1 was the same as P, okay? But R1 is the same as P. We proved that earlier on. And if that is true, simply means that this angle, that since R1 is the same as O1, because we have this kind of a bow tie, okay? Therefore, L, O, R, M is a cyclic chord. And the reason is the converse of angles in the same segment. Angles in the same segment, or angles subtended the same whatever. So that is what we were supposed to do in that case. So guys, I'm not seeing question 10. Let's see with this, because the instructions said we have 10 questions, and then I'm not seeing that. So unfortunately, I'll have to stop at that and then wish you all guys the best. So in this paper, I can write it as, yeah, 90, it's fairer compared to paper 1. All the best, guys, in your remaining examinations. I sign. Yes, hello, welcome to yet another episode where we shall be looking at the proposed memorandum. So, okay, so this paper had 11 questions, okay? And according to the instructions, we have to answer all of them. Answers only will not guarantee full marks, okay? We can use a calculator, round off to decimal places. Diagrams are not necessarily to scale. No pages may be torn, okay? We're not gonna do that. Answers must be written in black or blue ink, okay? Indicate questions you've answered by drawing the cell. No, we're not gonna do, we're gonna answer everything, okay? Draw a neat line through any work that must not be marked. All right, so those were the instructions. Let's just dive into the paper. All right, so question number 1, they're telling us that the histogram below shows the marks in percentage for the grade 11 learners in their November 2024 examination. Okay, so the minimum mark is 10, or we're looking at the minimum or the lower class interval is a 10. Then 20, so between 10 and 20, we have 2 learners. Between 20 and 30, we have 3 learners, and so on and so forth. So meaning that the highest mark that could possibly have been achieved was 80%, okay? Then they want us to complete the table below. So this table is showing us the frequency as well as the cumulative frequency. So let's start with the frequency. So we have a 2, okay? Then we have a 3, and then we have a 4, and then we have 6, 5, 4. It's a 6, 5, 4, and a 6. Then for us to get the cumulative, we know that the first cumulative should be the same as the first frequency, which is a 2. And then we plus 2 plus 3 is a 5. Then 5 plus 4 is going to give me a 9. Then 9 plus 6 is 15. 15 and 5 is 20. That's a 24. Then that is a 30. So the total of the frequencies here, we must get 30. That must align with the last cumulative. All right, so those are the sweet 2 marks that we have there. Then we move on. They want us to draw the ogive or the cumulative frequency graph. Okay, so we have the intervals already indicated and everything. So the only thing I need to do is extract my cumulative. So we have 259. Okay, we're saying 259. And then we have 15, 20, 24, 30. Okay, 24 and a 30. Okay, so when you're plotting the cumulatives, we always use the upper intervals, meaning that we're going to use these numbers, the 20 and so on and so forth, and then we shall end up with a 10. So 20 is going to go with a 2. Okay, this is 2. And then next we have 5. So 30 is a 5. And then our 40 is going to be a 9. 9 is just below 10. And then 50 is going to be 15 just on the line. And then 60 is going to be 20. And then 70 is going to be a 24. Okay. And then 80 is going to be a 30. Does that make sense? It's going to be a 30. Somewhere there. Okay. So that is what we have according to our points. Then just connect those points with your free hand. Okay, I'll try to be as accurate as possible, but in as much as it may not really be possible. Okay, we have something like that. And then we have to foot this graph to the origin, which is the 10. So where's our 0? This is our 0 and the 10. So meaning that the graph must start from 0 and 10. All right, so that is our cumulative graph that the question wanted, and as much as it is not looking more of an S, but it's fine. Then 1.3, use the ogive to estimate how many learners obtain at least 54%. So the word at least, it simply means the minimum is a 54%. So we can have even more than 54%. So let's go to the max, okay? So with the max, we have 50. This is 52, this is 54, 56, 58, and then 60. So we're going to follow this line of 54 up until it meets the graph. Let's use which color? Let's use purple. So 54, draw the line. Okay. When I look at my ogive, it's meeting at this point here. Okay. And then I'm going to read off this value. Okay. This value is, I'm getting a 17 according to my graph. You could have gotten something that is close to that. Okay, so we have 17 learners that have less than 54. But now for us to get more than 54, we're going to get the maximum. Okay, whatever is above here is more than 54. So you're going to say 30 minus 17. Okay, 30 minus 17, that must give us something like 13. Okay, so we have 13 learners. Okay, so 13 learners have just above 54%. All right, then we move on to the next one. It is further given, okay, that the minimum mark is 12 and the range is 66. Use the grid provided to draw a box and whisker. So for us to get our box and whisker, remember box and whisker is a summary of the 5 numbers. Which 5 numbers must be the minimum? The Q1, the Q2, the Q3, as well as the maximum. But the question told us that the minimum is a 12. And then we need to get we were given the range. So we know range is maximum minus minimum, meaning that for us to get the maximum, we shall get our range plus the minimum. So if we get a 12 plus a 6, no, plus a 12. Oh, we're saying 12 plus 66, okay? So the range is 66 plus 12, which gives us 78%. So maximum is 78%. Okay, then we need to go get the Q1. So we're going to start by finding the positions, okay? So for us to get the Q1, we know that the position is going to be a quarter of n plus 1 or just a quarter of n, okay, whichever way you want to do it. So what is a quarter of 30? Because our maximum is 30. So 30 divided by 2 is giving me 7,5. Okay, it's giving me 7,5. Let's see. Okay, 7,5, 7,75. Okay, so this is the position of Q1. Okay, then for me to get my Q2, I will say a half of n plus 1 or a half of n, okay, which is like 15. This is the position. And then for me to get my Q3, I will say 3/4 of n plus 1 or 3/4 of n. So 3/4 of n, I'm getting 22,5 as the position. Okay. If you say 31, then it's going to be 23, something. Okay. So let's see. So if I use a quarter of n, why don't I use n plus 1? No, either way. Okay. So let's say our position is 7,5. Where do we find 7,5? This is a 6, a 7, and 7,5 is somewhere here. Then draw the line up until it meets the ogive, and then we read off the mark. So you can see that the mark is somewhere here before 14. Okay, so this is going to be 38. So our Q1 is a 38. Let me jot it down here. Okay, 38%. Then I need to go look for the Q2. We say the position is 15. So when I look at the 15, from our graph, we saw already that the 15 is aligning with the 50. Okay, so meaning that our Q2 is going to be a 50%. And then to get the Q3, we say the position is 22,5, or you can easily round it off to a 23. Okay, so 22, now this is 21, 22. Okay, meaning that it is somewhere here in the middle. Okay, in the middle, and then we're getting it somewhere here, and then we drop it down. So if I drop it down, I'm getting an answer between 60 and 70. So this 60, 62, 64, this is 66. Okay, so remember all these are just estimates of how we would have done this. So that's the 66%. Okay, so we just need to represent these numbers on the box and whisker. So 12 is the minimum. So 10, this is going to be our 12. And then 38, this is 30, is going to be somewhere here. Q2 is 50, somewhere here on the line of 50. And then 66 is going to be somewhere here. And then our maximum is 78, which is somewhere there. So draw your box with your ruler. Okay, we have something like that. And then connect the whiskers. Okay, so we have our box and whisker in that format. Okay, so that is question number 1. Question number 2, we're dealing with the bivariant data. Okay, so we're given that the town manager conducted a survey to measure the pressure of the sea level in his coastal city. The table and the scatter plot show the results of the survey. Good. Then they want us to determine the equation of the least square regression line. So remember how to use the calculator when you're punching in all these values. So remember the first variable will represent the x, and then the second variable will represent the y. But even the graph tells it all, that the pressure is on the y-axis and then the depth is on the x. So when I punch all of this into my calculator, and we know that the equation of the least square is given as a plus bx. Some people write it as bx plus a, no problem. So my a that I'm having is a 55,96 plus my b is a 22,81. Okay, so that is our equation. We'll get a mark for the a, for the b, and then rewriting it in the equation format. All right, then use the scatter plot to draw the line of least square regression. Okay, so for us to draw the least square regression line, remember sometimes we call it the line of best fit. So we have 55,96. So this 55,96 is like the y-intercept. So if this is 100, then 50 is going to be somewhere here. And then 55 maybe slightly somewhere there. Okay, then we need one other point, and the point that we need is the mean of the x values and then the mean of the y values. Okay, so if we can get this center point, and I'm having 17,8 as well as 462. So where is 17,8? This is 16, 17, 18. Okay, so somewhere here in the middle. Okay, so in that middle, we need 462. So 400, 420, 440, 460. Okay, so meaning that our point is somewhere there. Then just draw a line to connect just these two dots. Okay, if you can draw your line, I'm sorry, I don't have a ruler, but I'm just trying my best. So you'd have something like that. So that should be your line of best fit or your line of regression. So passing through the mean of x and y, and then passing through the y-intercept. So that is your line of best fit. Then write down the correlation coefficient. So my R I'm getting 0.95 something. When I round it off, I'm getting 0.96. Okay. And then 2.2, okay. Research was conducted to measure the testosterone in runners at the Olympic Games. The table below shows the 5 numbers or the 5 runners who were tested for that thing. And then the mean of the 5 numbers is 7,7, and then the values of the last 3 form an arithmetic Marawai. Can this examine? Well, this was paper 1. Now they are still haunting us with paper 2 things. It's not fair. All right, so they want us to get the values of K and P. Anyway, at least Pythagoras is not meeting with Shakespeare here, but at least the examiner is trying to haunt us. Okay, so what I'm gonna do, let me start by looking at the last 3 numbers. So P, 3,8 and then 4,3. So for us to have an arithmetic, the common difference needs to be the same. So 3,8 minus P, and then we know that 4,3 minus 3,8, I'll get 0,5, okay? So these two must be equated to each other. So 0,5 is the same as 3,8 minus P. Let's transpose, meaning that P is gonna be a 3,8 minus a 0,5, which gives me a 3,3. That's our P value. Okay, then let me bring in the aspect of the mean. Note that the mean is the summation of all items over the number of items. Meaning that if I get my 6,7 plus my 10, we square that, which is 144 divided by 169. Opposite of hypotenuse. So 169, 144 over 169, okay? So that is that. And then tan 360 minus theta, which quadrant is this? That is the 4th quadrant. And the tan, because we know that the tan is negative in the 4th quadrant, so it's a negative tan theta, which is a negative. Our tan is opposite of adjacent, negative 12 over 5. That's going to be the answer. Because the negative and negative will be a positive, but this negative makes the answer more negative. And then the cos of theta minus 135. Let's expand using the compound angles. So that's going to be cos theta, cos 135, plus the sine of theta, and then the sine of 135. So we know that 135 is in quadrant 2, which will be 180 minus a 45, okay? So we're going to reduce that, and it's going to be cos theta multiplied by the second quadrant. The cos is negative, so it's going to be negative cos 45. And then we are adding, okay, sine of theta, and then the sine of 45. So we know that the cos of 45 is 1 over root 2. Is that correct? It's 1 over root 2. But then our theta from here, our cos theta is negative 5 over 13. Okay, negative 5 over 13. We're multiplying it by the negative 1 over root 2. Plus, the sine is going to be opposite over hypotenuse, which is negative 12 over 13. We're multiplying it by 1 over square root of 2. Simplify this, that's going to be a 5 over 13 root 2. Okay. 5 over 13 root 2. And then I'm adding, no, I'm not adding, I'm subtracting. Okay, subtracting 12 over 13 root 2. So 7 minus 12, sorry, 5 minus 12, I'm going to get negative 7 over 13 square root of 2. So guys, that is what I'm getting as my final answer. Okay, so that is 5.1.3. Then 5.2. Let's see. 5.2. We've been told that if we have 2 cos, okay, this is 180 minus x multiplied by the sine of negative x, and then we are dividing this by the 1 minus 2 cos squared 90 minus x. Okay, so to answer this question very fast, we need to do the reduction. There's 2. This is second quadrant, the cos is negative, okay? So that's going to be a negative cos x. And then that's also going to be a negative sine x over, this is a manipulated format of the double angle of cos. So if I introduce a negative, it's going to be 2 cos squared 90 minus x, okay, minus 1, something like that. Meaning that I'm just going to write it as negative cos twice of 90 minus x, something like that. Then I know that in the top, it's going to change to 2 cos x sine x over, this is going to be the cos of 180 minus 2x. Okay, so that is a positive. We have a negative down there. Then if we move on further, what we are observing is that we're just going to reduce this to a sine 2 theta or sine 2x. And then this cos is negative in the second quadrant, which is going to give us a positive. So negative and negative, we get a positive, so cos 2x. Simplify sine over cos, we get a tan 2x. Please, you'll help me identify this, because I'm not sure whether I left out a negative sign or because this negative here is what I'm carrying over to this point. But I already know that this and this is a positive. And if it's a 180 minus, then the negative will give me a positive. So that's what I have, guys. Let's confirm with the negative signs. Then 5.3. They want us to calculate the value of the following expression without necessarily getting a calculator. So what I'm going to do is when you look at this pattern, I'm going to look at the first and then the last, okay? So what is 92 plus 178? This is 178 and then 92, okay? So 178 plus 92, we have a 270. Now this 270, if you're looking for the tan, okay? Let's say we have the tan of 270. How many 45s are in 270? So 270 divided by 45, we have 6 of them. So it would be the same as tan of 6 times 45s. And we know that the tan of 45 is just a 1, okay? Look at 94 and 176. So 176 plus 94, we still get a 270. 96 and whatever comes there, which is supposedly 174, you get a 270. Meaning that if we multiply these ones together, we're just going to end up with an answer of just 1. Okay, so 6.1, can we prove that this is the same as that? So what I'm going to do, I'll just use the compound angles and open that up. So it's 2 into, we have cos 45, cos x, minus sine 45, sine of x, but this must be squared. Okay, we're starting with the left-hand side. Then we can change this, or let's open it up further. Does it make sense? Let's change that 2 into 1 over root 2 cos of x minus 1 over root 2 sine of x. This is squared. We can't factorize yet. Let's open that. That's going to be a half cos squared x minus, we know that a half and a, 1 over root 2 and 1 over root 2, we get a half. When you multiply by 2, you end up with 1. So I'm just going to have cos x and then the sine of x. And then this last part will give me a half sine squared of x. Okay. And then when I open this up, I'll have a cos squared x. That's going to be negative 2 cos x sine x. And then that is a sine squared x. So I know that sine squared and cos squared will give me 1. And then I'm subtracting. This is a double angle of sine. So sine 2x, which is equal to the right-hand side. Okay, so that is question 6.1. 6.2, they want us to prove. We are given sine of this and that. Can we prove that it is equal to that? So still, we're going to do the same thing. The left-hand side first. Okay, so we have the sine of a minus b minus the sine of, is it a minus first or a plus? It's a minus and then we have a plus. This must give us 2 cos a sine b. Let's open up this. So you're going to have the sine of a cos of b minus sine of b cos of a, and then minus, okay, it's going to be sine of a cos of b plus sine of b cos of a. Let's open up here. Sine of a cos of b minus the sine of b cos of a. Open up this further, minus sine of a cos b minus sine of a cos of a. Okay, so this, let's what we cancel out. We have sine a cos b positive, sine a cos b positive. So this cancels that. This is a sine b. Oh, why is this? This is a b and a. Okay, this sine b cos a, sine b cos a. So we're going to have a negative 2 cos a sine b, just the same thing, which is equal to the right-hand side. Okay, that we've proved. Then 6.2.3, we need to simplify. Now, the fact that this question is under what we have in here. So I'm going to let my 4x to be a minus b. And then this is going to be a plus b. So we're saying that a plus b is 4x. And then a minus b is a 6x. If I add these two equations, meaning that twice a is, are those numbers correct? We said 4 and 10. 4 and 10. Why am I saying 6? At the 2, we have 14x, which means that a is going to be a 7x. And then b is definitely going to be a 3x. Then what this means is that where I see the sign of 4x minus the sign of 10x, I'm just going to equate it to this whole thing and say that it's going to end up with negative 2, the cos of a, which is 7x, and then the sine of b, which is 3x. So that is what I would have done for that part. And then hence so determine the general solution, or the solution. They want the solution. Okay, so with the solution, we need to get the definite values of x between 0 and 30. So we're saying that where there is sine of x, okay, sine 4x minus sine of 10x should be equivalent to sine 3x. Okay, so let's replace this with that. So meaning that negative 2 cos 7x sine 3x is equivalent to the sine of 3x. Let's transpose and move it that side. Meaning that's a negative 2 cos 7x sine 3x minus the sine of 3x is equal to 0. Okay, take out the sine 3x. Let's take out the negative. We're going to be left with a negative 2 cos of 7x minus 1 is equal to 0. Okay, then either the sine 3x is 0, and we know that the reference angle shift cos of 0 is going to be 0. Then we're going to have also an 8 and probably 360, but we're focusing on 30. So the first solution is going to be 0 plus k times 360. K is an element of integers. Will that help us? 180 plus k times 360, k is an element of integers. So this may not really help. Gives me a 60. Okay, meaning that 7x is going to be a 60 plus k times 360. K is an element of integers. Divide through by 7. I'll just leave it as a 60 over, yeah, I can just change it. What is 60 divided by 7? That gives me 8,57 plus k times 360, k is an element of integers. So this is not going to help us because this is a quadrant 1 angle. We're focusing on quadrant 2, which is the 120. Okay, 7x is going to be a 120 plus k times 360, divide through by 7. So 120 divided by 7, we're getting 17,14 plus k, that is going to be 360 times, no, 360 divided by 7, which gives us a 51,43. K is an element of integers. So if I replace k with 0, I'm going to have a 17,14. If I replace k with a negative, it's going to give me a negative, which I don't want. So this is more or less the solution that I'm getting, 17,14. Okay. Okay, so we have that 17,14, but we can also include the 0 one that we had here because these equations were giving us a 0 plus k. So if k is a 0, which means 0 will be a solution. So the best solutions will be 0 and then 17,14. All right, so we move on to question number 7. We have two graphs, F and G, okay? Then they want us to write down the range of F. So one thing we need to know is that initially, okay, if we have a 2 cos, the range was supposed to be -2 and +2. But now since we are adding a 1, it's more like +1, then +1. So it's a 3 and then -1. So meaning that y is between -1 and the +3. That is it 7.1? Yes, that is 7.1. Then 7.2, they want the period of G. So when you look at G, how many graphs can we see? This is one graph. Those are 2 graphs, okay, in a space of just 360, meaning that our period is just 180. So it takes us just 180 degrees to get a full graph. Alternatively, get the 360 divided by this coefficient of x. We must get the same thing. And then 7.3, they want us to get the values of x in the interval for which f is increasing. So f is increasing from this point up to this point here. It's just increasing. So we're going to say that -180 is less x and then it's less 0. So we do not put the equal signs because at -180 and at 0, the graph is typically just changing the direction. All right. Then we have next 7.4. Use the graphs, okay, to determine values of x in which g of x times f prime of x is less than 0. So f prime is more like the first derivative or the gradient, okay, in this case. So if I have this as a plus and this as a minus, or if I have this as a minus and that's a plus, so where do I find the g to be above while f is decreasing? Above and decreasing. So it's decreasing in this area and it's above somewhere here, okay? Then the other section is where do I find the g below while this one is increasing? So g is below here while the other one is decreasing. So we can see the region of interest, this one and this one. But we know that if this is negative 180, this is supposed to be, this is the graph of g, which one is equivalent to 0, which is a 90. So this is going to be like a negative 90, and then this is going to be like a positive 90. So the answers for that is going to be negative 90 is less x is less positive 90. So that is how we would have answered that 7.4.1. Then 7.4.2, where do we find the cos of x to be less or equal to negative a half? Now, we're looking at the graph of cos, which is the f. So if this is a 1, negative 1, it should be somewhere here. Okay, we just want the x values. So when you punch that into your calculator, the shift cos of negative a half, okay, is going to give us a 120. So if that's a 120, even this side, it must be a negative 120. So the region of interest is below, okay, below a half. So this area and this area. So the answers for that will be negative 180 is less or equal to x, less or equal to negative 120. And then that side, we shall have a 120 is less or equal to x, less or equal to positive 180. So that is how I would have obtained that. Then 7.5, the graph of g is shifted 45 degrees to the right. Can we determine the new graph of h in a simplified form? So what this means, we shifting g, and g is what? The sine 2x. So it's going to be the sine of 2 into x minus 45. Change this or simplify that, we're going to have the sine of 2x minus 90. When you take out the negative, it's going to be 90 minus 2x. Then it's going to be negative sine of 90 minus 2x. This is a complementary angle, meaning that our h of x should be negative cos of 2x. And then this is what the question wanted for that part. All right, then question number 8, in the diagram, A, B, C lie in the same horizontal plane with AB being the same as AC. D is directly above A such that twice AD, okay? So in other words, if we have 2P is the same as a BC, then they want us to express AB in terms of P and Y. This is AP. But we're seeing that this is a right angle triangle, so we can use our trig ratios. And the ratio that combines adjacent and the opposite is the tan. So I would say that the tan of y is equivalent to the opposite, which is P, over the adjacent, which is AB. Let's make AB the subject. AB is going to be P over the tan of y. That is 8.1. Then 8.2. They're asking us to show that cos of x is equivalent to the tan of y. So cos of x being equivalent to the tan of y, meaning that I'm going to use AB, okay? Because I know that this is x, this must also be x, meaning that this entire thing should be the same as 180 minus 2x. So we're gonna say that BAC is 180 minus 2x, angles in a triangle. Okay, so if I use BC over BAC, it should give me the same as AB over ACB. This is the sign. I'm using the sign rule, guys, forgive me. Okay, so our BC, they told us is twice what? P. So twice P over the sine of 180 minus 2x is equivalent to AB, which we found as a P over the tan of y. You're dividing it by the sine of x. Okay, let's simplify this. So 2P is going to be equal to the sine 2x is equal to P over the tan of y and then the sine of x. We can cancel this P and that P. We can do the cross multiplication, meaning that twice tan y sine x is the same as sine 2x. Let's break down the sine 2x, which is going to be 2 sine x cos x. Okay, then from that point, we can see that the 2 cancels the 2. This sine x cancels the sine x. We have the tan y being equal to the cos of x. That's what we had to do. Then 8.3, they want us to get the size of y if x is 16. So meaning that the tan of y is equal to the cos of 16. So tan y gives us a half, okay? Then for us to get y, it must be the arctan. Okay, shift tan over half. Okay, so shift tan over half, which is 26, that's gonna be 57 degrees. Okay, so that is what I'm getting for 8.3. All right, then we move on to the last question 9, okay? Provide reasons for the statements for question 9 and 10. Where is question 10? These people, where did they get this paper from? Same for question 9 and 10. Hey, did we miss out a question? But the page numbers are just in order. We move on. So in the diagram, DEF is drawn, line GH, okay, is parallel and intersects that, blah, blah, blah. They are parallel, perfect. DG is 2 to 5, okay? Then they want us to write down the ratio with reasons of HF to EF. So we know that if we have GF over DG must be the same as HF over EH, proportionality theorem. So that's also going to be the same as 2 over 5. Okay, so proportionality theorem, because these lines are parallel. Then they want us to find EH if EF is 21. So we're saying if the whole of this is a 21, can we find EH? So there are 2 ways of doing this, but let me choose the longer way, or the shorter way, sorry. So I'm going to say we're looking for EH. So I'll say 5 over this entire thing, which is a 7. So 5 over 7 is equal to our EH over 21. So EH becomes 5 over 7 times 21, and that becomes 15 centimeters. Okay, so that is how I would have approached it. Alternatively, people would have said this is X, and then that is 21 minus X, and then you solve it. You're still gonna end up with the same thing. Then write down the triangle, which is similar to FGH. So this big triangle, the Makul one, because this is common, this is the same as that, that is the same as that. So since they started with F, I will also start with F. G must go with D, and then H must go with E. So that is the triangle because of angles. Then hence, I'll calculate the value of GH over DE. GH over DE. So we're looking at the shorter side over the longer side. So we're comparing the triangles. Okay, so what I can do, I can look at this and say that if I have 2 over 7, okay, just looking at 2 divided by entire side, which is 7, should be equivalent to the shorter side, which is GH, over the longer side, which is DE. So the ratio that they want is 2 over 7. Okay, so that is 9.1.4. Then 9.2. Okay, the diagram POL is the diameter of a larger circle with center O. TMR is the diameter of the smaller circle with center M. The two circles intersect at L and R. PLK is a tangent, okay. The smaller circle, and TR is a tangent to the larger circle. Okay, the larger circle is having this tangent. Okay, and then the other one is having a tangent at this point. Then the question is, can we prove that LT is parallel to PR? LT, okay, let me just highlight this. LT is parallel to PR. Okay, so for us to have parallel lines, remember what we need to look out for. We need to look for corresponding angles, alternating angles, as well as the cointerior. But in this case, the cointerior will not apply. So let me use the tan code, because I know that this angle is going to be the same as that. Okay, so I'll say that L1 is the same as R1. Reason, that's a tan code. Then if I look at the bigger circle, we're saying that R1 is going to be the same as P. That's also a tan code theorem. And then we can say that since L1 is the same as P, therefore LR must be parallel, no, it's LT. Okay, so LT must be parallel to PR. Reason is the converse of the corresponding angles. So that is what we had to do with 9.2.1. And then 9.2.2, okay, 9.2.2, they are telling us that LORM is a cyclic chord. We must prove that L, O, R, and M. Okay, so if I connect this, so the only thing I need to do in this case is that I need to prove either this angle is the same as this, or this angle is the same as that. So whichever one that I prove, I should be able to get that. I don't know why they're giving it 5 marks. They're telling us that this line is LT, okay, is parallel to OM. So these lines are parallel. So if they are parallel, what do we see? So you're gonna say that this angle here is also gonna be the same as O1, okay? So what I'm saying is that P, okay, P is the same as O1. Reason those are corresponding angles because OM is parallel to PR. Okay, so if this angle is the same as that, we can also see, or we proved that R1 was the same as P. Okay, but R1 is the same as P. We proved that earlier on. And if that is true, simply means that this angle, that since R1 is the same as O1, because we have this kind of a bow tie, okay? Therefore, L, O, R, M is a cyclic chord. And the reason is the converse of angles in the same segment. Angles in the same segment, or angles subtended the same whatever. So that is what we were supposed to do in that case. So guys, I'm not seeing question 10. Let's see with this, because the instructions said we have 10 questions, and then I'm not seeing that. So unfortunately, I'll have to stop at that, and then wish you all guys the best. So in this paper, I can write it as yeah, 90. It's fairer compared to paper 1. All the best, guys, in your remaining examinations. I sign. Yes, hello. Welcome to yet another episode where we shall be looking at the proposed memorandum. So, okay, so this paper had 11 questions, okay? According to the instructions, we have to answer all of them. Answers only will not guarantee full marks. Okay, we can use a calculator, round off to decimal places. Diagrams are not necessarily to scale. No pages may be torn. Okay, we're not going to do that. Answers must be written in black or blue ink. Okay. Indicate questions you've answered by drawing the star. No, we're not going to do. We're going to answer everything. Okay. Draw a neat line through any work that must not be marked. All right, so those were the instructions. Let's just dive into the paper. All right, so question number one, they're telling us that the histogram below shows the marks in percentage for the grade 11 learners in their November 2024 examination. Okay, so the minimum mark is 10, or we're looking at the minimum or the lower class interval is a 10. Then 20, so between 10 and 20, we have 2 learners. Between 20 and 30, we have 3 learners, and so on and so forth. So meaning that the highest mark that could possibly have been achieved was 80%, okay? Then they want us to complete the table below. So this table is showing us the frequency as well as the cumulative frequency. So let's start with the frequency. So we have a 2, okay? Then we have a 3, and then we have a 4, and then we have 6, 5, 4. It's a 6, 5, 4, and a 6. Then for us to get the cumulative, we know that the first cumulative should be the same as the first frequency, which is a 2. And then we plus 2 plus 3 is a 5. Then 5 plus 4 is going to give me a 9. Then 9 plus 6 is 15. 15 and 5 is 20. That's a 24. Then that is a 30. So the total of the frequencies here, we must get 30. That must align with the last cumulative. All right, so those are the sweet 2 marks that we have there. Then we move on. They want us to draw the ogive or the cumulative frequency graph. Okay, so we have the intervals already indicated and everything. So the only thing I need to do is extract my cumulative. So we have 259. Okay, we're saying 259. Then we have 15, 20, 24, 30. Okay, 24 and a 30. Okay, so when you're plotting the cumulatives, we always use the upper intervals, meaning that we're going to use these numbers, the 20 and so on and so forth, and then we shall end up with a 10. So 20 is going to go with a 2. Okay, this is 2. And then next we have 5. So 30 is a 5. And then our 40 is going to be a 9. 9 is just below 10. And then 50 is going to be 15, just on the line. And then 60 is going to be 20. And then 70 is going to be a 24. Okay, and then 80 is going to be a 30. Does that make sense? It's going to be a 30. Somewhere there. Okay, so that is what we have according to our points. Then just connect those points with your free hand. Okay, I'll try to be as accurate as possible, but in as much as it may not really be possible. Okay, we have something like that. And then we have to foot this graph to the origin, which is the 10. So where's our 0? This is our 0 and the 10. So meaning that the graph must start from 0 and 10. All right, so that is our cumulative graph that the question wanted, and as much as it is not looking more of an S, but it's fine. Then 1.3, use the ogive to estimate how many learners obtain at least 54%. So the word at least, it simply means the minimum is a 54%. So we can have even more than 54%. So let's go to the max, okay? So with the max, we have 50. This is 52, this is 54, 56, 58, and then 60. So we're going to follow this line of 54 up until it meets the graph. Let's use which color? Let's use purple. So 54, draw the line. Okay. When I look at my ogive, it's meeting at this point here. Okay, and then I'm gonna read off this value. Okay, this value is I'm getting a 17 according to my graph. You could have gotten something that is close to that. Okay, so we have 17 learners that have less than 54. But now for us to get more than 54, we're gonna get the maximum. Okay, whatever is above here is more than 54. So you're gonna say 30 minus 17. Okay, 30 minus 17, that must give us something like 13. Okay, so we have 13 learners. Okay, so 13 learners have just above 54%. All right, then we move on to the next one. It is further given, okay, that the minimum mark is 12 and the range is 66. Use the grid provided to draw a box and whisker. So for us to get our box and whisker, remember box and whisker is a summary of the 5 numbers. Which 5 numbers must be the minimum? The Q1, the Q2, the Q3, as well as the maximum. But the question told us that the minimum is a 12. And then we need to get we were given the range. So we know range is maximum minus minimum, meaning that for us to get the maximum, we shall get our range plus the minimum. So if we get a 12 plus a 6, no, plus a 12. Oh, we're saying 12 plus 66, okay? So the range is 66 plus 12, which gives us 78%. So maximum is 78%. Okay, then we need to go get the Q1. So we're going to start by finding the positions, okay? So for us to get the Q1, we know that the position is going to be a quarter of n plus 1 or just a quarter of n, okay, whichever you want to do it. So what is a quarter of 30? Because our maximum is 30. So 30 divided by 2 is giving me 7,5. Okay, it's giving me 7,5. Let's see. Okay, 7,5, 7,75. Okay, so this is the position of Q1. Okay, then for me to get my Q2, I will say a half of n plus 1 or a half of n, okay, which is like 15. This is the position. And then for me to get my Q3, I will say 3/4 of n plus 1 or 3/4 of n. So 3/4 of n, I'm getting 22,5 as the position. Okay. If you say 31, then it's going to be 23, something. Okay. So let's see. So if I use a quarter of n, why don't I use n plus 1? No, either way. Okay. So let's say our position is 7,5. Where do we find 7,5? This is a 6, a 7, and 7,5 is somewhere here. Then draw the line up until it meets the ogive, and then we read off the mark. So we can see that the mark is somewhere here before 14. Okay, so this is going to be 38. So our Q1 is a 38. Let me jot it down here. Okay, 38%. Then I need to go look for the Q2. We say the position is 15. So when I look at the 15, from our graph, we saw already that the 15 is aligning with the 50. Okay, so meaning that our Q2 is going to be a 50%. And then to get the Q3, we say the position is 22,5, or you can easily round it off to a 23. Okay, so 22, now this is 21, 22. Okay, meaning that it is somewhere here in the middle. Okay, in the middle, and then we're getting it somewhere here, and then we drop it down. So if I drop it down, I'm getting an answer between 60 and 70. So this 60, 62, 64, this is 66. Okay, so remember all these are just estimates of how we would have done this. So that's the 66%. Okay, so we just need to represent these numbers on the box and whisker. So 12 is the minimum. So 10, This is going to be our 12. And then 38, this is 30, is going to be somewhere here. Q2 is 50, somewhere here on the line of 50. And then 66 is going to be somewhere here. And then our maximum is 78, which is somewhere there. So draw your box with your ruler. Okay, we have something like that. And then connect the whiskers. Okay, so we have our box and whisker in that format. Okay, so that is question number 1. Question number 2, we're dealing with the bivariant data. Okay, so we're given that the town manager conducted a survey to measure the pressure of the sea level in his coastal city. The table and the scatter plot show the results of the survey. Good. Then they want us to determine the equation of the least square regression line. So remember how to use the calculator when you're punching in all these values. So remember the first variable will represent the x, and then the second variable will represent the y. But even the graph tells it all, that the pressure is on the y-axis and then the depth is on the x. So when I punch all of this into my calculator, and we know that the equation of the least square is given as a plus bx. Some people write it as bx plus a, no problem. So my a that I'm having is a 55,96 plus my b is a 22,81. Okay, so that is our equation. We'll get a mark for the a, for the b, and then rewriting it in the equation format. All right, then use the scatter plot to draw the line of least square regression. Okay, so for us to draw the least square regression line, remember sometimes we call it the line of best fit. So we have 55,96. So this 55,96 is like the y-intercept. So if this is 100, then 50 is going to be somewhere here. And then 55 maybe slightly somewhere there. Okay, then we need one other point, and the point that we need is the mean of the x values and then the mean of the y values. Okay, so if we can get this center point, and I'm having 17,8 as well as 462. So where is 17,8? This is 16, 17, 18. Okay, so somewhere here in the middle. Okay, so in that middle, we need 462. So 400, 420, 440, 460. Okay, so meaning that our point is somewhere there. Then just draw a line to connect just these two dots. Okay, if you can draw your line, I'm sorry, I don't have a ruler, but I'm just trying my best. So you'd have something like that. So that should be your line of best fit or your line of regression. So passing through the mean of x and y, and then passing through the y-intercept. So that is your line of best fit. Then write down the correlation coefficient. So my R I'm getting 0.95 something. When I round it off, I'm getting 0.96. Okay. And then 2.2, okay. Research was conducted to measure the testosterone in runners at the Olympic Games. The table below shows the 5 numbers or the 5 runners who were tested for that thing. And then the mean of the 5 numbers is 7,7, and then the values of the last 3 form an arithmetic mara y. Can this exam? Well, this was paper 1. Now they are still haunting us with paper 2 things. It's not fair. All right, so they want us to get the values of K and P. Anyway, at least Pythagoras is not meeting with Shakespeare here, but at least the examiner is trying to haunt us. Okay, so what I'm gonna do, let me start by looking at the last 3 numbers. So P, 3,8 and then 4,3. So for us to have an arithmetic, the common difference needs to be the same. So 3,8 minus P, and then we know that 4,3 minus 3,8, I'll get 0,5, okay? So these two must be equated to each other. So 0,5 is the same as 3,8 minus P. Let's transpose, meaning that P is gonna be a 3,8, minus a 0.5, which gives me a 3.3. That's our p-value. Okay, then let me bring in the aspect of the mean. Note that the mean is the summation of all items over the number of items. Meaning that if I get my 6.7 plus my 2k plus 2.4 plus my p, which I got as 3.3, plus the 3.8 plus the 4.3. Okay, when I divide this by 5, okay, I must get a 7.7. Okay, so let me simplify my decimals and like terms. Okay, so this is a 2k, okay, plus when I add up all the other things, I'm getting a 20.5. Okay, this is going to be the same as 7.7. Then I'm multiplying it by 5 because I need to get rid of this denominator. So times 5 and then times 5. Okay, so I'll have to move the 20.5 that side. So it's going to be a 2k. It's going to be a 38.5 minus a 20.5. So 2k becomes 18. Divide both sides by 2. And then k becomes a 9. All right, so that is how we would have answered this. Ne? Then question number 3, which is the analytical geometry. We've been told that in the diagram, triangle ABO is drawn, okay? E is the midpoint of AB, which is produced to C, okay? A is the x-intercept, and C is a 0 and 10, which is the y-intercept. Line EF, okay, is parallel to the x-axis, so meaning that if this is a midpoint and these lines are parallel, which means even this one is a midpoint. Eh? Then AB is perpendicular to OB. Okay, we see that 90, perfect. The angle of inclination is 108.43, beautiful, indicated. Then the angle formed by AC and the y-axis is alpha. Then 3.1. They want us to get the gradient of AB. So we don't have any coordinates here on AB, but we have the angle of inclination. So we know that M is equal to the tan of theta. Okay, this is the formula for the gradient in case we don't have the coordinates, for as long as we have the angle of inclination. So it's going to be the tan of 108.43. And when I punch this into the calculator, remember it is tan, not the arctan. Okay, 43, that is giving me negative 3,000, so meaning that our gradient is a negative 3. Then 3.2, we must find the equation of AB. Okay, so what do we know about AB? We only have one point, which is the y-intercept, okay? And this y-intercept is at a 10. We don't know the gradient of this, but we have the gradient of BO, okay? So since the lines are perpendicular, we know that the gradient of AB multiplied by the gradient of OB, it should give us a negative 1. Now, since the gradient of OB is a 3, which is negative, we're going to say that MAB is going to be negative 1 over the gradient of OB, which is a negative 1 over negative 3, which becomes 1 over 3. Okay, so we have our gradient, and we already have the y-intercept, meaning that y is going to be 1 over 3x plus a 10. Okay, so that is what the question technically wanted. Show us this multiplication of perpendicular lines, and then the answer. All right, then calculate the coordinates of B. Coordinates of B, so we know that B is a point where the two graphs are meeting, or the two lines are intersecting. And at this point, the two lines are equal to each other, meaning that if we get the equation of, we said 1 over 3x plus 10, and then we need the equation of this, we got the gradient as a negative 3, okay? But the y-intercept is a what? Is a 0. So the equation of OB is simply going to be negative 3x. Then we solve these two simultaneously. So what I'm going to say, I'll say that the equation of AB equated to the equation of OB. So 1 over 3x plus 10 should give me negative 3x, since everything is yy. Let me collect the like terms. I'm gonna say 1 over 3x plus a 3x is equal to negative 10. When I do my magic here, I have 9x plus 1x, which is a 10x over 3 is equal to negative 10. Cancel the 10s. So it's like a third of x is negative 1, and then x becomes a negative 3. So if x is a negative 3, let's use the other equation of negative 3x to find the y. So it's a negative 3 times a negative 3, which becomes a 9, meaning that b is a negative 3 and 9. Okay, so that is how I would have gone about this to get the 3 marks. Then they want us to get the length of BF. Okay, the length of BF. So we say this is a negative 3 and 9. Length of BF, where's BF? So from here up to there. But we don't know the coordinates of F. So the quick way, since we are saying that F is a midpoint, né? Okay, so step number 1, we're gonna say that F is a midpoint of the side B what? BO. Reason being, we have the midpoint theorem. Okay, so then if that F is a midpoint, what I can do is I can simply calculate the distance of OB, and then I divide it by 2. So if my O is a 0, 0, and then my B is a negative 3 and 9, let me use the distance formula, which is going to be x1 minus x2 squared, and then y1 minus y2 squared. Okay, let's do the substitution. That's going to be 0 minus minus 3 squared plus 0 minus 9 squared. That's going to give me a 9 plus 81, which is the square root of 19. Okay, so if the square root of 90 is going to give me 3 square root of 10. So this is the distance OB. But BF is a half of OB, meaning that 1 over 2 times 3 root 10. So we get 3 over 2 square root of 10 units. So I would prefer to leave it like that and not necessarily put it into decimals. But for people that love decimals, if we were to use decimals, what would be the answer? It would be a 4,74 units. Okay, so that is 3.4. Then 3.5, we want the area of CBO. Okay, I'll use this. The area of CBO. What do we notice? What do we notice? So we notice that this is a right angled triangle. Okay. Now, what I can do, there are 2 ways to this. How many marks is this question? It's 4 marks. If B is negative 3 and 9, I have a quick way of doing it, but I'll try to check it with a longer way to see if we get the same answer. So the quick way is for me to focus on this right angled triangle and create another 90 if this is a perpendicular. If this is my height and the whole of this is my base. Okay, meaning that our base is gonna be 10 units because from 0 up to here, that's basically 10 units. Then the distance from this line up to the B is going to be 3 units. Okay, distance is never negative, so that's 3 units. So meaning that our area is going to be a half times the OC, then multiplied by the perpendicular height. So a half times 10 multiplied by 3, which gives me 15 units squared. I feel this is the quickest. Okay, so alternatively, somebody could have said that it is a half this being the base, OB, and then the height being the BC. Okay, so if that is the case, we have the distance of OB, okay, we got it as a 3 root 10. Okay, let me just, okay, 3 root 10. The only thing that is shorting is the distance of BC. So for us to get BC, 0 minus 3 is gonna be a 3 squared plus 10 minus 9 is gonna be a 1 squared. So that is a 3 squared, which is 9 plus 1, which is root of 10. Okay, so that is a root of 10. Then I have a half times 3 square root of 10 times the root of 10. Okay, what does this give us? So root of 10 and root of 10 gives us a 10. So it's going to be like 30 divided by 2. And that is 15 units squared again. So I'll take my approach to be the quickest, okay? So that is that for 4 marks. The examiners are now generous. Eh? Alala. All right, 3.6. Let's find the alpha, okay? They want us to get the size of alpha. Now, let me just erase this out so that we make more sense out of this. Okay, so for us to get the alpha, one thing I want us to do is we know that this is a 90. Okay, if that's a 90, because between the y and the x, we can find this angle here, which angle is BOC. Okay, then we know that this is also a 90 because these angles are just on a straight line. And then we can find this angle here, which angle should be vertically opposite. So we shall start with BOC. Okay, we're saying BOC is going to be 108,43 minus 90. 108,43 minus 90 gives me 18,43 degrees. Okay, then I know that my CBO is a 90 angles on a line, or some people will say adjacent supplementary angles, which is correct. And then BCO is going to be a 90 minus 18,43 because angles in a triangle must add up to 180. Okay, when I say 90 minus 18,43, that gives me a 71,57 degrees. And then we're going to say alpha is 71,57 because they are vertically opposite. So that is how I would have worked that out. Or if you have any other alternative of how to do that, we would gladly appreciate it. Okay, but then that is how I would have taken it. Okay, then that is the end of question number 3. Question number 4 with the circle geometry, no, the analytical geometry with circles. Okay, what are they telling us? We're being told that on the diagram, P is negative 3, 4, is the center of a circle that is passing through B, which is the x-intercept. And then T is the origin. And then a second circle Q is having this much of an equation. Points R and S lie on the circle. Okay. AS and AR are both tangents, so tangents from a common point must be always equal. B is the x-intercept, we saw that, of AS. All right. First things first, they want us to get the equation of P. What do we know about P? They told us this circle is passing through the origin, meaning that the distance between P and O is our radius. Okay, so we're going to say that our OP, okay, OP is going to be the square root of 0 minus 3 squared plus 0 minus 4 squared. This gives us a 5. Okay, so if that is the radius, we know that the general equation is x minus a squared, and then y minus b squared is equal to r squared. So our x is a negative, meaning we're going to switch the sign to a positive. So x plus 3 squared plus y minus 4 squared. When you square 5, we end up with a 25. So that is our equation for circle P. Then OT is a diameter. Okay. So if we connect this to that, that is our diameter. Perfect. So that's a 5 and that's a 5. They want us to determine the coordinates of T. Okay. So what we know about this P being the center and this being the end, for as long as the diameter, this becomes the midpoint. And we're going to use the midpoint formula. So if our O is 0, 0, our P is negative 3, 4, our T is XY. So we're going to say X plus a 0 over 2 must give us this midpoint negative 3. Cross multiply, X is a negative 6. Do the same with the Y. Y plus 0 over 2 should give us a 4. Cross multiply, Y is 8, meaning that T is going to be a negative 6 and 8. Okay, paper is still flowing, guys. Ne? Yes. Then 4.3, they want us to get the coordinates of Q. What do we know about Q? Q is another circle whose equation we know. Okay, so what we're going to do, we just have to complete the squares there. So it's x squared, okay, minus 12x plus y squared plus 12y plus 54 is equal to 0. That is the equation. Okay, then what I'm going to do, I'm going to move this 54 to that side because I prefer working with it on that other side. So it's going to be x squared minus 12x plus y squared plus 12y is equal to negative 54. Okay, so what I'm going to do, complete the squares, open your bracket, that is x. A half of this is negative 6. Okay, so negative 54, I'm just going to plus with a 6 squared. Okay, because I said a half of 6. And then plus, open the bracket for y. This is y. A half of this is going to be a positive 6 squared, and then I'll plus it that side. Okay, then meaning that we have x minus 6 squared, and then y plus 6 squared. When I simplify this side, I have a negative 54 plus a 36 plus 36, which is a 72. So 72 minus 54, I get 18. What did the question ask for? Coordinates of Q. Since Q is the center, Q is going to be a 6 and a negative 6. All right, so that is how I've gone about that. Then determine the equation of AS. What is AS? AS is a tangent, okay? For us to get the equation of the tangent, we need to start by getting the gradient of QS. All right, so our Q, we said it's a 6 and a negative 6. Is that correct? Okay, and then our S was a 3 and a negative 9. So let's get the gradient of that. So gradient of QS is going to be the change in Y over the change in X. So negative 9 minus minus 6 over 3 minus 6. This is a plus 6. Okay, from the top, I'll get a negative 3 over, this is going to be a negative 3. Does it make sense? And then I'll end up with a 1. Let's see the direction of that line. It's positive. Okay, perfect. So if that is 1, meaning that the gradient of AS is going to be a negative 1, since the gradient of 1 times the gradient of AS should give us a negative 1. The lines are perpendicular. Ne? Reason, we're going to say the tan perpendicular to the radius. All right, so we have our gradient. We can use the point S, which is 3 and negative 9. Okay, at 3 and negative 9, we can say y minus y1 is equal to m into x minus x1. So y minus minus 9 is equal to a negative 1 into x minus a 3. Let's open up. That's going to be a negative x plus a 3. Let's move this one that side, meaning that our y is going to be a negative x minus a 6. So that is how I would have obtained those sweet 5 marks. Okay. So if I've left out something, please just slot it on the comment section and let's continue cruising. 4.5, identify the type of quadrilateral that ASQR and substantiate. Shakespeare is back. Substantiate. In other words, give a reason for your answer. Oh, so ASQR. Okay, so what I'm seeing is that with ASQR, one thing we say that this is a radius, this is also a radius. Okay, tangents from a common point are equal, meaning that this shape is definitely a kite. Reason, we have two pairs of adjacent sides that are equal. All right, so we're going to say the shape is a kite for 1 mark, and then for the substantiating, we are saying two pairs of adjacent sides. Adjacent simply means next to each other. Adjacent sides are equal. Okay, in other words, if you don't want to say that, then you can give the sides themselves. Someone would say AS is equal to AR, and then QR is equal to SQ. It's fine, no problem. All right, so that is 4.5, and then 4.6, determine the scale factor. Okay, determine the scale factor K by which the radius of the circle with Q should be increased such that the two circles must touch. Okay, scale factor with which the radius of the circle with Q must be increased so that the circles should touch. Now, which circle are we looking at? We're looking at Q. In other words, this Q must be increased. Okay, but we want to see by how many times. So if we increase it, the question never told us how many points, but they are telling us they must touch once. Okay, all right, that's perfect. So for it to touch once, okay, we're saying that for it to touch once, the distance OQ is what we're gonna be looking at. Let's get our radius OQ and then compare it to the radius. If this is, let's say, I'll say QR, and then we see how many times. So since we say that O is 0, 0, and then Q, we said it was a 6 and negative 6. Let's get the distance, the radius OQ. So that's going to be x1 minus x2 squared plus y1 minus y2 squared. Okay, square root, that's going to be a 0 minus a 6 squared plus a 0 minus minus 6 squared. So that's going to be a 36 plus another 36 and the square root, which gives us a 70 what? A 72. Now we know that square root of 72 is going to be, so we're saying R or Q is going to be 6 square root of 2. Okay. Then initially, okay, the initial radius RT, I don't need to go there. Okay, the initial radius RQ, sorry. Remember, it was something like 18. R squared is 18. From the equation that we worked out, where was the equation? Here is the equation, okay? R squared is 18. So I'm saying that my RQ is going to be the square root of 18. And square root of 18 gives me just 3 square root of 2. Okay, then let me try to divide these two. So 6 square root of 2 divided by 3 square root of 2. This cancels that, and then that is 2, meaning that the scale factor K is 2. So scale factor K is a 2. You must increase it by 2 times, and then we shall get what is desired. All right, so that is how sweet question 4 was. Question number 5, which is the trig. All right, let's start with this. They're telling us that the sine of beta is positive 12 over 13, where tan beta is less than 0, meaning that the tan is negative. The sine is positive. With the aid of a diagram without a calculator. Okay, so for 4 marks, they're going to give us 2 marks for the sketch first. Ne? So we know that sine is positive in the first quadrant and the second quadrant. But between the two quadrants where sine is positive, where is the tan negative? Definitely the second quadrant. So that is where our sketch should be. Okay, so let's indicate from our dear friend, so Cato, we know that the sine is the opposite over the hypotenuse. So this is a sweet 12 over the 13. Okay, so we can say this is our beta, no stress. And then we need to find the missing side. So use your Pythagoras. So if that is O, call this a P, call this a T, no stress. Tell us that our OT is going to be the square root of 13 squared minus 12 squared. That's going to give us a plus or minus 5. But the fact that OT is on the left-hand side of the Cartesian, so this is going to be a negative 5. So that's all you need. You probably have 1 mark for that and then 1 mark for the Pythagoras. Okay. Okay, so we move on. They want us to answer and find sine 2 beta. Okay, so this is the double angle of sine, which can be expanded as 2 sine of beta cos of beta. Okay, 2 times sine beta we were given. It's a 12 over 13. Cos of beta is going to be negative 5 over 13. So 12 and 2 is 24. 24 and 5 is going to be 120. 13 and 13 is 169. There's nothing common then. I want to believe so. Okay, 120 over 169, nothing common. Just leave it like that, please. I know temptation sometimes are strong, and then somebody will be convicted to change this to a decimal. That's how they're going to get you, that you use the calculator. So you leave your answer just the way it is here. All right, 5.2. I'm telling us that the compound formula for cos is given as that. They want us to use that identity to deduce the sine of alpha minus beta. Now, from our complementary angles, we know that if we have the cos of, let's say, 90 plus theta, this gives us a negative sine of theta, or 90 minus will give us a positive sine. So I'm going to use the 90 minus this complementary approach and then get to that. So this is going to be the cos, okay? I'll say 90 minus, we have alpha minus theta. If you simplify this, you're definitely gonna get your sine, okay? Then I'll regroup this and say if I have my cos, okay, of a 90 minus alpha, and then negative and negative, I'll have a plus theta. And then I'm gonna open this up using this identity that I was given. Okay, so I'll have the cos of 90 minus alpha, the cos of theta. Since I'm adding, I'll subtract. And then I'll have the cos, no, it's supposed to be a sine, okay, because the formula says sine. So the sine of 90 minus alpha multiplied by the sine of theta. So compound angles, cos of 90 minus, gonna give us a sine of alpha, that's a cos of theta, minus sine of 90 minus, that's gonna be a cos of alpha, then the sine of theta. So this is basically what we have here. But remember we said this gives us the sine of alpha minus theta if you do reduce the complementary angles. So that is how we would have gone about with 5.2.1. The key part is this 90, okay? And then this bracket. If you can introduce the 90 and combine with the bracket, the rest is history. Hence, so otherwise, you'll evaluate this. Okay, so I found this a bit challenging, but one thing that I saw, since they said hence, it's just a tip of the iceberg to say that we have to use what we already have, okay? But we have a sine and a cos, then a cos and a sine. So if this is a 76, and this is a 14. How does 76 and 14 compare? When I plus the two, I see that they give me a 19. Same applies with the 44 and the 46. So what I'm going to do, I know that sine of 76 could be the same as a 90 minus a 14. Okay. Then when I look at the 46, it could be the same as a 90 minus 44. So if I'm to replace this, you don't have to show it, but I need to show people why we are using that. It's saying minus sine 14, and then it's going to be the sine of 90 minus 14. You could also use the cos aspect. You would also get the same thing. So this is going to give me the cos of 14, the sine of 44, minus the sine of 14, and then cos of 44. We said 90 minus 44. Does that make sense? Does that make sense? Yeah, it makes sense because 90 minus 44 gives us a 46. Perfect. So we have 14 and 44. Then what I'll do, I'll say is the sine. I'll say 44 minus 14. I'll presume that this is my theta and probably that's my alpha. Okay, or you can do it the other way around. Okay, so if I'm to look at the way the question was presented, the sine comes first and then the cos, meaning that the 44 is the alpha, then that is the theta. So 44 minus 14 gives me a sine of 30, and that becomes a half. I believe if somebody had switched them around, you were going to get a negative, a half. But I would go with a half as my final answer. Okay, then 5.3. Examiners were bored. Ne? Now they are bringing calculus again, intrigue. These guys. We have f of x as this, meaning that our f of x plus h is going to be the sine of x plus h. They want us to show that this, okay, show that this can be written also as that. Okay, let's give it a try. Do we need the limits? No, we're not going to use limits here. So we know that our f of x plus h, we've already said is the sine of x plus h. We are subtracting our f of x, which is the sine of x, and then we are dividing by h. So no limits whatsoever, né? Because it's not calculus. Then let's expand this using the compound angles of sine. So it's going to be the sine of x cos of h plus cos of x sine of h. We are subtracting the sine of x and then dividing it by h. Now we need to regroup because we are seeing some like terms. Okay, here and here we have some like terms. I'll say sine x cos h minus the sine of x plus cos x sine h. Everything is over h. Then what is common here is the sine x. Take it out. We are left with the cos of h minus 1. Okay, we are plusing it by the cos x sine h. Everything is over h. Which formula did we have? Things were separated. Okay, split this since it's the same denominator. Gonna have the sine of x into cos h minus 1. Everything is over h plus this is gonna be cos x sine of h also over h. So all you have to do is just rewrite the way it was because we've already obtained whatever we are interested in. So that is cos h minus 1 over h, and then cos x, and then we have sine of h over h. Put the brackets the way they put them as well. So that is basically or technically how we would have gone about with this mini calculus kind of teaser. All right, then question number 6, which is also still under the trig. Okay, so they want us to simplify the following into a single trigonometric term without the use of a calculator. So what I can see, how many marks is it? 7 marks. Wow. These people are generous today, né? So we know that from our Cartesian, this is going to be a 360 plus, it's going to be a 180 minus, 180 plus, and then a 360 minus. Okay. So this 180 is going to be quadrant number 2. And in this quadrant, tan is negative. Let's reduce that. So negative tan x. And then 180 minus is still second quadrant. Cos is negative. So cos of x over 240. Which quadrant is 240? It's in the third quadrant, which is 180 plus. So that's the same as 180 plus a 60. Okay? Because 240 minus 180, you get a 60. And we know that in this quadrant, the cos is negative. So it's going to be the same as someone saying the negative cos of 60. And then when we look at this, what's going on there? We can change the tan squared into sine and say sine squared y over cos squared y minus 1 over cos squared y. Okay, beautiful. We move on. We're going to change now this tan into a sine and cos. So it's a negative sine x over cos x. Now I'm multiplying it by the negative cos x. I would have killed the negatives. Negative cos 60 is going to be negative a half times. Denominators are the same. Okay, meaning that I can do the numerator sine squared y minus 1 over the cos squared y. Okay, then it's party time. Let's cancel out what we need to cancel. So this cancels that. And then what do I see? What do I see? So I can take this negative a half to the top because like 1 divided by 0.5 gives me a 2. Okay, so this is a negative, and negative is a positive. So this negative is going to stay. So I'll have a negative 2 on top over my problem here. I have sine squared y minus 1. What I would do is take out the negative sign, and then I'll have 1 minus sine squared y, which also gives me the same as cos squared y. So I'll say that this top part is the same as negative cos squared y, and then I'm dividing it by cos squared y. So this cos squared cancels that cos squared, and then my answer is just a 2. Okay, someone will say we left out something. Yes, we left out the sine x here, which we cannot do. Okay, so 2 sine x becomes our final answer. All right, so that is how the 7 marks were meant to be obtained. So your reductions, you'll start earning marks just with the reductions. That's already 3. And then your magic here, and whatever you do, you end up with a 7. All right, 6.2, prove this identity. Okay, prove the identity. We're being told that sine 3x over sine x cos x is equal to this. So let's start from the left-hand side because I have more elements there. So I know that sine 3x is going to be the sine of probably 2x plus x over sine x cos x. Let's expand the top using the compound angles. So it's going to be sine 2x cos x plus the sine x cos 2x. I'm dividing this by sine x cos x. What we saw on top, on the right-hand side, everything is just cos. So sine must disappear. So let's expand this double angle to sine x cos x. Then I'm going to multiply it with this cos x. Plus, let's change this to a cosine format. The double angle of cos is 2 cos squared minus 1. Okay, sine x into 2 cos squared of x minus 1. We're dividing this by the sine of x and the cos of x. All right, so what we see, let's take this out. I'm taking the sine x out. I have cos and cos, which is cos squared. So 2 cos squared of x is left. Then I also have this 2 cos squared. Does it make sense? It should make sense. Okay, so we're having 2 cos squared x, and then we are subtracting a 1. This is all over sine x cos x. So this cancels that. 2 cos squared gives me 4 cos squared of x minus 1 over the cos of x. So that is equal to the right-hand side. So that is how the proof would have been done. Alternatively, if you want to open this up, you can still go ahead. But I believe that would be a waste of time, because if you take this out, you'll be left with that bracket alone. All right, so that is the sweet 5 marks as well. 6.3. Yo, the devil himself, or the devil herself. Determine the general solution. Okay, so this general solution was a bit tricky, guys. But the easiest way that I feel we can go about it is let's square both sides, because we need to get some single trig ratio that we can use. So I don't know how other people would have approached it, but for my case, I would have squared both sides. Okay, so that I have this squared and then that side squared. Okay, so if I open brackets here, I'll have the cos squared of x plus twice cos of x is equal to the sine squared x. I already have a cos x here, meaning that I can change this into a cos. So cos squared x plus 2 cos x is equal to 1 minus cos squared x. Let's transpose and take everything to the other side. There's something I left out. There's a 1 here, because when I'm opening, it's a cos squared plus 2 plus a 1. Good. Let's move everything to one side. Cos squared x plus 2 cos x, okay, plus a 1 minus a 1, and then plus cos squared x is equal to 0. Okay, then cancel out this and that. And then cos squared and cos squared gives me 2 cos squared x plus 2 cos x gives me a 0. What's common? Take out one cos. I'll be left with just a cos x plus a 1 is equal to 0. Okay, then we get into where people understand this better. So either 2 cos x is a 0 or cos x plus 1 is a 0. So meaning that here cos x is a 0. What's the reference angle? The shift cos of 0 gives me a 90. Okay, so I'll have x to be a 90 plus 360 times k. K is an element of integers. That is quadrant number, it's on the boundary between quadrant 1 and quadrant 2. The other angle or the other solution would be 270 plus 360 times k, because k is an element of integers, okay? So that is for the first reference value. Then with this one, we know that the cos of x is gonna be a -1. So x is gonna be the shift cos of -1, which gives me a 180, meaning that's gonna be 180 plus 360 times k. K is an element of integers. The other solution that I would have obtained is way above 360, which is like 540, because if I say cos of 540, I'll end up with a -1. But I don't need the 540 because it's way beyond the 360 point. So this can be left out and we focus on just those 3 solutions. All right, guys, that's how I would have nailed this question for 7 marks. Yeah, it's reasonable. Okay. Unlike the paper one where people is stingy, here, people are generous. They are just giving back to the community. They are trying to compensate for the disadvantage they were making. All right, in the diagram below, the graph f of x is negative cos 2x within this interval. Okay. Now they want the period of f. Now we know that if the graph is just a cos x, the period is going to be 360. If it's a cos 2x, it's going to be 360 divided by 2, which is 180. Now, the other thing that you can also look at is how many cos graphs do we have? Because this is negative 180 and 180, which is basically 360. How many graphs do we see? We are seeing 2 graphs of cos, and each graph is taking an interval of 180. So that is the period. Then they want the range. Range is basically y values. We have -1 and +1. So we're going to say -1 is less or equal to y, less or equal to 1. Alternatively, y is an element. You use the square brackets, -1 and 1, because they are inclusive. 7.3, they want us to sketch. Okay, so with the sketching, we're going to use our calculators. Okay, the graph is tan of x minus 45. Okay, we're just plotting one graph, so we don't have to use the other graph. Okay, the intervals are basically, the starting point is -180. The end point is +180. The step is 45. There we go. Okay, so -180, I'm getting a -1. Okay, -135 is a 0. Why don't I use a different color? Okay, so we said -1, that is a 0. And then -90 is a 1. -45 is a complex error, which is an asymptote. Okay, just in case the asymptote, just like that. Then 0 is -1. Okay, and then 45 is a 0. And then 90 is a 1. And then 135 is an error, okay, which is an asymptote as well. Then lastly, 180 is a negative. Is a negative what? Is a -1. Okay, so how do we plot this? So since it is moving towards the asymptote, we can just connect something like that. Okay, this one must move towards the asymptotes, just like that, and then towards also this asymptote. And then lastly, this one must just move in that direction, because if ever we were to have another graph or any other points, let's say we are using 45 now. So 180 plus 45, it's going to give us 225. And then the tan of 225 minus 45 was going to give us a 0 somewhere there, so that the graph just moves in this sort of direction. Okay, so this must move towards the asymptote. So guys, that is our graph that we can label as G. All right, then they're asking us for which values of x is f below, okay, the G of x, between -180 and 0. G is above, no, G is below. F, no. They said f of x is less than G, meaning that f needs to be below G. So where do we find the graph of f to be under G? So between this point and this point, the graph is below. So we're going to say -90 and then -45, okay? I don't know about this side, how the points, because I'm not that accurate with my drawing, but I'll presume they were using the same line and then they, okay? So where do we find f to be under? So I'll say -90 is less or equal to x, and then is less than 45. Reason as to why I cannot use the equal sign is because that's an asymptote. Okay, then 7.5, they want us to get the maximum of this entire thing. So the trick is just on the exponent. So if I rewrite this exponent, or if I take out the negative sign, I'll have 1 minus 2 sine squared of x. And 1 minus 2 sine is the same as cos 2x. So negative cos 2x. So what is the maximum of the cos 2x? That is what the question is asking for. Remember, initially, the graph was a negative cos 2x. So its maximum is a 1, okay? Meaning that where there is this graph, I'll just put exponent 1, and then my answer becomes F4. Okay, so that is question number 7. All right, we move on to question number 8. So question number 8, they are telling us that in the diagram below, A, B, C lie in the same horizontal plane. The vertical pole DC is H units and AB is K units. CAD is theta, and then BAD is beta. Okay, and then DBA is alpha. Now they want us to express CDA. CDA. In other words, this angle here in terms of theta. So we know this side as the opposite, and then this side as the hypotenuse. Determine the size of CDA, but we don't need to do that. They only want the size, this angle. So if that's a 90, this is a theta, meaning that this angle should be a 90 minus theta. That's why it's a 1 mark. Then if it is true that this is a 90 minus theta, the next question is asking us to determine the length of AD. Okay, determine AD. So this is our hypotenuse, like we said, this is the opposite to the theta. We can use the sine and say that the sine of theta is equal to the opposite, which is h, over the hypotenuse, which is AD. Do the cross multiplication, so AD becomes h over sine of theta. That's how we go about it. How many marks? Should be 2 marks. Okay, so we said AD is h over sine of theta. Then 8.3, can we show that CD can be written as that? Okay, prove that CD, which is the h, can be written as the k sine of something, something, sine alpha, sine theta over the sine of alpha plus beta. Okay, so we're looking at AD. Now, what I'm going to do is, if this angle here is alpha, this angle is a beta. It simply means that this angle here, okay, let's look at our BDA, is going to be 180 minus the alpha plus beta. Okay, so this is the angle BDA. Then I can use, because I already have my representation of H by 8.2, or the A, okay? And I can use the triangle BAD. Okay, from BAD, let's use the sine rule and say that AB over the sine of BDA should be equivalent to AD over the sine of DBA. Let's do the substitution and see. What's our AB? That's going to be a K over the sine of 180 minus alpha plus beta, okay, is equivalent to the AD over the sine of this alpha. Okay, then let's do the cross multiplication and the substitution. Okay, let me just erase this so that I have more space. So we have the K over, when we reduce this, that's gonna give us the sine of alpha plus beta is equivalent to the AD, which we already have as H over sine theta. Now we are multiplying it by this as well, 1 over sine alpha. Then make H the subject, since we're looking for H. Okay. So cross multiply K over sine of alpha plus beta is equivalent to H over sine of theta, and then the sine of alpha. When you cross multiply, our H becomes what we were given. Okay, so that is how we would have gone about with proving that for the 5 marks. So sine rule, and then what is important is for us to get this angle first, and then apply what is next. All right, then 8.4, calculate the length of CD. Okay, what we know about CD is the H. In other words, we are trying to do the substitution back into the formula. They told us K, the sine of alpha, the sine of theta, over the sine of alpha plus beta. Is that correct? Yes. So we substitute. We're saying our K is a 95 multiplied by the sine of alpha, which is a 32,7, and then the sine of theta, 43,9, divided by the sine of alpha, 32,7, plus the 61. When you punch all of this into the calculator, I'm getting a 35,66 meters. I don't know. Somebody can advise us otherwise, but that's what I'm getting. All right, then let's get to question number 9. The paper is now just starting. We are just starting. Question number 9. In the diagram below, CD is a diameter with a center O. Okay, E is a point on the circle such that DE produced to G. Okay, we have other extensions, the OG, the CE, the CG, blah, 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 blah. This is X, and then they're telling us that this is a 90. Now pay attention. They told us it's a 90 COG, and then they never indicated it. So I'm indicating it there for myself. All right, then 9.1, they want us to prove that COC GE is a cyclic quad. Okay, so they want us to prove that this and that and this entire thing is a cyclic quad. So for us to prove cyclic quads, number 1, we have what we call the exterior angle. We have the opposite angles being supplementary, and then we have the angles in the same segment. So any of the 3 that we can see is what we can use. So number 1, what I can see or what I can notice is that O1 is a 90, we were told. Okay, O1 is a 90, that is given to us. If O1 is a 90, we know that DEC is also a 90, angle in a semicircle. So the whole of this is a 90 because this is a diameter. And if it's true, that is a 90, then CEG will also be a 90, this one. So since we have the 90 and the 90, in other words, we are getting the bow tie here. The bow tie is already out. So this is a 90, that is a 90. So that is enough to prove that the 2 or the shape is a cyclic quad. So therefore, OCGE is a cyclic quad. The reason we're going to say the converse of angles in the same segment. Okay, so that is how we would get those 3 marks. And then name 3 other angles that are equal to X. I'll just write this up here because I don't want to scroll up and down. Okay, 9.2 angles that are equal to x. The first one, we have this one, C1. Reason, this is a radius, that's a radius. So angles that are opposite equal sides. Okay, so if C1 is x, remember we've just proved that this is a cyclic chord. So meaning that the bow tie will still hold, meaning that this G2 is also going to be x. Angles in the same segment or angles subtended by the same chord. Okay, if this is x, then we could also observe another x or another bow tie, just like that. Okay, so if this is x, meaning that even the G1 is also x, same story, angles in the same segment. All right, so we have G1 as x and then all of that. Okay, so that is how we would have answered that 9.2. 9.3, they want us to get the size of DOE. DOE. This is D, this is O, this is E. So they want us to get this angle here. Okay, let me just try to erase some things here. Okay, so how do we get this angle? Number one, we say that this was a 90. We did prove that because it's an angle in a semicircle. And then we have this as our x. But what is this angle here? It must be the same as this. Does it make sense? So we said angle D. Angle D. Okay, let me look at it in a different approach. Mustard. If I look at this big triangle, this is a 90. This is our x, meaning that this angle D is going to be a 90 minus x. That's what I'm going to start with. So I'm saying that D, this mustard is something else. Okay, 90 minus x, angles in which triangle? I'm looking at triangle DCE. Okay, then if this is a 90 minus x, this is a 90, then I need to find what O3 is. Remember they said DOE, if I'm not mistaken, okay, which is O3. Okay, so if it's a 90 minus x, then I can say this 90 minus x plus 90 plus O3 gives me 180. Okay, so a 90 minus x plus a 90 plus O3 should give us 180 interior angles of a triangle. So that's a 180, which is going to cancel out, meaning that O3 is going to be x. All right, so alternatively, there could have been another way of doing it, okay, which at this point, I'm not so sure, but that is how I would have gone about, okay? Let people give us any ideas of how they worked out 9.3, please. Question number 10. Okay, question number 10. In the diagram below, A, B, C, and D, E, F are drawn. So A is the same as D. Okay, perfect. B is the same as E, and then C is the same as F. Okay. Use the theorem or the diagram above to prove the theorem that states that if two triangles are equiangular, then their corresponding sides are also in proportion. So what we normally do is that start by constructing. Okay. Just label this any letters of your choice. I'm going to label it S and T. So step number one, you have to tell us that construct the line ST, okay? Construct the line ST on the side AB and then AC such that, okay, such that the distance AS is the same as DE, and then the distance AT is the same as DF. That is what we need to start with, okay? So if construct to show that this is the same as that, and then this is the same as that. If that is correct, then we can go ahead to say that these two triangles are basically congruent because we have this side and that side, this side and this side, and then we have the angle. So therefore, I'm saying that AST is congruent to triangle DEF. Reason, side, angle, side. And if that is done, then we know that this angle E is going to be the same as, I can say this is my S1, this is my T1. Okay, I know E is the same as S1, which is the same as this angle here, B. And then consequently, we know that T1 is the same as that other angle that is F, which is the same as which angle? C. Then if that is correct, then it makes these angles to be corresponding. And if they are corresponding, which means that these lines are parallel. Okay, so we're going to say that therefore, our ST is parallel to the BC, the converse of corresponding angles. And if that is true, then we can use the midpoint theorem or the proportionality theorem, not necessarily midpoint proportionality. So they started with DE. Okay, DE is the small side over the bigger side. So I'm going to say that if I have my AS over AB, okay, so AS over AB should be the same as AT over AC, okay, over AC. But remember we said that our AS is the same as DE. So replace that and say last that DE over AB is the same as, we said AT is the same as DF. That is DF over AC. So that is how you do the proof for this particular question. 6 marks. All right. 10.2. 10.2, the diagram below, ACF are points on a semicircle with center B. A circle with center C is drawn. The radius of the semicircle is twice the radius of C, meaning that the radius of center B is the same as twice the radius of C. Let's leave it at this point. We're going to need it probably somewhere. Then fade is a tangent to both circles respectively, and then that is a straight line. Then step number 1, prove that AFC, okay, this AFC, okay, prove that this triangle is similar to FEC, to this triangle here. Okay, so step number 1 that I'll do, I know that my F2, this is a 90 angle in a semicircle, eh? So F2 is a 90 angle in a semicircle. We know that E1 is also a 90, a tangent and radius, tan perpendicular to radius, meaning that F2 is the same as E1, which is 90. Okay, then 2, we can see that F3, this angle here, is the same as this angle here. So angle CAF is the same as F3. That is basically the tan chord theorem. And automatically this C1 and the C2 will be equal to each other. So C1 and C2 will be equal. Reason, the remaining angle of a triangle. So we have 3 fundamentals and you draw the conclusion. Therefore, AFC is similar to FEC. Reason, we said angle, angle, and then angle. Okay, so that is how we would obtain the 5 marks. Then 10.2.2. Okay, they're telling us if the radius of the smaller circle is P, determine the following in terms of P, the radius of FC. Let me do it here. So let me just try to redraw those two triangles somewhere here so that we see what we're talking about. Okay, we say this is A, F, C, that's our bigger triangle. And then the smaller triangle, we said it is E, C, and F. Remember, this was F3, and then this was a C1, but that is not important. Né? All I need to know is that FC goes with EC for the small triangle. AC of the big one goes with FC of the small one. Then I can do the comparison, okay? So if I'm to compare this, remember our AC from here up to there. Remember the radius is twice. They told us that this is a P. So R of B is 2P. So if that is a 2P and this is a 2P, it becomes a 4P. And then this distance from C to E is what we are having as a P, meaning that I'll have this AC as my 4P, and then I'll have the EC as a P. Let me compare the sides. So I'll say that if I have AC divided by FC, it will be the same as someone getting FC divided by the EC. Reason is going to be similar triangles, or you can tell us that those two triangles are similar. What we can see, we can do the cross multiplication, meaning that our FC squared is equal to AC multiplied by EC. Then our FC squared, we know that our AC was 4P. Our EC is a P, meaning that we have a 4P squared. Then we can find the square root on either side, meaning that FC is just a 2P. All right. Then part B, they're telling us that they want the length of FD. Okay, they want the length of FD. If FE is the same as ED. If FD, they want the length of FD. If this distance is the same as that distance. Now, what we just calculated was the FC. Let me just erase this out. Okay, so we say that our FC is twice P. We have this radius as a P, and we say this is a 90, meaning that we can use our theorem of Pythagoras to find FE first. Okay, so we're gonna say that FC squared, let me try to redraw that. Say that's a 90. Oh, so FC and E. FC and E, we say this is a P, and this is a 2P. So we're going to say that FC squared is the same as the CE squared plus FE squared. So 2P squared is equivalent to CE, which is a P squared, plus FE squared. So meaning that our FE alone is going to be the square root of 4P squared minus a P squared, which gives me a 3P squared, and a square root, which is the same as root 3 of P. Okay, but that is just FE. They told us FE is the same as ED, okay? Meaning that our FD should be twice, okay? Multiply this by 2. So 2P square root of 3. That becomes my answer. Or someone can say 2 root 3 with a P. It's still the same thing. All right, question 11, the last one. In the diagram below, we have a cyclic quadrilateral EFGH. Okay. Then chords EH and FG are produced to meet at K. Okay. M is a point on F such that MG is parallel to EK. KG is the same as EF. Now they want us to prove this, 6 marks. Okay, so before we do the proof, this is a cyclic quad. E, F, G, H is a cyclic quad. And if it's a cyclic quad, we know that H1, okay, if I call that X, it's going to be the same as F. Okay, reason being, let's just say it. H1 is the same as F. That is exterior angle of a cyclic quad. That's number one. Number two, the other thing we need to highlight before even we start the proving is that G1 is going to be the same as E. Also exterior angle of a cyclic quad. So if this is a Y, this must also be a Y. Now let's do the proving. So what I'm going to do to get this, I need to prove that triangle KEF is similar to KGH. Okay, so KGH, the same as KEF. So this small triangle and the bigger triangle, prove that they are similar, and then we shall be in position to do that. So what we're seeing is that both triangles are sharing a K. Okay, K is the same as K. Reason is common to both triangles. And then we're saying that G1 is the same as E. We saw that, say the exterior angle of a cyclic quad. And then lastly, we're saying that H1 is the same as F, same story, exterior angle of a cyclic quad. Okay, so we're saying that KGH is similar to KEF. And if that is the case, then we can do the comparison of the sides, meaning that our KG, okay, this KG here, the common angle and the Y, the common angle and the Y over KE, okay, is equivalent to GH. So I'm to look at GH, the Y and the X over the Y and the X, EF. So GH over EF. Okay, what was the question asking for? EF. But the question also told us that KG is the same as EF. So where there is KG, we can put an EF somewhere. So meaning that we have EF over KE is equivalent to GH over EF. Cross multiply, we have our EF squared is equivalent to GH multiplied by the KE. So I think that is what the question has, and then that is how we would have obtained the 6 marks. So start by proving these two triangles. Reason is going to be angle, angle, and then angle. All right, then 11.1.2, can we prove that KG squared is equal to EM dot or times KF? So what I can do here, remember it is, we have a set of parallel lines. I can use my proportionality. Okay, proportionality, because this line is parallel to that. So they said, what did they say? They said KG squared. Okay, so KG, so what I'm going to do, I'm going to look at the side, and which side am I going to say? I'll say that if I get the KF, the whole of KF, over the KG, okay, should be the same as EF over EM, something like that. Okay, so I'm going to say K is equal to EF over EM. Reason, the proportionality theorem, because EK is parallel to GM. Then we can, what did they tell us? Sides that are the same. KG is the same as EF. EF is the same as KG. So let's change the EF into a KG, here to a KG. Mean that KF multiplied by EM is equal to KG times a kg. So meaning that Kf times Em is equal to kg squared. That's what the question wanted using the proportionality theorem. And then 11.2, if the length of Ke is 20, Kf is 16, and Gh is 4, calculate the length of Em. Now remember, the previous two questions gave us two formulas, okay? The first formula, or rather the last one, was kg squared is equal to Kf times Em. And then the first one was telling us Ef squared, okay? That if we have Ef squared is the same as Gh and Ke, Gh and Ke. Now, what do the two have in common? Ef is the same as Kg, so either way. So what I'm gonna do, let me start by looking for the Ef, okay? Since I have my Gh, I have my Ke. So meaning that Ef squared is gonna be the 4 multiplied by 20, meaning that Ef squared gives us 80. But we know, okay, that Ef is the same as a kg from the first part, okay? Meaning that instead of me replacing or calculating this back, I'll just replace it with the 80 and say that 80 is the same as Kf multiplied by Em. So what is my Kf? My Kf is 16. So 80 is equal to 16 times Em. Divide both sides by 16. Okay, so how many 16s are in 80? We only have 5. So Em becomes 5 units. All right, guys, so that brings us to the end of the paper. I hope you guys have scored much in this paper just to liberate yourselves from what paper one did, okay? So I wish you guys all the best, okay, as we compare the answers. And I once again appreciate you guys for your comments, for your subscriptions, and for your views. Keep it up, and I wish you all the best in the remaining examinations that you're writing. Number 2025. Okay, so under this paper, all the topics will be tested as per the examination guideline. Okay, and some of the topics basically that are covered in paper 2, we know that we're going to have statistics. Okay, statistics, sample cohort data handling. Okay, so usually it's 2 questions in that case, but overall the mark allocation should be plus minus 20 combined. Okay, whereby the first question normally talks about the ungrouped data. Okay, and then the second question talks about the bivariant type of data with the correlations and all those things. Then topic number 2 that we can think of in paper 2 is analytical geometry. Okay, so analytical geometry. Number 3, we have what we call the trigonometry. And then after the trigonometry, then we can have our Euclidean geometry. So basically, these 4 topics are the backbones of paper 2. Okay, so please just follow with me as we go over this paper together. Okay, so bit by bit, I'll try to be as brief as I can, but also explain some other details, okay, just when need arises. So let's use this as our sample paper. So in this case, we have 10 questions that we're gonna be dealing with, okay? And the first question is statistics, as always. First 2 questions will always be statistics. So they're telling us that a group of learners wrote a standardized mathematics test that was recorded out of 60 marks, okay? And then the results were represented within the table. So learners that got between 0 to 10, we have a cumulative. We don't know how many they are. 10 to 20 up until 60. So we've been given the cumulatives, and then 1.1 wants us to complete the table, meaning that we need to fill in the frequency column. And so what we can notice, or what we know, is that the first cumulative must always be the first frequency, okay? And then for us to get the next frequency, we just have to do the subtraction. So 60 minus 20, which is a 14. Then 120 minus 60, which is going to give us a 60. Then 170 minus 120, that gives us 50. Then 190 minus 170, that's a 20. And then 200 minus 190, just 10. Okay, so these represent our frequency values. Okay, so 20, 40, 60, 50, 20, and 10. Now, if we want the total here, it should be equivalent to the last cumulative, which will be 200. So how many learners for the test? It's basically 200. So even without adding all of this, the last cumulative value should be able to give us that answer of ours. Now they want us to draw a cumulative frequency graph. Okay, I don't have that page, but I'll try to just put it down here, just for the purpose of people having an idea, okay? So with the intervals, we have 0 up to 60. So I can use 10. So 0, that's a 10, 20, a 30, a 40, a 50, and maybe a 60. And then I know the graph is a bit skewed, but just bear with me. Then the biggest frequency that I have is 200. 200. Let me use intervals of 20. Will 20 make sense? No. Let me use 50. And so that's a 50. That's going to be 100, 150, and 200. Okay, so when you're plotting or when you're graphing a cumulative, we normally use the upper class intervals together with the cumulative frequency. So 10 is going to go with the 20. Okay, 10, we know 20 could be somewhere there. And then 20 is going to go with a 60. As per our cumulative, 60 should be slightly above 15. And then 30 is going to go with a 120. So 120, just somewhere there. I want to believe so. And then 40 is going to go with a 170. 170 is just slightly close to halfway the mark. Oops, why does it look like it's going to be a straight line? Okay, then 50 is going with 190. So 50 is a 190, and then 60 becomes the 200. Okay, then connect this with your points with your freehand, and then you need to extend the graph to the mean. So the starting point, that's where the graph must start from. It needs to be footed. Okay. Okay, so that is the cumulative graph that we would have in that sort of scenario. Then how many learners scored at least 20 out of 60? So when they say at least, meaning that the minimum is 20, but the maximum can be 60. So what we do in that case? So we know that between 10 up to a maximum of 20, we have 60 learners. Okay, at that point, the cumulative of between 0 to up to 20 is 60, meaning that those that obtained either 20 or slightly above 20 out of 60 should be all these ones. Okay, so what I can do, I can just say my 200 minus 60, which gives me 140. Because even if I were to get it from the graph itself, okay, if I'm to read off the 20, I'm going to get a 60 here. Okay, and then I have to subtract that from that, and then I get my answer. Then determine the mean estimate. So the mean for the group data, some people prefer to get the midpoint here and then create a table. Yes, it's allowed, but it's a bit lengthy. How do we get the midpoint? You add 0 plus 10 divided by 2, that's going to be a 5. Then 10 plus 20 is a 30 divided by 2, that's a 15. This is going to be a 25. That's going to be a 35. That's going to be a 45. This is going to be a 55. Then this multiplied by the frequency, okay? Because we know that the estimated mean will be given as the summation of f of x over the summation of f, whereby we know that our f is already at 200. So the f of x is what we need to add up. So meaning if I get those midpoints together with the frequencies, remember the first one is a 5 multiplied by 20. Next one is a 15 with a 40. And then we have a 25. We're going to multiply it with 60. And then a 35 by 50. Then we're going to have a 45 multiplied by 45. We say it's going to be multiplied by 20. Okay. And then the 55 with 10. And then the answer we get, divide this by a total of 200. So I believe this is the easiest. Just determine your midpoints and represent them in this format. So when I plus up everything that is on the top, I'm getting 5.4 divided by 200, and then we get an answer of 27. Please, you can cross-check with your calculator if I'm not telling lies. No? All right, so that is question number 1. Now, this question 1 could also come in terms of, let's say, the box and whiskers, the quartiles, the standard deviation, the mean, the mode, and all those other aspects. Okay, so let's just prepare and be ready for whatever might be brought. Question number 2, a group of 9 students attended a course in statistics, okay, on Saturdays of a period of 10 months. And then the number of Saturdays on which the student was absent was recorded below on the scatter plot was drawn, okay? So if the student was absent for no day, we get a 96%. For one day, it's a 91. So we literally seeing that the more the absenteeism, the lower the marks. Okay, so they drew the box and they drew the scatter plot for us. And then they want us to determine the equation of least square regression. So what this question tests is basically, are you able to use a calculator, okay, when you're punching these values? Remember, it's the mode, and then go look for 2VAR, okay? And then you start entering these numbers. So start with the first one, which will represent the X, and then this will represent the Y. Punch in all the numbers, and then you cancel out, you clear all, and then you go back and find whatever. So if I follow my calculator, I'm getting my A to be a 90,375. I think the next episode we should come with a live calculator and show how we're getting these answers. Okay, then now B is a negative 4,875. Okay, but the question wants the equation, meaning that our Y should be a 90,3. You can round it off to 2 decimals, okay, minus 4,88x. So that is the line that they want. And then for us to get the correlation coefficient, so remember this can also be obtained from the calculator. So my correlation is a negative 0,8. Okay, we can add a 0 since we want everything to be rounded to decimals. Then comment on the strength. So whenever you're commenting on the strength, number 1, you need to talk about the weakness and the strength, meaning that is it weak, is it strong, is it moderate? And then from there, we need to go on and talk about the direction. Okay. Okay, so we're seeing that a 0,8 is really a strong correlation or relationship, okay? So what we can say, since it's a negative, we can say it's a negative strong. correlation or relationship. Okay, so strong, negative, whichever way you want to put it, no problem. Then 2.4, if a student scored 52%, can we predict the number of days that the student was absent? Now, remember, the percentage is the Y, okay? X is the number of days that the learner was absent. So let's use our equation, okay? And say where there is Y, we're going to say 52 is equal to 90,38 minus 4,88x. So start by moving the 90 to that side, okay? So it's going to be 52 minus 90,38 is equivalent to negative 4,88x. Divide both sides by negative 4,88. I mean, this can be done just on the calculator without showing all these steps. So the answer we are getting is 7,86. But then predict the number of days. So since it's days that are countable, okay, so this is approximately 8 days. Okay, the learner was approximately absent for 8 days. But, okay, then is the answer calculated in 2.4 reliable? Okay. What would be our response in this case? The response would be that it's a yes. Okay. Why is it a yes? Because the correlation is negative. Okay. Because of the negative correlation, meaning that if you're absent for more days, even the possible mark for you that you obtain is basically smaller. We are seeing that for 7 days, the learner got a 56. Now we're saying if the learner is absent for 8 days, it should be a 52, which means it's following the trend, meaning that it is very reliable. All right, then we move on to question number 3, which is the analytical. In the diagram below, A is negative 26, B is 8, negative 4, C is negative 6K. Are 3 points in the Cartesian plane with M that is lying there. They are telling us that AM is the same as BM, meaning that this point is a midpoint. Ne? Let's baptize it there. Then also AB. Where's AB? All of this is the same as BC. So this is the same as that. Okay. Then D is a point on the y-intercept of the line AB. Okay. Thank you very much. Then they want us to get the coordinates of M. Now, since we say that M is the midpoint, meaning that we're going to need to use the midpoint formula. And that formula tells us that x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so N can be our x1, so just get negative 2 plus 8 divided by 2, and then 6 plus negative 4 divided by 2. When we simplify that, that's going to be a 6 over 2, which is a 3. Simplify this, it's a 2 over 2, which is a 1, meaning that M is basically 3 and 1. 3 and 1 will become our answer. And then 3.2, they want us to get the coordinates or the value of K. How many marks? 6 marks. 6 marks. What are we going to do? Are we going to use the distance formula? I think that's going to be the only reasonable thing, since they told us that AB is the same as BC. So you can get the distance of AB and then equate it to the distance. Won't this give us a quadratic? But there's nothing we can do since we're focusing on the 6 marks. So distance formula is going to be x2 minus x1 squared plus y2 minus y1. Everything is squared. Okay, when I do the substitution, that's going to be 8 minus minus 2, which is going to be like a 10 squared. And then negative 4 minus 6, which is also negative 10 squared. Okay, so that's 100 and 100, which gives us 200. Ne? And the root sign, which is the same as 10 root 2, not 2 root 10. It's 10 square root of 2 units. Ne? So that is our AB. Then we're going to equate this to the distance. since we already have our coordinates as 3, 1. Okay, so why don't I just write it on this other side? Okay, so we're saying that m is 3, 1. And then this point is negative 6k. Is that a C? Perfect. Okay, so we're saying that MC, but it's not MC. We're focusing on BC, 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 BC. What's our B? It's 8, negative 4. Okay, so BC, which is the same as AB, should be the same as, okay, we're going to have 8 minus 6 squared plus negative 4 minus k squared. You can arrange it in whichever way you find convenience. Okay. And then we said we're going to equate this to 10 square root of 10 square root of 2. Let's open up there. You're going to have 8 and 6, which is a 14. Is that a 14? Did I do anything wrong? Let's just erase this out and see. So this is 8, negative 4. Okay, so it's 8, negative 4, negative 6, and a k. Okay, when we do the substitutions, okay, when we do the substitutions, that's going to be 14 squared plus, that's going to be 16 plus, that's going to be 8k plus k squared. This must be equal to 10 square root of 2. Okay, I'm just opening this square bracket. Then I need to square both sides to get rid of the root sign. So 14 squared is going to be a 196 plus 16 plus 8k plus a k squared must give me 100 times 2, which is 200. Let's move everything to one side so that we have a k squared plus 8k. Okay. Then that's going to be negative 4 plus this. I think it's just going to be a 12. Né? Because I'm trying to look at 200. I'm taking away 196, which is a 4. Okay, 16 minus 4, which gives me a 12, is equal to 0. And then I need to factorize this. The two numbers of interest will be 6 and 2. So k plus 6, k plus 2. So either k is a negative 6 or k is a negative 2. K is a negative 6, k is a negative 2. So we need to confirm and see. We know that this y value is a negative 4 here. There is no way this k can be negative 2 below the negative 4, meaning that our k needs to be a negative 6. It cannot be this negative 2. All right, so we've decided and we got those 5 marks, then hence or otherwise they want us to get the equation of Cm if k is a negative 6. Thank you for confirming that. Okay, the equation, so we saw that C is that M is 3 and 1. Okay. M is 3 and 1, and then C is negative 6 and negative 6. Okay. Okay, so they want the equation. So whenever we get the equation, number 1, we need to find the gradient, okay, change in y over the change in x. So we're going to say 1 minus 6 over 3 minus 6. Meaning that we're going to have a 7 over 9. Okay, that's the gradient. Yeah, I know it's weird, but it's fine. Then let's use this point. Okay, some people prefer to use the mx plus c. They look for the c. I prefer to use y minus y1 is equal to m into x minus x1. I'm going to use the point m. So it's saying y minus 1 is equal to our m, which is 7 over 9 into x minus a 3. We open this up. So 7 over 9x minus, that's going to be a 21 over 9 plus 1. Okay, simplify this fraction, 7 over 9x. When I simplify this, it's supposed to be a 7 over 3. Means that's negative 7 plus 3 over 3, which is a negative 4 over 3. So this is what I get as my equation. All right, we move on. If A, E, B, C, if A, B, no, if A, E, B, C, A, E, meaning, before I even finish the question, trying to look for point E, I'll just locate it to be somewhere there. I don't know. A, E, B, C is a parallelogram, and K is negative 6. Determine the coordinates of E. So if this is our E, I'll just put XY. Okay, we have that. And then we have that. Don't mind about the shape, but we just focusing on the parallelogram part. How many marks is it? It's 2 marks. Okay. So if it is 2 marks, and we already know that our AB is a diagonal, meaning that this point M is going to be a midpoint even to this AE. Now, if this is x, this is a negative 6, we're going to have something like negative 6 plus x divided by 2 must give us a 3. Okay, cross multiply, meaning that negative 6 plus x is equal to a 6. Move the 6 that side, x becomes a 12. We do the same with the y. If we get k, which is a negative 6, plus the y value of e, divide by 2, we must get the y value here, which is a 1. Cross multiply, negative 6 plus y is a 2. Then y becomes 8. Okay, so that's what they wanted. I don't know why they are giving us just 2 marks. Okay, 3.5. Given that the straight line is defined by this, they want us to determine the value of m if the line has an inclination of this, like y. Because I don't see any big logic in this. You know why? Because we have the inclination here. But then they're telling us that if a straight line defined by this, determine the value of m if it has an angle of inclination of this much. Okay, so what I'm going to do, let me start by maybe creating a standard equation, okay? 2y minus 1, okay, 2y minus 1 is equal to mx. Let's leave y on one side. So y is going to be a half m of x plus 1 over 2. So move this one that side, it will be mx plus 1. Okay, then divide through by 2. We shall get to this. What does this mean? We need the value of m. But we know that this m is the same as m over 2 times x. So this is like the gradient of interest. We know that tan of theta is equal to the gradient. Okay, just the normal gradient m. So we're going to say if we get the tan of 116,56, we should be able to get to our gradient. So punching this into the calculator, we're getting a negative 4. Then this is just the value m, but then this m over 2 is our gradient. Means that negative 4 divided by 2, the answer becomes a negative 2. But what was the question asking for? Determine the value of m. So I'm not sure, because if the question was asking for the gradient, then I would have gone for the -2. But if they're asking for m, then this would make a lot of sense. I don't know. Let's see what you guys have to say about that. Then calculate the coordinates of D. Where is D? We don't have D. Ne? Did they mention anything about D? So they told us this is the y-intercept. Oh, it's here. Okay, so how do we get those coordinates? How many marks? It's 2 marks. Do we need to get the equation of the, okay, we're saying that the gradient is -2. But this is a y-intercept, meaning that the x is going to be a 0. Is there anything special they mention about D? There's nothing. It's just y-intercept of AB. So 2 marks is still an understatement, unless if there's something that I'm missing for 2 marks. For 2 marks. Okay, the equation, we know we only found the distance. Did we find the gradient? Nothing, only found the midpoint. Okay, so let's try to find the gradient of AB. Maybe that will lead us to what we want. So it's going to be 6 minus -4 over -2 minus 8. That gives us 10 over -10, which is a -1. Let me use 3 and 1 and say that y minus 1 is equal to -1 into x minus 3. So y becomes a -x plus 4. Okay, so this is our equation, and the y-intercept is 4, meaning that D is going to be just 4 with a 0. So 0 and 4 becomes the D. Then they want us to get the size of B. The size of B. Now, is the B in relation to the triangle or the parallelogram? Okay, I'm just going to ignore the parallelogram and focus on the triangle here. Okay, so this angle here is what the question is asking for. So it should be a lot of marks, né? It's 5 marks. What do you think needs to be done here? What needs to be done? You see the gradient here is a -1. We got the equation of MC. And what was the equation of MC? We got the gradient to be 7 over 9 for MC. For us to get this, do we need to extend this line? I think that's the only logical explanation that I'm seeing now. Let me just take this out so that I can show people what I'm seeing, so that I don't waste a lot of time. Okay, so what I'm saying, I'll just extend this and then extend this line. Okay. So I'm gonna treat this as my exterior angle. Let me call it theta. I'm gonna call this a beta, my angle of inclination. And then let me call this my alpha, also the angle of inclination. So that when I plus these two, I should be able to get to the theta. Now, since we say the gradient here is -1, I'll say that the shift tan of -1 is to give me alpha. And I know this is going to be like a -45. Okay, so if that's -45, technically I know that this will be the 45 and this one will also be the 45. Then what is the gradient of BC. I think that's the only tricky part. Let's look for it. BC is going to be -4 minus 6 over 8 minus 6. Okay, so when we plus this up, we're gonna have a +2 over 14, which gives us just a 1 over 7. Okay, so that's what I'm getting as my value. So I need to get the inclination value. Okay, let's punch this into our calculator and see. So we're going to say that the shift tan of 1 over 7 should give us our beta. Shift tan of 1 over 7 because I'm focusing on this line. Okay, so shift tan. Nope, that's not true. It's saying the shift tan. Okay, of 1 over 7. It's giving me a very weird answer. Very weird answer. I'm getting 8,13 as my answer. Okay. I don't know if it's my calculator, but that's what I'm getting. Then if this is 8,13, meaning that I just need to plus these two and get my value of B. So 45 plus 8,13, that gives me 50, what? That a 53,13 degrees. Okay, so guys, that is if I'm using the triangle part. But there are also other ways, okay? We shouldn't just focus on that. Remember, we found the distance, this one to be 10 square root of 2. This is a 10 square root of 2. You can even find this distance, okay? And then we use the cosine rule. That is also one other quick way to get the answer, okay? So nevertheless, it's all about the approach that we are interested in, for as long as you get an idea of how to go about this. So cosine rule could also be applied in this case. There is no problem with that. All right, so someone is saying there's an issue with our gradient for AB. Is it not -1? So you say 6 minus -4 over -2 minus 8. It's a -1, okay? So I believe even if you use the cosine rule, we should be able to get the same answer. Then determine the area of the triangle ABC. So I'm going to use this angle that I found, okay? I'm going to use 53,13. So we know that area of a triangle will be given as a half AB sine of C. But now since we have angle B, okay, it's just gonna be a half times A times C, the sine of B. Okay, so that's a half times 10 root 2 times 10 root 2, the sine of 53,13. So I'm just using the angle that I got. Okay, so if ever you get a different angle, is just use the same steps and then use that same angle that you got. So when I punch this into the calculator, that's gonna be the sine of 53,13. Okay, I'm multiplying it by 100. It's giving me, because this and this is gonna be 200 divided by 2, that's like 100. So I'm getting 79,9998, which is approximately 80 units square. All right, so that is how we would have gone about with that, okay? Alternatively, if you feel there is a 90 degree somewhere, then go ahead and use it and find the distance. Okay, that is question number 3, 29 marks. Question number 4, which is also analytical, but this focuses more on the circle geometry. In the figure below, circle A has this equation. Line BC is a tangent at D. That's the point. Okay, everything is included. Determine the coordinates of A, which will be the center for 4 marks. So in this case, we need to complete the squares. So it's going to be x squared plus y squared plus 6x. Let's bring everything that side, plus 6y. Is equal to -1. Okay. So when you look at the x's, it's just x squared and 6x. Same story with the y squared and 6y. So how do we complete the squares in this case? So we can see that one value is negative, the other is a positive. Oh, I'm missing something here. This is supposed to be negative 6y. Sorry about that. Okay, so open the brackets. We square that, open the brackets, we square that, that's a -1. So I'll put my x there, I'll put my y there. What is a half of 6? It's going to be a 3. Keep the sign, plus. And then I'll plus a 3 squared. And then half of 6 is a 3. Keep the sign to negative. And then we said I'll plus a 3 squared. Meaning that the general equation is x plus 3 squared plus y minus 3 squared is equivalent to, that's a 9, that's 18 minus 1, which is a 17. All right, so these are our center points. They are not interested in the radius, they are only interested in the center point. So we're saying A is going to be a -3 for x, a +3 for y. Perfect. Then they were asking for the radius of the circle, which is just going to be the square root of 17, because this represents r squared. So if r squared is 17, which means r alone will be the square root of 17. All right, then determine the equation of the tangent. Okay, so if this is a -3 and a 3, we need to draw that sort of a line. We know that tan radius will be perpendicular, okay? We know the coordinates of D to be -28/5 and then 31/5, okay? So let's get the gradient and then multiply it by -1, and then we get our answer. Okay, so gradient of the radius, we're saying is a 31/5 minus 3 over -28/5, we shall say plus 3. Okay, so when you punch all this in the calculator, we end up with a -16/13, meaning that the gradient of the tangent is just the reciprocal of this, which is a 13/16. Do we have a point that we're using? Because they want the equation. So we can use the same point, the 28 and so on. Meaning that it's going to be y minus 35, no, it's a 31/5 is equal to 13/16 into x minus, which is a plus 28/5. Open the brackets and collect the like terms. I don't know why this paper, they used fractions too much, but not a problem. Okay, so I'm getting the C as a 43/4, meaning that the equation is going to be 13/16x plus a 43/4. So that is what we get. Then they want the area of B, C, O. B, C, and O. Okay, so what this asks for us, we need the coordinates of C, we need the coordinates of A, which are basically the intercepts, okay? So meaning if X is a 0, Y is going to be a 43/4. If Y is a 0, okay, we're going to get x to be a negative 172 over 13. Then substitute that into the equation of the area of a triangle, it's a half, 172 over 13. The height, we said 43 over 4. Simplify that. You can give your answers in decimals, but I prefer to leave them as fractions. So it's going to be 1849 divided by 26, that's units squared. Then 4.5, the circle with this equation is reflected about the line y is equal to 0. And which line is that where y is 0? So that is the x-axis. Okay, so this circle is reflected about the x-axis. Can we write the equation of the new circle? So if it's reflected about the x-axis, meaning that it's only, okay, so we're keeping the x. It's only the sign on the y that's going to change. So the new coordinates of the center will be -3 and a -3. Okay, so the new equation, I prefer to write it in a simplified version. It's going to be x plus 3 squared, and then y plus 3 squared is equal to 17. Nothing is going to change. That has to be the equation. And then hence, calculate the length of the common chord of the two circles. Write your answer in simplest form. So if we have the same circle reflected, meaning that the two would be, no, that is a lie. That is a lie. So if that is our center there, this is our center. So we can have something like that. So the common chord, this one, is what they're asking for, the line that connects the two meeting points. So you need to equate the two equations and solve them simultaneously because that chord is along the x-axis. Okay, sorry, yeah, along the x-axis where y is a 0. So with the first equation, if your y is a 0, your y is a 0, meaning that x squared plus 6x plus 1 gives you a 0. Okay, when you punch this into your calculator using the quadratic formula, obviously, we're going to get our x to be something weird. We have -3 minus 2 square root of 2, or x is a -3 plus 2 square root of 2. So we already have the 2 points, this one and that one. Then we just need to get the distance between the two answers. Okay, so I'll start with a -3 plus 2 root 2 minus the smallest value, -3 minus 2 square root of 2. So this gives me 4 square root 2 units. Okay, so I've used just one circle, but you could also use the other circle. Alternatively, you can solve the two simultaneously, whichever way makes you get the marks. Question 5, which is the trig. Okay, they're telling us we are given the cos of A being this compound angle formula or identity. Use the identity for cos A minus B to derive 1 for sine. So this thing is quite easy. The only thing you have to do is how do I obtain a sine A minus B from a cos? So it's all about using a 90 formula or the complementaries. So I'll say A minus B is going to be the same as the cos of 90 plus A minus B, something like this. Okay, is it a minus or a plus? I think it has to be a minus, no? For it to make more sense. Because if I have it this way, then I'm going to get a negative. So meaning I have to use a negative so that I end up with a positive. Perfect. Then I'm going to snatch this A and keep it to the 90 so that I have the cos of 90 minus A and then minus B. something like that. And then I can open this using this identity that I was given. So I have a cos of 90 minus A, and then the cos of B. And then I'm going to have a plus sine of 90 minus A, and then the sine of B. So cos of 90 minus from our complementary reductions, that's going to give us a positive sine of A, and then the cos of B, plus the sine of 90 minus gives us a cos of A, and then that is the sine of B. So that is what the question wanted. So the trick is just with the 90, and then you merge this A together with that 90. Okay, then on 5.2, if sine of theta is this, and cos theta is greater than 0, calculate without a calculator and with the aid of a diagram. So this is the Cartesian. It has been simplified for us. We can see that sine is negative, when cos is positive. So we need to find the quadrant. Okay, so the cast, and we are saying the sine is negative in quadrant 3 and 4, but cos is positive in quadrant 4. So meaning that our sketch needs to be somewhere here. Okay, that's the 19. They told us 12 over 13. So this is the 13. This is the 12, which is a negative. Then use your Pythagoras to find the missing side. Okay, so when we do that, so it's going to be like 13 squared minus 12 squared under root sign, which gives us a 5, ne? Positive 5. So remember, the hypotenuse is always positive, cannot be negative. They want us to find the sine 2 theta. So this is the same as 2 sine of theta, cos of theta. Let's now substitute. So it's going to be 2 times the sine is negative 12 over 13. The cos is 5 over 13. So this is a 10. So it's a negative 120 over 169. That is what I'm getting as my answer for 5.2.1. Then cos of theta plus 30, this is a compound angle. We just need to open it up. 30 is a special angle. So it's going to be cos of theta, cos of 30, minus sine of theta, sine of 30. Okay, let's use just a different color. So cos of theta is going to be adjacent, which is 5 over 13. The cos of 30 is going to be a root 3 over 2, if I'm not mistaken. Then we are subtracting the sine. They gave us negative 12 over 13. And then the sine of 30 is a half. Remember, they said without a calculator. But can really this one be simplified without a calculator? That's like being unfair. But anyway, we can do it because denominators are the same. So I'll have a 26. So it's a 5 root 3 plus a 12. That should be our answer. Don't give us decimals, otherwise they'll get you there. Evaluate again without a calculator. So cos of 35, sine of 35, we have 225, we have 200. Let me write it this side. Okay, so it's saying sine of 35, cos of 35, tan of 225, and then cos of 200. Okay, so these ones, I believe they are shorting something to give us the double angle. And that is basically the half that I can introduce. Then 225 is a special angle, which is more like 180 plus 45. We can find it on the in the Cartesian. 200 is 180 plus a 20, which is in the third quadrant. Okay, so I'll start by saying it's a half sine of 70 because 2 times 35 is 70. over, we said 180 plus 45 gives us the 225, that's quadrant 3. It's the same as the tan of 45. And then this one, cos is in the third quadrant, cos is negative. Cos, so it's a negative cos 20. Then we know that sine of 70 is the same as the 90 minus 20, which gives us a cos. So it's going to be a half multiplied by the cos of 20 over tan of 45 is a 1, and then negative cos of 20. So this cancels that, which means our answer is just negative a half. I don't know. I believe that's what I would have done to get those sweet 5 marks. Okay, then they want us to get 1 minus sine squared of 22,5. So we know that 22,5 is just the half angle of 45. Okay, so how do we express this? We can say that 1 minus, let's change this to a cos. It's going to be 1 minus cos squared of 22,5. The 1 and the 1, they're going to cancel out. And then we're going to be just left with the cos squared of 22,5. They want us to get the value of this. Okay, so I'm going to go back to the double angle and half angle. Okay, so we have cos squared of 22,5. But we know that cos 2 of 22,5 gives us a 45, meaning that we, as well as dealing with the cos of 45. So the double angle of cos that has cos squared, what is it going to look like? Did we do the right thing here? We said 1 minus. Isn't that wrong? Because we said sine squared is the same as 1 minus. And then that is cos squared. It's fine. It's okay. It's okay. It's okay. Meaning that we have 2 cos squared of 22,5 minus 1. This needs to be the cos of 45. Okay. The question is asking for the cos of what? They're asking for the value of this. So I'm going to move this one that side. So it's a cos of 45 plus 1 divided by 2. So cos of 45 is 1 over root 2, or root 2 over 2 plus 1 divided by 2. Can simplify this further, which will give you root 2 plus 2 over 4. That becomes our final answer. All right, 5.4, we have 3 sine p plus 4 cos q is equal to 6. 4 sine q plus 3 cos p equals to 1. Can we prove that the sine of p plus q is a half? 6 marks. What are you going to do there? Okay, so what I'm going to do, because it's a bit tricky, I'm going to start by squaring here. And also squaring this side, because that's the only way to sort this out. So I'm going to get 9 sine squared p plus 24 sine p cos q plus 16 cos squared q is equal to 36. Let me do the same there. I'm going to get 16 sine squared q plus 24 sine q cos p plus 9 cos squared p is equal to 1. That is equation number 2. Then I'm going to plus the 2 equations together and see if I can get some like terms. Are there any like terms really? Okay, so cos squared q, sine squared q. There seems to be no like terms. Let's see. 9 sine squared p. Okay, this is different because it's a sine q and then a cos p. Is there anything common? So if I get the 9 and the 9, will that make sense? Let's say when I'm doing the addition. So it's a sine squared p plus cos squared p. Oh, this and that. Let's do the same with the 16. 16 cos squared q plus sine squared q. And then these ones, I mean, they have the same 24. And then we have sine p cos q plus sine q cos p. This is equivalent to just a 37. Okay, so we know that sine squared cos squared is a 1. That's a 1. Means a 9 plus 16 plus, this is now going to give us a compound. Sine p cos q is the same as now 24. Sine of p plus q is equal to 37. Okay, we know that 9 and 16 is a 25. Let's move everything that side. So 24 sine of p plus q is equal to, so 37 minus 25 gives us just a 12. And then divide both sides by 24. Being that the sine of p plus q gives us a half. Yo. This is dangerous, ne? If it's further given that PQR are interior angles of a triangle, R is acute, they want us to get the size of R. Okay, now we know that P plus Q is equal to a half, meaning that if we can get, is it gonna make sense if we have to look at it that way? Because we know that P plus Q plus R must give us 180 degrees, meaning that if we can get R, it's going to be 180 minus the sum of P plus Q minus the sum of. Alternatively, we can just have P plus Q being 180 minus R. Either way, so I prefer to use the latter, okay? Meaning that I can use this here. So the sine of 180 minus R is equal to a half. Then the shift sign of a half gives us 180 minus R. Does that make sense though? Does that make sense? If we reduce, because we cannot just say that is 180 minus R. Oh, that would be a lie. Okay, so this is going to be just sine of R is equal to a half. And then shift sine of a half is going to be just a 30 degrees. Yeah, that would make sense. All right, question 6, the trig graphs. Okay, f of x is that, g of x is that. Between that domain, determine the value of q if f touches the x-axis at the origin. What is q? Q is the shift of the cos graph. So if it's a -1, which means, wait a minute, we're focusing on f. Find the value of q if f touches the x-axis at the origin. Is there a number before that? No. So we know that originally the graph is just supposed to pass through 1 and then up until -1. But now it has been dropped down. It's been dropped down. So y or q is going to be a -1, The graph has been shifted 1 unit down. Okay. Then the amplitude of F. Okay, so amplitude is going to be 1 because the maximum displacement, because the maximum minus minimum divided by 2. Then the value of B, if the period of G is half the period of F. So what is the period of G? The period of G is 360. The period of F is also, no. If that's 360, then it's going to be 180, which means B is a 2. Okay, so it's like 360 divided by 180, it's going to be a 2. Then the coordinates of the x-intercepts of G, where is G? This is G. So we already have now the equation to say cos 2x. Where do we find the y to be? A 0. So the shift cos of 0 is going to be a 90. Then, so 2x is a 90, meaning that x needs to be a 45. So that's a 45, and then that needs to be a negative 45. But the question is asking for the coordinates. So it's negative 45 and 0, and then we're going to have 45 and 0. Then use the graphs to determine the values of x in this interval for which x times the gradient to be negative. Okay, so when you look at the negative side, I think it satisfies all the values. Okay, meaning that there's a negative 90 is less or equal to x less than 0, or we can have 0 less x less or equal to 90. As x, so x is negative, the graph or the gradient is positive for f, which is on this side. Okay, and then when f is positive, the other one must be negative. So that is either sides of the domain. Question number 7, which is the 3D trig. They are telling us that a telephone cable is to be created between two cliff sides, AED and BE. An engineer stands at a point C in the same horizontal plane as the foot. All right. Then they are telling us to show that the length of the cable is given by that. So the cable is created between two cliffs, AD and BE. So this is our cable. I want to believe so. Is that what they say? They didn't even tell us which side they are focusing on. But that is the DE, that's the cable of interest. Okay, so they want us to get the length. How many marks is it? So it must have a tan theta and a sine alpha. It's some sense here to find that. And then the sine, I'm gonna find that distance. And then from there, we can use the sine also. Okay, so let's start with this one. So from triangle DEF, we're saying that the tan of alpha, should I use the tan? Yeah, it's given as the adjacent, but we don't know what DF is. Okay, so tan is going to be a bit weird. That would be my last triangle, maybe. Let me start from BEC. So he's saying that the tan of theta is the opposite, which is EB over the x, meaning that EB is x tan of theta. Then I can now proceed and use the sign and say that the sine of alpha is going to be the opposite, which is EF over DE. But we want the DE, which is going to be the EF over the sine of alpha. Now, for us to get the the EF, we need to get the EB minus the FB. Okay. They told us that this is a y, meaning that this is a y here, which makes life easy now. So it's going to be x tan of theta minus the FB, which is a y. So let's punch that to the top, meaning that we're going to have x tan of theta minus y over the sine of alpha. Oh, that was a quick 5 marks. Then if x is that, y is that, and theta alpha 45, what's the distance between the cliffs? So we can use because they want the distance AB. Is that true? No, not AB. Yeah, it's the same as AB because they are focusing on DF, this distance. But we already have our DF. Is there anything that combines DF here? No, we didn't look at it. But it's fine. Let's do the substitution and find DF. But we're going to use DF, DE, because we now have our y, we have the missing parts, and we can do just the substitution. So I would prefer to use the tan alpha, which is EF, over DF, and then make DF the subject, which is going to be the EF over tan alpha. And we found our EF to be x tan this minus y. Okay, we say tan alpha minus y. We are dividing it by the tan alpha. Let's do the substitution. So 1000 tan of 45 minus 250 divided by the tan of 45. So this gives me 750 millimeters. Okay, so that is what we would have done with that. Question number 8, which is the Euclidean. Okay, so in the diagram, AD is a triangle that is having BC parallel to ED and AE parallel to that. It's also given that AB to BE is 1:3. Okay, and then AC is 3 units, EF is 6 units, and then CG is X units. They want us to get the length of CD. So these are parallel lines, okay? If they are parallel lines, then basically we must follow the same proportions, okay? So what we say is that if CD divided by CA should be the same as BE divided by AB. Reason is going to be the proportionality theorem because BC is parallel to ED. So we're saying that if our CD divided by 3 should be equivalent to 3/1. Cross multiply, CD becomes 9 units. Okay. Then they want us to get the value of X. Okay, this X here. So which lines are we focusing on? We can focus on this other section of parallel lines, these ones. Okay, because we said the whole of this is 9. If that is X, then this is gonna be 9 minus X. I don't know. Yes, that's what I'm seeing. Okay, so the whole of that is 9, so we're gonna focus on this over that whole part. So we still use the same proportionality theorem. So we're going to say if we have GD divided by the total distance, which is AD, this should give us the same as DF over the entire distance, which is ED. We're gonna still use the same proportionality theorem. GF is parallel to AE. So let's substitute that and we have our 9 minus X over the total distance, which is 12, is equal to 3/9. Cross multiply and let's see what we get. So that's gonna be, why must I multiply? So that's gonna be like a 36/9, which is a 4. Okay, so meaning it's gonna be 9 minus x is a 4, which means x is 5 units. Then they want us to get the length of BC. Okay, this length here. So one thing we need to do is just try to compare the sides. Okay, compare the triangles. So if this is a 1, and then this is 4 units, this is 3, and then that is what? That is 12. So we can see that the ratios are the same, 1/4, 1/4. Okay, so we can say that AB over AE. So AB over AE is equivalent to AC over AD, AC over AE, which must also be the same as BC over ED. BC over ED. This is going to be sides in proportion because the triangles are similar, okay? So that is one approach. Alternatively, one would start by proving that the triangles are similar. So we are saying it's 1/4 because the marks are really too much. Okay, so if we have 1/4, okay, it's equivalent to BC divided by, we know that this is a 6, this is a 3, which is a 9, meaning that our BC is going to be 9/4, which is 2,25 units. Then 8.4, the area of ABC, FD. Okay, be this one 4 times 3 over 3 times 4, meaning that we have 9/16. All right, question number 9. They want us to prove angle N. Let's call it N. Okay, so even this one, we can call it a 2 if we so wish. Then go on and tell us that number 1, we know that T1 and T2, T1 plus T2 is a 90. The reason, they turn perpendicular to the radius. Or you can tell us that will it be angles in a semicircle? No, it doesn't make sense for angles to be in the same. I would prefer the turn radius, T1 and T2. That makes sense. Then S1 and S2 is the one that's going to be angle in a semicircle. Angle in a semicircle. So if that is true, meaning that S1, okay, is going to be the same as T1. How is that possible? Because that's a 90 and 90, meaning that our T2 is going to be 90 minus T1. Okay, and then when you look at S1, it's going to be 90 minus S2. But we know that S2 is the same as, is it S2? Yes, S2 is the same as T2. And if S2 is the same as T2, therefore S1 is the same as T1. I think that is just enough for that particular part. Just that. Yo. Okay, question number 10, which is the last one. We get out of here. Okay, they're telling us that in a diagram, M is the center of the circle, and the diameter AB is produced to C. M is drawn perpendicular to AC, and then that is a tangent. Okay. Then, if that is a chord intersecting that, MB is twice BC. If D4 is X, okay, our D4 is X, they want us 2 other angles that are equal to X. Okay, so this is a tangent, this is that, so meaning that the angle A is going to be X. Okay, so A is X, we're gonna say it's a tan chord. And then, which other information were we given? nothing. Okay, so we're calling this x. If that is x, which means even D2 is going to be x. Angles that are opposite equal sides, because this is a radius, this is also a radius. If that is true, do we have any other x? I think that's all. That's all. Then can we prove that CM is a tangent at M to a circle passing through MED? MED. So for us to prove that something is a tangent, it's always the tan chord that must play the role. Okay, that is just one. Two, even the perpendicular can also help us in deciding that. So what we can start with is that if this is x, meaning that M1 is going to be twice x, exterior angle of a triangle. Okay, exterior angle of a triangle. Then from there, we could go on and say that our M2, this M2 here, is going to be a 90 minus the 2x. Okay, 90 minus the 2x. And we can say that that's basically tan radius. Okay, because this is a radius. Oop, does that even make sense? No, that can't be a reason. That could be probably the last part. We can say adjacent supplementary angles, because this is a straight line, this is a 90, all of that would be a 90, that's a 2x, okay? Then if that is a 90 minus 2x, okay, we know that this angle is going to be a 90, because definitely those are angles on angles in a semicircle. So if that is true, then where is our E? This angle here is going to be 2x. Because when you focus on the triangle MED, if this is a 90 minus 2x, which means this is 2x. And this 2x is the same as the 2x that we found there. Okay, so since E is the same as M1, therefore CM is a tangent. And the reason is going to be the converse of the tan chord. Okay, so that is how we would have proved that. Then can we prove that FMBD is a cyclic chord? Okay, so number one, we can start with the D3 and D4, or D3 and D2. I think that would be better. D3 and D2 to give us the 90. Okay, so we're saying D3 and D4. Let me just write it somewhere here. So D3 plus D4 is going to be a 90 angle in a semicircle. Okay, remember our target is FMBD. Okay, FMBD. So that's a 90. Then we also know that M1 plus M2 is a 90. Okay, so what does that mean? I want to use just the exterior, the opposite angles, okay, being supplementary. So we say adjacent supplementary angles. So therefore, FMBD is a cyclic chord. Reason being, opposite angles are supplementary. So the converse of opposite angles being supplementary. So this is a 90, and that's a 90. Alternatively, you could say this is a 90, and then M3 is a 90, and then you use the property of the exterior angles. Either way, okay? Then prove that DC squared is the same as 5BC. Okay, so what you need to do in this case, let me just erase this part here so that I can write it where people can see. I see. Okay, so we're going to focus on triangle DBC and DFM. Okay, so DBC as well as DFM. So we say that B1 is the same as F2 because of exterior angle of a cyclic quad. Okay, why can't I remove all of this? So DBC and DFM. Okay, so we're saying B1 is going to be the same as F2 because of the exterior angle of the cyclic quad. We agree with that. Then D4 is the same as D2. We proved that earlier on, that everything was X. Then we know, wait a minute, am I answering the correct? No, I'm answering 10.5, which is incorrect. It's fine. Let's finish with the 10.5, then you can go back, okay? Then lastly, so those are two, which means the other one is just going to be the third angle, means C is supposed to be M2, which is the remaining angle. So therefore, DBC is similar to DFM. Okay, so to prove that this squared is the same as that, we're gonna need to use some bit of Pythagoras here, okay? So if I use triangle MDC, okay, because that is the triangle that's gonna lead me to what I need. This is MDC, this entire triangle here, okay? I know that the whole of this is a 90. We saw that, no? The turn radius. Okay, so if that is true, then I can come down and say that my MC squared should be the same as the MD squared plus the DC squared. The reason that is basically the Pythagoras. Then what is our MC? They told us it is twice of they said MB is twice BC. Okay, so if this is a K, this must also be a K, so it's twice, so it's the same thing, meaning that my MC, wait a minute, MB alone is twice BC. If this is a K, this is gonna be twice K. That's the meaning, eh? So we're gonna have 3 BC squared. Our MB is this, which is twice BC squared, okay? Because this is a radius and this is also a radius, so they have to be the same. Then our DC, we can keep it because it's part of our solution. Then this is gonna be a 9 BC squared is equal to 4 BC squared plus DC squared. Let's move everything that side, so it's gonna be 5 BC squared, meaning that DC squared is 5 BC squared. Okay, that's fine. And then lastly, we proved that the triangles are similar, so this should be just a walk in the park. So you can say that DM over FM should be the same as DC over BC. Remember, we already proved that the triangles are similar. So if we do that, the reason is going to be similar triangles. So when you do your substitution, you're going to have √5 of BC over BC, which gives us 2025. Okay. Now, with this paper, we have 3 hours for 150 marks, and then the paper has 11 questions. Wow. Why so many questions? Okay, so the others are just basic instructions of paper 2. Then question 1, which is the statistics. Now, for some provinces are not including statistics within their scope for their own reasons, okay? But in Limpopo, we had statistics there. But of course, statistics, that will be just the grade 11 and grade 10 statistics, and not necessarily the grade 12 statistics. Okay, so with the first question, they're telling us that a certain grocery store's delivery service has grown over the past 2 years. And then the store owner did a survey on a specific day to improve their delivery performance. And then the following table represents this. Okay. All right. So we have the delivery time and then the performance, the number of deliveries. And they want us to complete the cumulative in the answer book. So I'll just put the cumulative just down here. So the first cumulative will always be the first frequency. Then 8 plus 5 is a 13. 13 and 12 is a 25. 25 and that is a 40. It's a 43. 43 and 22, that is a 65. 65 and that's going to be 90. That is 110, 125, 135, and then 140. That's my last cumulative. How many deliveries did we have altogether? Let's see. They never told us. That's weird. But it's fine. Let's take the 140 to be our last cumulative that we're getting. Then 1.2, they want us to draw an ogive to represent the information. How many classes do we have here? How many classes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, 10. Okay, so I'll just try to sketch an ogive this side and see. Okay, so if we have, let's use this color. Perfect. That is our cumulative. And then we can have the time in this format. Okay, so we know that the deliveries started at 8. Okay, so we can have this as 8. And then we can have 9, 10, 11, 12, 13, 14, 15, 16, 17. The last delivery was 18. 1, 2, 3, 4, 5. I don't need to count them. Yeah. Okay, so whenever we are plotting, okay, let me indicate this side. Our maximum cumulative is 140. So I can use 20, 40, 60, 80, 100, 120, and probably 140. All right. I'm sorry if the intervals are not that clear. It's just that it's a sketch. So we just need to have the shape. So whenever we are plotting, we said we only use the upper class intervals. Okay. So 9, 10, 11 up to 18. So 9 is going with 5. So I'll say 9 is 5, which is somewhere there. And then 10. Okay, 10, we're going to take a 13. And 13 is still below 20, which could be somewhere there. And then we have 11, which is a 25, slightly above 20. Okay, and then we have 12, which is a 43, slightly above 40, somewhere there. Why does it look like a line for me? Okay, then we have 65, slightly above 60. Let's have it somewhere there. Okay. And then we have 90, 90, 90, 90, 80. And then this is our 90 with a 14 somewhere there. And then we have 110. This is 100. 110 must be just in the middle there. For the 15, somewhere there. Okay, I hope it comes out. Then we have 125, 135. 125 is somewhere here. Okay. Then we have 135, slightly above that. And then lastly, we have 140. Guys, please forgive my graph, the way it is looking. Okay, then I'll connect this using the freehand. Okay, up to somewhere there. And then we just need to extend this to the starting class, which is the 8. So that is the OGIF, or the cumulative frequency graph, that the question is basically looking for. All right, then determine the 5-number summary of the delivery times from the OGIF. Why? Okay, so we know that from the OGIF, we need to get the minimum, okay? We need to get the maximum, we need to get the Q1, we need to get the Q2, we need to get the Q3. So we know that our minimum is 8 o'clock, no? Our maximum, we say that is 8. Our maximum is 1800. Okay, so the median, we know that half of 40, or half of 140 is 70. And 70 is somewhere around here. So if I draw a line and then it meets somewhere there, you can see that it is somewhere around the 13,5 or 13, something. Not so accurate, but that is the kind of time I'm ending up with. So I can say that my Q2 is a 13, let me just take 15 to be precise, but it's around 13, something. Then Q1, which is a quarter of 140. Okay, so 140 divided by, saying 140 divided by 4, which is a 35. Did we have a 35 in our cumulatives? 35? No. Let's just look at the graph and then we see. So 35 is somewhere around here. You draw the line up until it meets that. We're seeing that it is going to be after 11. Okay. So we can say maybe that is 11, maybe 36 or 11, 30 something. Then our Q3, what is 3/4 of 140? Okay, so it's saying 140 times 0, that, which is 100. Eh? So where do we find 100? Is 100. You draw a line, miss the graph, and then you're getting it after the 14th mark or the 14th hour. So meaning that it's around 14 something. I'll say 1430 or depending on how the graph will look like, okay? But remember, I don't have a graph, that's why I'm taking just estimates. Then they want us to draw the box and whisker. Okay, so let's see. My lines need to be investigated. Why are they so skewed? Okay, let's have that. So this is our minimum, which is 8. This is our maximum, which is 18. Okay. It's not going to make sense. Not making sense. So let's have 8. We have 10, 12, 14, 16, 18, and maybe 20. You say the minimum, this is the maximum. Our Q1 is 11, something, which is somewhere there. Our Q2 is 13 something, which is somewhere there. I'll put it somewhere there. Our Q3 is a 1430, which is also somewhere there. Then I'll just have my box drawn, and then I'll connect this. Then I'll connect that. So this is our box and whisker. Now, from my box and whisker, because I know the question is asking to comment on the skewness. So we can say that there is more space between the Q1 and the Q2. So it is skewed to the left. Okay, skewed to the left. Or it's negatively skewed. Then they're telling us if the store owner appoints 2 more drivers, the number of deliveries increase by 4 every hour. What influence will this have on the standard deviation? So for as long as the effect is uniformly distributed, the standard deviation will stay the same, okay? Can say stay the same, or we can say it's not affected, for as long as it is uniformly done. But if it's done for just some others and left out for others, then they'll definitely have an effect. All right, then question number 2, which is the box and whisker. So they're telling us the number of push-ups that can be made in 1 minute by the first team rugby players of a certain high school will be recorded. Box and whisker given below. So this is the minimum, this is the median, this is the Q3. So if the range of the data is 36, determine the maximum number of push-ups. So we know that range is given as the maximum minus the minimum. So if we want the maximum, we must get the range plus the minimum. So our range is a 36 plus the minimum, which is a 49. So what is a 36 plus 49? 36 plus 49, you're getting 8 what? That is 85. Okay, so this is 85 there. And then determine the lower quartile value if the interquartile range is 20. So we know that interquartile range, IQR, is the same as Q3 minus Q1. So if that is a 20, our Q3 is 75 minus the Q1, which we don't know. So switch positions, meaning that Q1 is going to be 75 minus 20, which is a 50 what? It looks like a 55. Okay, then 2.3, we have 2 players. Okay, 2 players that had the same number of push-ups. They did 8 more push-ups than the median value. Determine the number of push-ups that they did. Okay, 8 more push-ups than the median. So we know that the median is having a value of 64 push-ups. So what is 64 plus 8? Does it make sense? It is 72. This question is giving Metzlit vibes, ne? Yes. Okay, then 2.4, the average number of push-ups is 65. Comment on the skewness. The average. So average, I mean, how does it connect with the skewness? Okay. Unless if we look at how the median relates with the mode, but that's not important for this particular question. Okay. But let's see. If the 65 is greater than the median, but we said our Q1 is a 55. I don't know. Let's see. What is 64 minus 55? Because I don't need to use that whole thing. This is going to be a 9. And then this is going to be 11. So there's more space to the right. No? So I'll just say it is skewed to the right. The reason someone will say that the mean is greater than the median, which is the Q2. All right, then 2.5, the standard deviation is this. Determine the number of players whose push-ups was less than 1 standard deviation. So to be less, we need to get the mean, okay? And then you subtract the standard deviation. So the mean is 65 minus 10.91 or 10,91. So 65 minus 10,91, which gives us 54,09. Is that what the question is asking for? No, that's not what the question is asking for. The question is asking us how many players will have that. But we have the push-ups of the players in a certain high school. The box and whisker is given below. The range is 36. Do we know how many players are there? Nope. 2 players have the same push-ups, they did that. Well, we don't have the number. I don't know. Is there something that I'm missing? Any annexure? Nothing. So it doesn't make sense for them to ask us about the number of push-ups if they never gave us the push-ups in the first place, because this box and whisker simply represents a summarized sort of version. So this is what I'm getting, but I cannot draw a conclusion as into how many was determine the number of players whose number of push-ups this question is kind of vague for me. Okay. We move on to question number 3. Okay, so with the Gauteng people, this is probably where your paper is going to start from, the Euclidean. There's no statistics. Hallelujah. Okay, question 3 in the diagram below. A is -10 and -2, B is 10, 8, and then C is 11, -9 at the vertices of our triangle ABC. Answer the following questions. All right. Can we show that the equation of the altitude? Wow, now they're using big English. The altitude from C, okay, to AB, or from C onto AB is given us this. How many marks is this for the big English? It's 4 marks. Okay, so we know that altitude is basically height above something. Yeah? So if, let's say, we have our distance, which distance must make a 90 degree with whatever the question is asking for. So they want the altitude from C onto AB. These people, they want the height, technically. Remember, altitude must make 90 degrees with the base. So if this is the base, this is the height, which is the altitude. Okay, so we know that these two must be bisecting perpendicularly, and yes, there's trouble. Way in paradise. All right, so let's see. At least we have the answer. We cannot fail to get the answer if you've already given a hint. So let's get the gradient of AB first of all. Okay, it's going to be the change in Y over the change in X. So that's going to be 8 minus -2 over 10 minus -10. All right, so that is a 10 over 20, meaning that the gradient is what? A half for that. But we know that these two are going to be perpendicular. So we can say that gradient of the altitude is going to be -2, because we know that M1 times M2 must always give us -1. So if that is true, then we can use the point C and say that Y minus Y1 is equal to M into X minus X1. So that's going to be Y minus -9 is equal to -2 into X minus 11. We open that up. It's going to be -2x plus 22 minus 9. So it's a -2x plus, what's 22 minus 9? Is it 13? This is what I'm ending up with. Isn't that what the question wanted? Correct. So the question just wanted us to interpret the perpendicular lines, yeah? Hence, determine the coordinates of D, the point of intersection of the altitude, and they keep on using the word altitude. It's examiners, no? It's not fair. Big English for small learners. No, man. All right, so let's get the points of intersection. So the equation of this line, we need to find it. And then also the equation of this line, we already have it. So the only thing we need is the y-intercept, and then we have the equation. So we're going to say if we have y minus 8 is equal to a half into x minus 10. Let's open this up. It's going to be a half of x minus 5 plus 8, meaning that's a half of x plus 3. So this is the equation of that line. So a half of x plus 3. Now, when I solve these two simultaneously, I'll have a half of x plus 3 is equal to -2x plus 13. Let's move the 2 that side. Let's move the 3 that side. So what's a half plus 2? It's 5 over 2x. When you move that side, you're going to have just a 10. So that's a 20. So 5x is a 20, meaning that x is going to be a 4. Then we substitute this 4 back into this equation and see that y is going to be a half of 4, which is 2 plus 3, which is 5. So these are the coordinates of D, 4 and 5. This question. Okay, so we move on. 3.2, they want us to get the area of ABC. So we know that area of a triangle is given as a half multiplied by the base multiplied by the height. So the only thing we need is to get the distance AB, okay, using the distance formula. Okay, so we had our beautiful coordinates, which was a 10 and 8, then a negative 10 and negative 2. Negative 10, negative 2. This was 10 and 8. We got D as 4 and 5. We have C as 11 and something, 11 and negative 9. So let me get the distances for those two, and then I'll find the area. So it's going to be x squared. That's going to be 10 minus 10 squared plus 8 minus 2 squared. Okay, so that's going to be root of 20 squared. I go 20 squared plus another 10 squared, which gives us 10 root 5. And then the CD, okay, it's going to be square root of 11 minus 4 squared plus, can I say 5 minus 9 squared? It's the same thing. That's going to be square root of 7 squared plus, that's 9, which is a 14 squared, which is 7 root 5. So 10 root 5, 7 root 5, and then we just need to substitute into the formula of the area. Okay, so we know that the area is going to be a half times 10 root 5 multiplied by 7 root 5. So half of 10 is 5. 5 times 7, that's going to be a 35 multiplied by 5 again. That's 15 and 2, which is 17, which means it's 175. This is units squared. All right, then 3.3. They want us to get the size of A. By these people. We're saying this is 10 root 5. They want us to get this angle here. So there are two ways to getting this. It's either we get the distances BC and then AC, and then we use the cosine rule. Okay. Alternatively, since we already have this as a 10 root 5, I think this would be the quickest. We know that this is a 7 root 5. We can divide this into 2. So that this is a 5 root 5. And then remember this is a 90. So we can use our tan. Yeah, I think that's the quickest. Let's not use the cosine rule. So you're going to say that the tan of A is equal to the opposite, which is the 7 root 5, over the adjacent, which is 5 root 5. Because 10 divided by 2 is 5. So root 5 and root 5 will cancel, meaning that the tan of A is basically 7 over 5. So A is going to be the arctan of 7 over 5. Okay. So shift tan 7 over 5. I'm getting 54,46. Okay, so if I use this kind of approach, it might give some sort of misleading information. Okay, so let me rather not use it, because for me to use it, it simply draws an indication to say that D is a midpoint of AB, and yet the question never mentioned anything of the sort. Okay, yes, we can have a perpendicular, but at a different, not necessarily at the midpoint way. Okay, so I'm going to discard that. Okay, I'm going to throw away that. So rather, what I will do, if I use, because I need to find a distance, because that's the only way out for me to make life easy for myself. So let's get the distance BC. Okay, so if we find the distance BC, do we need a BC or just AC? Let's get AC. It's going to be easier for us. So when you substitute this AC, I should get something like a 7 square root of 10. Okay, that is the AC. 7 square root of 10. Now we have this, we have that. We need the distance BC again. Nope, we don't need the BC. We can use the area rule, whereby we know that the area, if we're focusing on the side of A, it's going to be area being a half multiplied by the AC multiplied by the AB, the sine of A. So we got 175 is equal to a half, or AC 7 root 10, multiplied by the AB, which we got as a 10 root 5, the sine of A. Okay, so when you do your magic, simply means that our sine of A is equal to 0.707, and then the shift sign will give us a 45. I think this is more reliable than the first one. All right, then we move on to question number 4. Question number 4, they're telling us a circle that has a midpoint, which is like the center. What are these people? Why are they like, no, man. It's inscribed in a triangle. AB is a tangent, P is that. A and B are the x and the y-intercepts of the tangent. O is the origin. Okay. It's examiners. It's like they had an agenda. Inscribed. Midpoint. All right, they want the equation in the form of that. So what we need to do is just determine the radius, okay, using the distance formula. So what we're going to do is, okay, so we need to get the distance PM. So under root sign, we shall have negative 18 over 5. We are subtracting a negative 2 squared. Plus 16 over 5, you're subtracting a 2 squared. So you punch that into your machine, you're getting just 2 units, okay? Then we just have to say that it's x plus 2 squared, plus we have y minus 2 squared, must give us this squared, which is like a 4. That's what the question wanted. And then 4.2. What is the mighty paper saying about 4.2? Okay, they want us to get the equation of the tangent. Now, whenever we find the equation of the tangent, we need the gradient. Okay, so we're going to say that the gradient of PM or MP. So change in y over change in x, which is 2 minus the 16 over 5 over negative 2 minus minus. This is negative what? 18 over 5. Okay, so when you simplify this, punch this, we're going to get a negative 3 over 4. So that is the gradient of the radius. Né? So gradient of the tangent is going to be the reciprocal of this with the negative sign, so it is a 4 over 3. Then we can say that y minus the 16 over 5 should give us the 4 over 3 into x minus minus the 18 over 5. Open up, make y the subject. So I'll end up with something like y minus 16 over that is equal to 4 over 3x plus probably that's going to be 6, which is like a 24 over 5. Okay, simplify further, we shall have a 4 over 3x. Okay, and then this is plus 8. So that is my answer for 4.2. 4.3, circle A is shifted 3 units up and then 1 unit to the right. And the radius is halved, so that we get a new circle. Can we write down the equation? Okay, so let's start by the 3 units up, 1 unit down, meaning that the x is gonna, because if it's moved 3 units up, meaning that we're starting from here. So you're gonna subtract. We're going to subtract, or we're going to plus a 3, which is like a 5 here. And then this one, if we move it 1 unit to the right, it's going to be a negative 1. So meaning it's going to be x plus 1 squared. And then this is going to be y minus 5 squared. We say the radius is half. So if it was 2, then it's a 1. So 1 squared is 1. Okay, so that is what we end up with. Then circle N touches the tangent AB at R. We want to get the coordinates of that. So we have the equation. We have the equation of the tangent. So let's solve the two simultaneously. So where there is y, we just substitute this. Let me come this side and say that the equation of our circle, we said it was x plus 1 squared, and then y minus 5 squared is equal to 1. But the tangent was 4 over 3x plus 8. So where there is y, let's replace it with that. Okay, so you're going to have x plus 1 squared plus, this is 4 over 3x plus 8 minus 5 squared is equal to 1. Let's open this up. It's going to be x squared plus 2x plus 1. We open this up, it's going to be 16 over 9x squared, because this is going to be a 3, né? Then 3 multiplied by this is going to be 4 times 2, which is going to be like 8x. And then 3 squared is going to be 9 minus 1 is going to be a 0. Let's get rid of the denominator. Oh, let's collect the like terms first before we get rid of the denominators. Okay, so when we collect the like terms, this and that's going to be 25 over 9x squared. That and that is going to be a 10x. And then this one cancels that. We have a plus 9 is equal to 0. Multiply through by 9, 25x squared plus 90x plus 81 is a 0. Okay. And then factors, we're going to have a 5x plus 9. And then we're also going to have a 5x plus 9 equal to 0. So the roots here are equal, meaning that the value is going to be negative 9 over 5. So that is the x value. The question is asking us coordinates of R. So if that is your x, we just need to substitute into the equation of y, meaning that it's going to be 4 over 3 multiplied by negative 9 over 5 plus 8. And what does that give us? It gives us a 28 over 5, meaning that our R is a negative 9 over 5 and then 28 over 5. So that's what the question technically wanted. Okay, then we move on to 4.5, determine the ratio of BR to BP. Where is BR? So they told us there's another circle that is touching that. So BR. So let me just extend this. I don't know if it is just in the same, because we say the coordinates are basically negative 1, 5. So let's assume it is somewhere here. And then this is R. Okay. It could be even over passing that side, no stress, no problem. Okay, so they want us to get BR to BP. BR and then BP. So meaning that these are more like similar triangles. Okay, so what are the coordinates of BP? Or coordinates of B? Because we got this as our equation 4 over 3, we got that as 8. Ne? So if that is 8, we need to find this distance, and then we also need to find the total distance. All right, so first things first, we need to get the distance BR, ne? Using the distance formula. So with BR, we're going to have a 0 minus 9 over 5 squared plus 8 minus 28 over 5 squared. And then for BP, 0 minus 18 over 5 squared plus we have 8 minus 16 over 5 squared. This is all under the root sign. So with the BR, we have a 3, and then with this, we have a 6. So in stock of BR, over that, it is 3 over 6, which becomes just 1 over 2. Then what conclusion can we be made about the ratio BN to BN? We must give the answer. And so we know that if this is 1 over 2, automatically we know that NR and MP, okay, NR, because this is N, saying NR and MP will also be a half. So it's saying Rn over MP must also be a half, because those are basically radii of the same circle. And we can see that the two triangles are technically similar. Okay, so we can use that sort of conclusion, and then we can say that Bn over Bn is also going to be a half because of similar triangles. Okay, that is question number 4. Wow, what a question. Question number 5, which is trig. If tan 41 is t, write down the value of the following in terms of t. We need to reduce this. If possible, we can even draw a sketch. I prefer drawing a sketch, even if the question sometimes doesn't need one. Okay, so if that is a 41, we know that tan is opposite of adjacent, meaning that this hypotenuse must be 1 plus t squared under the root sign. All right. So 319. Where do we find 319? Which quadrant is that? That is quadrant number 4. So 319 is the same as 360 minus 41. 360 minus 41. Good. It's the same as tan of 360 minus 41. And then the fourth quadrant, tan is negative. So it's the same as negative tan 41, which gives us a negative t. And then 82. So 82 is twice of 41, meaning that this is the sine of 41, but twice. So it's a double angle, meaning that's 2 sine 41 cos 41. But we know that the sine 41 is okay, then I'm multiplying it by the cos of 41, which is 1 over that, 1 plus t squared. Okay, so by the top, we shall have just a 2t over, when these two multiply, we just have something like a 1 plus t squared. So this is what the question basically wanted. And then lastly, they want us to get cos of 19 for 4 marks. Okay, so for us to get the cos of 19, we could look at some special angles. Which special angles can I look at, especially when I'm maybe focusing on the subtraction? Okay, what is 60 minus 41? Could be 19, yeah. So let me say that the cos of 60 minus 41, then I can use the compound angles and say that this is the cos of 60, cos of 41, plus the sine of 60, the sine of 41. So we know that the cos of 60 is 1 over 2, and the cos of 41 is 1 over the square root of that. So 1 over root of 1 plus t squared, plus the sine of 60 is root 3 over 2. And then the sine of 41 is t over that beautiful 1 plus t squared. All right, so we can see that the denominators are basically the same, meaning that I'm only going to have 1 plus root 3t. I'm dividing it by 2, 1 plus t squared. So that is what I end up with as my final answer for that. Then question number 6. Question number 6. Simplify the following. So reduction here. So let's see. 6.1. If it's doable. 6 out of 11. So 4 over 3. Saying 4 over 3. Okay, so 4 over 3 cos squared of 330 minus 1 over 2 cos squared of negative 45. We are subtracting 1 over 3, the sine of negative 30. So reductions of special angles. So where do we find 330? That's the fourth quadrant, which is 360 minus 30. But in that quadrant, the cos is positive. No? So meaning that this is going to be 4 over 3 cos squared of 30 minus, you know that the cos of a negative is the same as the cos of a positive. So this is not going to have any effect on that. So it's 1 over 2 cos squared of 45. And then pull out this negative. So it's going to be positive 1 over 3 sine of 30. Remember? Oh, they never told us that because they already say without using a calculator. Yeah. All right, so that's 4 over 3. We know that the cos of 30 is basically root 3 over 2. But this will be squared. Minus 1 over 2. We know that the cos of 45 is supposed to be 1 over root 2. But then when you square that, it's going to give us a half. Or you can say it's root 2 over 2. That's just the same thing. 1 over root 2 squared plus 1 over 3. The sine of 30 is just a half. Okay, let's simplify with the squares. So it's a 4 over 3 multiplied by 3 over 4. Now, this is going to be a half. The 2 cancels the 2, which means it's just the 1 left. Plus, this is, we said, a half, not a third. It's going to be 1 over 6. Now, this cancels that cancels it. So 1 minus 1 plus 1 over 6, meaning that our answer should be just the 1 over 6. All right, so 6 marks done. Then 6.2, we need to prove that the sine squared of 1 minus cos is equal to that. You can do this very fast for 3 marks. No? Why can't we do it here? So we know that cos, let's use the identity, is the same as 1 minus cos squared theta over 1 minus cos theta. So we're starting from the left-hand side. So difference of 2 squares, 1 minus cos theta into 1 plus cos theta. Everything is divided by 1 minus cos theta. So this cancels that. There's a minus 1 there. Okay. Then we have 1 plus cos theta minus 1, which gives us what? Cos theta, which is equal to the right-hand side. All right, I was worried because I'd left out that negative 1. Okay, then 6.3. 6.3, what are we doing? We are solving for a general solution. So we have sine 2, no, it's 2 sine squared a. Okay, this is 6.3. So 2 sine squared a plus sine a minus cos a must give us sine 2a. And then you're telling us that a must be, or sine of a must be greater than 0. In others, it should be positive. Okay, so what can we see here? What can we see here? Let's move this on this side. So 2 sine squared a plus sine of a minus cos of a minus, let's just simplify that, 2 sine a cos a is equal to 0. Okay, so I'll push, I don't know which one to push and which one to, that's just the same thing. I'll do the grouping. Okay, I can do the grouping here, this and that, and then all of this and that. So what's common? What is common there is going to be the sine of a. I have 2 sine a plus 1. What's common here? I'm going to take out the negative cos of a. I'll be left with 1 plus 2 sine a. So meaning that this bracket is common, which is 1 plus 2 sine a into sine a minus cos a is equal to 0. Okay, so how many marks? Should be like 6 marks, this question. Oh, it's 7. Hallelujah. Okay, so let's solve this. So with the first one, it simply tells us that sine a is going to be negative a half. In this case, we're going to say that the sine of a is equal to the cos of a, meaning that the tan of a is just the 1, okay? Now, after identifying something like that, since they told us that sine of A must be greater than 0, this is less than 0. So this is a not applicable kind of situation, or we're not going to use any solutions from it. Our focus is going to be this side. So let's get the reference angle by saying the shift tan of 1 should give us the A, which is like a 45. Okay, so we know that when the angle is 45, the sign is positive. That is quadrant number 1. In the second quadrant, we can have 180 minus 45, which is giving us 135. So in the first quadrant, we're saying A is going to be 45 plus 180 times K. K is an element of integers. Okay. And then with the second quadrant, it's going to be 135 plus 180 times K. K is an element of integers. But if the question want the exact values, we just said solve for A. Okay, so we can stop at it. We can stop at this, where we have the general solutions. All right, 6.4. Now they are twisting questions again. P is X and Y is a point on AB, whereby that angle is theta, the norm P is a rectangle, express BP in terms of Y and theta. BP, this one, in terms of Y and theta. So this is X, then this is Y. BP. Okay, so we can, which they want it in terms of Y. So we're looking at the opposite and we're looking at the hypotenuse, which is the sine. So 6.4.1, we're going to say that the sine of theta is equal to the opposite, which is Y, over the hypotenuse, which is BP or PB. Then just switch or cross multiply, meaning that BP is going to be Y over the sine of theta. I don't know, that's what I'm getting. 6.4.2, hence can we prove that AB, where is AB? So this is Y over sine of theta. AB, this entire thing, must be given as Y over sine plus X over cos. Hello? Okay, so what I can see is that if this is a theta, even this will be a theta in a way. But now we're focusing on the bigger picture there. Okay? If this is a rectangle, if that's a Y, this must also be a Y. If this is X, then this is going to be probably M minus X. So what do we do here? What do we do here? So we know that this line is going to be parallel to that line, technically. So if this is a theta, we could also look at just this triangle alone and say that the sine of theta is equal to the opposite, which is AN over the hypotenuse, which is AP. Okay, meaning that our AP is going to be the AN over the sine of theta. But the question is focusing on the cos. I don't know, why am I using sine again? That sine is not going to help me. Let me use the cos pattern C. Let me use the focusing on ANP. Let's use the cos. So cos of theta is the adjacent, which is NP, over the hypotenuse, which is AP, meaning that your AP is NP over the cos of theta. Okay. But they told us P is what? X. So meaning that my interpretation of this X was wrong. All of this is X. So it's going to be X over cos of theta. So for me to get the AB, is going to be the AP plus the PB. So the AP that we found was x over cos of theta, plus the PB that we found was y over sine of theta. Okay, question number 7. Question number 7. Telling us in a quadrilateral ABCD, these two lines are parallel, beautiful. AC bisects BCD. If our X is a B and then the C is 2Y. Now, if it's being bisected, simply means this is a Y. That's also a Y. Now, they want us to express DAC. DAC in terms of Y. So we know that DAC is going to be a Y. Okay. DAC is going to be a Y. Why? Because those are alternate angles. No? And then ADC. So if this is a Y, that's a Y, meaning that the ADC is going to be 180 minus 2Y, the angles in a triangle. So 180 minus 2Y. All right, then 7.2. Are we able to show, okay, that AC, this one, is given as this? So let's use they say A, this is A. So let's use the sine rule and say that A over sine of Y should give us AC over the sine of 180 minus 2Y. Our focus is the AC, so we're going to multiply that side. So our AC is going to be A. When we simplify that, that's going to be sine 2Y over sine Y. I think that's what the question wanted. We don't need to break that down further to give us A equals Y. Then can we show that AC will be given as this? So we're seeing signs all over. Okay. AC is having a BC. So we already found our AC to be A sine of 2Y over sine Y. Now, if this is a Y and then this is X, meaning that this angle here is going to be 180 minus X plus Y. Okay, because you add that and that to give us, okay. They want us to show that AC is still that. So what I can do, we have a BC of interest, and then that, okay, perfect. So I'll say that AC over we have the sine of X is equal to the BC over the sine of 180 minus X plus Y. So make AC the subject. So we're going to have a BC sine of X over, when you reduce this again, we're going to have just the sine of X plus Y. Okay, perfect. Then can we show that BC is given us that? So let's equate the two equations of AC. So BC sine of X over sine of X plus Y is equal to our AC that we found as 2. We got it as A, not 2. It's A sine 2Y. Divided by, we got the sine of Y. Okay, let's do the cross multiplication and leave this on one side. So you're going to have A. Let's break this down, which is going to be like a 2 sine Y cos Y. And now I'm multiplying it by the sine of X plus Y. And then I'm dividing it by the sine of Y and the sine of X, because this must go down, this must go up. So this cancels that, meaning that we have our 2A cos Y, the sine of X plus Y, and then we're dividing this by the sine of X. Okay, so that is what we have for that particular question. All right, question number 8, which is the trig functions, and telling us that the diagram below represents two graphs of trig between 0 and then 180. Then can we identify these functions by writing it in the form of So we know that 8.1, when you look at the F, between 0 up to 180, it's just in this format. So this looks to be like a sine graph, because you must just finish up this up to 360, then you're done. The maximum is 190, and then that. So what I'm going to end up with, it should be just a simple sine x. Okay. Then with the g, from 1 to -1, it's 180. That's going to be -180. So it's a negative, meaning that it should be a negative cos of x, no? By the look of things, because it is flipping. So if I have to extend this, it should be in that sort of format. So negative cos x. Then the range of g. So range is basically the y values for which the graph is valid. So you're going to tell us that -1 is less or equal to y, less or equal to +1. Then the period of f is just going to be a 360. Then the amplitude of g is just a 1. That's the maximum displacement that we can ever get. And then for which graphs will this and that be less than 0? So between 0 and 90, okay, we're saying that if this is a positive and this is a negative, so the graph of f is decreasing while g is above. Graph of f is decreasing in this section while g is above. So from 90 up to 180, okay, so we're seeing that. That's number one. So 90 up to 180. Okay. And then if this is a negative and this is a positive, so the gradient is increasing while this one is below. Increasing while the other one is below. F is increasing while below. So between 0, okay, so we can see that even between 0 up to 90. So it's the same as the entire thing actually, between 0 to 180. I don't know why we should break it down. So 0 to 90, 90 to 180. So even if somebody says 0 is less x and less 180, it will still be perfect. It would still make sense, okay? It would still make sense. Okay, so that is what we're going to say. But then remember at 90, both graphs are equal. Is that true? No, it's way far away. It's not. Okay, so that is 8.5 and question 8. Then question 9, we have our, does it look like Euclidean? Yes. AE is a tangent to the circuit O, or circle over D. AC is a straight line. BD or DCD are drawn. Okay, there we go. 9.1, what do they want? If B1, okay, is a 5/7, can we give reasons for ODE? ODE. So we know that this is a 90. Tangent perpendicular to the radius. So ODE is a 90. Reason, radius perpendicular to the tangent. 9.2. 9.2. They want us to get D3, this angle here. So for us to get D3, we know that this is a 57. We know that all of this is a 90. Then we can get this to be a 33. So start by getting C2. So tell us that C2 is a 33. Those are basically angles in a triangle. Okay. And then we're going to say that D3 is going to also be a 33. The angles are opposite, equal sides. Okay, so that is what we have with that 9.2. Okay. Then someone could also look at it in a different way. What do we mean in a different way? If they can find D1, And then they have found C1, which is the same as the D3. Okay, so if that is a 57 for D4 here, using the turn code. Okay, so D4, someone could say that D4 is a 57, meaning that 90 minus 57 gives us that. So either way, we'll get the same answer. Then they want us to get C2. So this is a 33. Must get C2. Oops, this other angle. Oops. So we're going to say that our C2 is going to be 180 minus 33 angles on a line, or adjacent supplementary angles. So 180 minus 33 is giving me 147. So that is how quick I would have obtained that for 4 marks. Because one, I've already clarified that my C1 was a 33. Who said C2, man? We said C1, not C2. We say something else, we write in something else. Okay, C1 is a 33, then yeah, so you get the 4 marks for that. Alternatively, somebody could find D2. Then after getting that, you focus on the exterior angle. You plus this 57 together with this 90. Does it make sense? Yes. 57 plus 90, we should get 147. And then you focus on the exterior angles of a triangle. Okay, so that is another way to kill this question. Question number 10, you must prove the angle at the center being twice angle of the circumference. Can we prove that theorem? So step number 1, construct. Okay, construct a line in that matter. So tell us that draw the line KO. Draw the line KO, produced to a letter maybe T. Produced to T. So what that does is it breaks this into 2. So if that is 1 and 2, okay, then we're going to say that O1 is the same as if I also break this down into 1 and 2. It's going to be K1 plus L. Okay, reason, those are exterior angles of the triangle. So this and that will be the same. But, okay, we know that but K1 is the same as L. Those are angles that are opposite equal sides, meaning that our O1 is going to be twice of K1. We do the same using that other triangle and say that our O2 is the same as K2 plus M, exterior angle of a triangle. But we know that our K2 is the same as M, angles opposite equal sides, okay? Because we know that this is the same as that already, meaning that our O2 is going to be twice K2. All right, then we know that O1 plus O2 should be the same as 2K1 plus 2K2. So twice K1 plus K2 is the same as this angle, LOM, okay? Which means that LOM is the same as twice K1 and K2 is the same as LKM. So that is what we get for that particular question. All right. So those are the 5 marks for that question. And then 10.2, O is the center of the circle. So whenever they give us the proof question, chances are high, whatever follows should be an application, okay? So then, if XY is a tangent, okay, the circle Y, X, P, Q, U, and Y, S, T are straight lines at that. Let me just do this. Okay, and then Y1 is M. Okay, this is M. All right, so 10.2.1. Did I skip a question? No, I haven't. I haven't skipped a question, not at all. Okay, so the first question, can we write down with reasons the other angles that are equal to M for 3 good marks? Wow. Wow, let's get these 3 marks. Okay, they want 3 angles with reasons. Ne? Okay, so I'll say this is 10.2.1. So which other angles are the same as M? Number 1, we have T1, because that is like a tan chord. Okay, this is M. Then, which other angle do we see? What did they tell us? XY is a tangent. They told us that PX and PY are the same. So this and that will be the same. So if that is true, meaning that the angle X is also M. Angles opposite, equal sides. So this is also M. So we have this one. Then which other angle can we look at? Do we have a butterfly somewhere? I guess so, because I'm seeing this and that and that and that. Meaning that if we have this, that's not coming out the way I want it. It's not coming out the way I want it. Okay, so let's look at the circumference. Let's look at the circumference, because this one is at the circumference. This one is at the center, which is going to be like 2M. We need another angle. They said 3 or 2. I might be doing a whole lot of things yet. Oh, they said 2. Oh, thank goodness. Because we're going to sleep here looking for another M. Okay, write down with reasons 3 other angles that are equal to 2M. Oh, we've already found one. So O1 is 2M. Hallelujah. So it's 2M. Reason is going to be angle at the center. Must be twice angle at the circumference. So if that is 2M, okay. Tangents and what? Do they make sense? We need to look for another angle. We need to look for another angle. So if this is that and that is that. So what is T? No, that's not going to make sense for me, because T is not going to work for me. Let's look at P3 and see. P3, would that make sense? Where I look at this angle. Yeah, it would make sense because it is exterior to these two. So we're saying P3 is going to be 2M. That is exterior angle of triangle XYP. Okay, so this is a 2M. Do we have any parallel lines? No, we don't have parallel lines. So we need to look for the last one, which now brings me to the bow tie. It is this and that, same coordinate or angles in the same segment. So it means T2, this angle in this one will be the butterfly or the bow tie. So T2 is 2M, angles in the same segment or angles subtended by the same chord. So that is what we needed for 6 months. Hallelujah. We move on. Question number, last one. ABC. Okay. ABC is acute angled, that is inscribed, again, big English. CF and BE are perpendicular. CF and BE are perpendicular. Oh, wait a minute. What did I do? They said CF and BE are perpendicular to BA. Where is BA? CF, okay, and BE. This one. They're perpendicular to that and perpendicular to that. Okay, CD is the same as DB. Okay, already given. OA is produced, custard, the circle, G is drawn. Beautiful. Let's see. What do you want now? Question, what do you want? Can we prove that AFDC is a cyclic chord? AFDC. Okay, so if this is a 19, this is also 19. I want us to prove that this thing is a cyclic chord. So remember, with the cyclic chord, only thing we need to prove is that opposite angles are supplementary. We need to also look at the exterior aspect and also focus on the bow tie. Okay. So 11.1, we're going to say that D3, okay, this is going to be a 19. Why? So D3 is a 19. Where can I write that? Let's put it here. D3 is a 19. Line from the center bisecting the chord must be perpendicular to the chord. So line from the center, or we can say the perpendicular bisect. Oh, is that correct? No. It's a line from the center bisecting the chord. That's perpendicular to the chord. Okay, so if that's a 19, are we going somewhere? Then we know that F3 is a 19, which is given to us. And if that is true, so if this is a 90, this is also a 90, then we have the bow tie. Hallelujah, that is done. That is done. And we're saying that since D3 is equal to F3, therefore AFDC is a cyclic chord. We're using the converse of angles in the same segment. Okay, so that is that. And then can we prove that C2 is the same as C3? Can we prove that C2 is the same as C3? So in other words, they want us to prove that this line bisects those two. Okay. So what we need to do is, what is C2? We know that C2 is going to be the same as A1. Okay, since we've just proved the bow tie kind of approach. So C2, let me just use this. Okay, C2 is the same as A1. Okay, because of that. Then, in the same respect, we can say that A1 is the same as C3 because of, again, the bow tie. There's another bow tie, this one, this and that. But since we proved that this is a cyclic chord, then this and that will be. So now, since we've seen that the both of them are that, then C2 will be the same as C3. Oh, we need to give reasons now. It's going to be angles in the same segment. Same story, angles in the same segment. And then we move on. We move on to 11.3. Can we prove that ABD will be similar to CGD? Let's see. ABD. Where is ABD? ABD. ABD, this one is similar to CGD. to CGT. Similar to that. Okay, so let's highlight what we see from the two triangles. Let me just put it in. So one thing I know is that the whole of this D4 is the same as D2 and D1. Those are vertically opposite. We know, because when you're proving this, you need to use angles, strictly angles. Now we saw that this is the same as this, meaning that this should be the same as this entire thing, B1 and B2. Okay, so we're saying that B1 plus B2 must give us G. Those are angles in the same segment. Then we're saying that D1 plus D2 must give us a D4 vertical angles. And then we say C3 is equal to C1. We've proved that in the previous question. Therefore, CGD is similar to ABD because of angles. All right, so that is how we prove that. And then lastly, 11.4, can we just sort that out? So we know that in the triangle OCD, GCD, because these are the triangles we're focusing on, okay? We're saying OCD, how is OCD a triangle? It is, Malumi, because we're focusing on this. Because this is also similar to those two. Okay, there's a 90, this is also a 90, this is a 90, those are the same. This was the same as that. And then which means this will also be the same as that. So we know that those two triangles are similar. So what we're gonna say? What are we gonna do? What we're gonna say? Because it is 6 marks. Can say that C2 is the same as C3. We've proved that. We've proven that one, okay? Then D3 is the same as D4. Okay, what is the reason for that? So D3 is the same as D4, angles on a line, which is also a 90. Okay, angles on a line. Then CD will be also CD, which is common, meaning that the two triangles are congruent. Therefore, we're saying OCD is congruent to CGD. So the same thing. So if that is true, we're going to say that AB over CG should be the same as BD over DO. Okay, so that is what they needed, because if the two triangles are formed, then these two sides are equal. Boom. Okay, guys, out of 100, I can rate this paper to H because of the big English and, let's give it a 95, guys. It wasn't that bad, but it was fair. Okay, so guys, I'll stop there. I wish you all the best in your preparation. Let's meet when we look at the memo of other provinces for paper 2. Bye-bye. Hello, welcome you to this episode where we shall be looking at the proposed memorandum of Limpopo Grade 12 Mathematics Paper 2 for June 2025. Okay. Now, with this paper, we have 3 hours for 150 marks, and then the paper has 11 questions. Wow. Why so many questions? Okay, so the others are just basic instructions of paper 2. Then question 1, which is the statistics. Now, for some provinces are not including statistics within their scope for their own reasons, okay? But in Limpopo, we had statistics there. But of course, statistics that will be just the grade 11 and grade 10 statistics and not necessarily the grade 12 statistics. Okay, so with the first question, they're telling us that a certain grocery store's delivery service has grown over the past 2 years. And then the store owner did a survey on a specific day to improve their delivery performance. And then the following table represents this. Okay. All right. So we have the delivery time and then the performance, the number of deliveries. And they want us to complete the cumulative in the answer book. So I'll just put the cumulative just down here. So the first cumulative will always be the first frequency. Then 8 plus 5 is a 13. 13 and 12 is a 25. 25 and that is a 40. It's a 43. 43 and 22, that is a 65. 65 and that's going to be a 90. That is 110. 125, 135, and then 140. That's my last cumulative. How many deliveries did we have altogether? Let's see. They never told us. That's weird. But it's fine. Let's take the 140 to be our last cumulative that we're getting. Then 1.2, they want us to draw an ogive to represent the information. How many classes do we have here? How many classes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, 10. Okay, so I'll just try to sketch an ogive this side and see. Okay, so if we have this as our, let's use this color, perfect. That is our cumulative. And then we can have the time in this format. Okay, so we know that the deliveries started at 8. Okay, so we can have this as 8. And then we can have 9, 10, 11, 12, 13, 14, 15, 16, 17. The last delivery was 18. 1, 2, 3, 4, 5. I don't need to count them. Yeah. Okay, so whenever we are plotting, okay, let me indicate this side. Our maximum cumulative is 140. So I can use 20, 40, 60, 80, 100, 120, and probably 140. All right. I'm sorry if the intervals are not that clear. It's just that it's a sketch. So we just need to have the shape. So whenever we are plotting, we said we only use the upper class intervals. Okay. So 9, 10, 11 up to 18. So 9 is going with 5. So I'll say 9 is 5, which is somewhere there. And then 10. Okay, 10, we're going to take a 13. And 13 is still below 20, which could be somewhere there. And then we have 11, which is a 25, slightly above 20. Okay, and then we have 12, which is a 43, slightly above 40, somewhere there. Why does it look like a line for me? Okay, then we have 65, slightly above 60. Let's have it somewhere there. Okay. Another episode where we're going to be looking at the mathematics paper 2 for Gauteng province. Okay, this time round, there is a cute presentation where the question paper is merged with the answer book. That is fine. We shall see how we can do. Question number 1. They're telling us that the table below shows the monthly salaries of 100 employees at that law firm. Okay. Then 1.1, they want us to draw an ogive to represent the data in the table. So step number 1, what we need to do is we need to first of all complete the cumulative frequency column. Okay. And if that can be done, then we shall be in position to draw our ogive or cumulative graph. So first cumulative will be a 3. Then 3 plus 4, that's going to be 7. Then 7 plus 13, that's going to give us a 20. 20 plus 20, that's a 40. 40 plus 21, that is a 61. And then plus 12, that's going to be a 73. Plus 12, which is 85. 85 plus 8, that's going to be a 93. And then a 98. And then lastly, we have 100. So those are the cumulative values that we needed. Okay. Then we go down and plot the graph. Remember, when you're plotting, we always look at the upper class intervals. These ones, they are the ones that we use against the cumulative. Let me just use a red one. Okay. So it's saying 0 is going with 3. 0 goes with 3. No, not 0. It's 10. 10 goes with 3. So if it's 10 runs or 10,000 runs, those are 3 threes somewhere there. Okay. Then 20, we say it goes with a 7. 20 is a 7. So let's locate where 7 is, slightly above the 5. Okay, then 30, we say it goes with a 20. This 30 here must go with a 20, then a 40. Okay, 20 is there. Then a 40 for 40. Okay. And then we said we have 61. The next one must be 61. 61 is slightly above 60. Then 73 for the next one, slightly below 5. And then we have 85, which is exactly in the middle there. We have 93, which is slightly below. Then 98, somewhere there. And then we shall have 100, which is at that point. Okay. Then from there, what we can do is just connect the dots so that we get the S kind of graph. Okay. So if I use my dotted lines, I'll start with the dotted lines and have, no, let me just connect it once. Okay. So something like that. Connect this to that. Okay, let's remove this and reconnect it again. And then we connect this to the original class interval, which is a 0. Okay. All right, so this is our cumulative graph that they needed. Then question number next. Question number next, what do they need? They want us to use the ogive to determine the number of employees that received less than 35,000. Okay, so for us to get 35,000, come to the salaries. We come to the salaries and look for 35,000, which is halfway here. Then let's draw a line up until it meets the ogive. Okay. He's saying we are drawing a line from 35,000 up until it meets the ogive, and then we read the value on the side. So we have 30 people altogether. Okay. So that's going to be 30 employees. All right, then next question, determine the median. So for us to get the median, we know that we have 100 employees, so we need to get a half of 100, or you can say half of 100 plus 1, which will give us a 50 or 50,5. Then let's look for 50,5. I'm going to just look for 50. So this is a 50. Follow this line of 50 up until it meets the ogive, somewhere there, and then let's take the reading. So this represents the median, which is 45,000. Okay, so median data will be 45,000 rands. Okay, 1.4. They're telling us that the monthly monthly salaries of 5 employees within this interval are listed below. Then 2 employees from one other interval were promoted and are receiving 83,000. And then they're also receiving 84,000, which is somewhere there. Then the question is asking for the monthly mean. So if you punch this into your calculator using the start functions, so that's 83,000. We have another 84,000, then 84,000. We have 85, then we have 87, we have 89, and then lastly we have 89. Okay, perform the functions. What do we need? We need the mean. So the mean becomes 85857,142. Okay, and then they want us to get the standard deviation. So shift 1, 4, and then 3. I'm having 2294,63. Okay, 2294,63. So that's my standard deviation. Then 1.4.3. They want us to get the percentage of employees whose monthly salaries lie within 1 standard deviation. So let's get the interval of the mean minus the standard deviation, and then the mean plus the standard deviation. So if it's 85,857,14, we subtract the 2294,63. That's for the minimum, and then for the maximum, it's going to be 85,857,14 plus 2294,63. So my interval is basically 83,562, because this 85,000, it is going to be 83,000, okay? That's 51. And then the upper limit is going to be 88,151,77. Okay, so after getting this interval, then I need to count how many data pieces. Remember, I'm dealing with 7 data pieces and no longer 5. Okay, so above 83,000, so I have this one, the 84. I have the 84, I have the 85, I have 87. 89 lies above or outside. So it's 1, 2, 3, and then 4. Determine the percentage of employees. So since we're looking for percentage, we're going to have 4 over 7 times 100. Okay, 4 over 7 is giving me 0.57, which is now 57.14%. So that's what the question was asking for. Now remember, this is just the proposed memorandum. Memorandum is yet to be out. Okay. Let's look at question 2. Question number 2. Question 2, we have the bivariant. During a netball tournament, we have several stalls that's selling food and refreshments. In a period of 10 minutes, at 6 stalls, the following were observed. So we look at the number of customers and then the amount of money that was spent. Okay, we can show this information. And then we have our scatter plot drawn for us. And then the first question is asking for us to determine the equation of this regression line. Okay, so if you follow through with how this is done, using the mod start, and then you look for the AX plus B, which is option, I think, number 2, and then just feed the data into the calculator, and then look for the values of A and B. So we know that the general equation of the regression line should be given as A. It's a small a, capital A, it doesn't matter, plus BX. Okay, so from my calculator, I'm getting A to be 12,596 Let's just make it 12,60 plus the B, which is a 17,33 x. So that is the equation. Then predict the amount of money that is spent by 11 customers. So the customers in this case are representing the X. Okay. And then the amount spent is representing the Y. So since we're looking for the amount of money, which means we're looking for the Y, which is 12,60 plus 17,33 into 11. When I punch this into my calculator, I'm getting 203,23. So this is how much will be spent by 11 customers or clients. All right, then next one, they're telling us to determine the correlation coefficient. So still when you use your data and calculator, I'm getting the R of 0,9. If I round it off, I'll have 9.5. Okay. Then the organizers of the event think that there is a very weak positive correlation between the number of customers and the amount of money that is spent. Motivate whether you agree or disagree. Okay, number one, I will disagree with the fact that this weak whatever definition is wrong. When I look at the correlation coefficient of 0,95, this is a very high positive, or it's a very strong positive correlation. Say agree or disagree. It is a strong, or we can say very strong positive correlation. Positive correlation. Okay. Alternatively, when you look at the points, yes, they're a bit far away, but that wouldn't define anything because the closeness would probably look at the correlation value. Okay, the points are not far apart. They are just close to each other. All right, so that is 2.4. Then 2.5, we have another store that is having 6 customers that spent 195. If this point is included in the data, will the gradient of the least square increase or decrease? Okay, so if I look at 6 and 195, so 6 is somewhere here, 195 is somewhere there. So in other words, this point is going to be an outlier, okay, compared to all the other pieces of data. And the fact that it is moving towards the y-axis, it's going to affect the gradient, okay? So if this point is included, will the gradient increase or decrease? Motivate your answer. So if it's going to attract the least squares regression line towards itself, which means the gradient becomes smaller, it's getting flatter and flatter. So my argument is going to be decrease, okay? Why? Because 6 and 195 is an outlier. This is an outlier that changes the gradient of the least square or of the regression line towards itself. All right, so that is 2.5. And then we'll look at 2. No, that is just the end of question 2. Let's look at question 3. In the diagram below, we have P, which is -9 and 12. Q is 9 and 9, are vertices of a triangle. M is the midpoint. I need to highlight this of the line QR. N is AB, is a point on PM. Okay. In the second quadrant, the equation of QR. Okay, this equation is given as 2y minus 3x plus 9 is 0. The angle of inclination of QR is theta. Good. And then they ask us to calculate the coordinates of M. So we know that M is on the x-axis, or it represents the x intercept. Under the x-intercept, we know that y will always be a 0. So what I'm going to do where there is y, I'll put a 0. So that's going to be 2 times 0 minus 3x plus 9 is a 0. So negative 3x, let's move the 9 to that side, is negative 9. Divide both sides by negative 3, which means x is a 3. So the coordinates of M are basically 3 and 0. Okay, we move on to the next question. Next question. So remember, we say this is a 3 and 0. Okay, next question they're asking us, determine the equation of PM. Let's look at PM. PM. So we have this point M, and then we have this as well. So we can find the gradient. Gradient of PM will be change in y over change in x, which is a 12 minus 0 over negative 9 minus 3. So it's 12 over negative 12, which must give us negative 1. So if the gradient is negative 1, we can use the point 3 and 0 and say y minus y1 is equal to m into x minus x1. Substitute into that formula. Y minus 0 is equal to negative 1 into x minus a 3. So y becomes negative x. That and that gives us a positive 3. So that becomes the equation of PM. Then they want us to get the size of theta. Okay, we need to find the size of theta. So what we're going to do here is we need to find the gradient of QR. Okay, from this equation, we can find the gradient, or you can use these points Q and M. You get the gradient. So gradient of QR, we're using 9 and 9, then we have 3 and 0. No? So it's 9 minus 0 over 9 minus 3, which is a 9 over 6, which is by 3 is a 3, by 3 is a 2. No? Then we know that the tan of theta should be equivalent to M, which means M. We have our M as 3 over 2. So which means for us to get the theta, let's do the substitution. It's going to be the shift tan of 3 over 2. Okay. Shift tan of 3 over 2, that's giving me 56.31 degrees. Okay. So if this is a 56.31, let's look at the next question. They want us to show that B. They want us to show that P is given as that if P, N, and M are collinear. So collinear simply means that the points are just lying on the same straight line. And for as long as points lie on the same straight line, the gradient between P, N is the same as the gradient between N, M, and the same as P, M. So I know for sure that the gradient here, because the question asks for the gradient, we got a negative 1, not so? Gradient of PM. So I can use, let me use N and M. Okay. So N is AB, M is 3, 0. Let me use this and equate it to the gradient of negative 1. So I'm going to say change in Y over change in X. So it's going to be a B minus 0 over A minus 3. This must give us negative 1. Cross multiply. So B is going to be negative A plus 3, or the other way around, 3 minus A. Okay, so that is 3.4. Then 3.5. 3.5, they're asking us to hence determine A and B if NQ is 5 root 5. Where is NQ? So from here up to here, that's a 5 root 5. So since I already have my coordinates of B, or my value of B, remember the previous question told us it's a 3 minus A. So let's use this, substitute into that using the distance formula. Okay. So I'm going to say that the distance NQ is given as the square root. I'm going to have 9 minus a squared plus, can still have 9 minus 3 minus a. This must be squared. Let's substitute. So 5 root 5 is giving us the square root of, let's open this up. That's going to be 81 minus 18a plus a squared. Simplifying this in the brackets will just give us a 6 plus a. Let's open that up. 6 squared is a 36 plus 12a plus a squared. Let's square both sides to get rid of the root sign. So if I square that and square that, that's going to be 25 times 5, which is 125. How many a's are there? There are 2 a's. Minus 18 plus 12, that's minus 6a. 81 plus 36. Okay, that's giving me 117. Let me move the 125 that side. 2a squared minus 6a. That's going to be a minus 125 minus 117, which is 8. This must be equated to 0. Okay. Divide through by 2. A squared minus 3a minus 4 is equal to 0. Okay. Then let's get the factors. Let's get the factors. That is a minus 4, a plus 1, which means either a is a 4 or a is going to be negative 1. But looking at the position of a, okay, looking at point A, which means our a has to be a negative 1. Okay, so if that is true, we're going to substitute this into the formula of b. So which means b is going to be 3. Remember, we said it's a 3 minus a. So it's basically 3 minus 1, which is a 4. So a is negative 1, and then b is going to be a positive 4. So basically, that is what we would have obtained if we were to look for the values of a and b. Then 3.6. 3.6, they want us to get the equation of the circle that is having O as the origin. Okay, let me use a different color. So if O is the origin, and this circle must pass through point R, please, that's just the imaginary circle that I have. So which means if we can get this distance, OR, that's going to be our radius, okay? But for us to do that, we need the coordinates of R. Remember, they told us that M is the midpoint of the QR. Okay, so 9930. So we have 99, we have 30, and then we have R, which is XY. So that's Q, M, and R. So we know that from our midpoint formula, if we get X plus 9 divided by 2, must give us this 3. Cross multiply, X plus 9 is a 6, which means X is going to be a negative 3. Is that true? Yes, R is in the third quadrant where X is a negative. Perfect. Let's do the same with the Y. So Y plus 9 divided by 2 must give us a 0 cross multiply. Y is a negative 9. So which means the coordinates of R are basically negative 3 and 9. So for us to get the distance OR, we need to find the square root of 0 minus 3 squared plus 0 minus 9 squared. So that's going to be 9 plus 81, which gives us a square root of 90. And then from the equation of the circle, we know that this should be the general equation where a and b are the coordinates of the center. But we know that a and b are 0, so it's just going to be x squared plus y squared is equal to the root 90 squared, which is just a 90. So this is what the question wanted. Or alternatively, you can pull the 90 that side, you have x squared. Okay, let's see, you have x squared plus y squared minus 90 is equal to 0. There is no harm with this. So both answers will be correct. So that is 3.6. Then 3.7, there is an acute angle between QR and another line, mx plus 4, that is 45. Determine the possible value of values of m. Okay, so let's see. So if we have a line whose gradient we don't know, but the y-intercept is a 4, which means that line is in this sort of direction. I don't know where the lines are meeting, but let me just assume they're just in that sort of direction. Let me just erase out a few things. Let me take this out. Okay, so what they're telling us is that this angle here is a 45, because if I look at this other angle, it's going to be way bigger than acute. Okay. So we know that the y value is a 4. That's why I'm choosing that direction. Because someone also choose a different direction, but for as long as positive 4, this is the only possible option we have. So y is mx plus 4. When I look at this question, it's 4 marks. What are we going to do? So since initially we got our angle of inclination to be 56,3. This is my thought, okay? And I beg to be advised just in case I'm wrong. So if I try to get this entire angle, so that I look at the angle of inclination and find the gradient, I think that would make sense, because it simply means that I'm going to have 1. So I'm going to have this 56 plus the 45. Okay. So I'll go down and say that 56,31 plus the 45 plus the 45, that gives me 101. Okay. It's giving us 101,31 degrees. So let me call this a T A and X. So TKX will be that. Now for me to get the gradient of this line, remember it's sloping downwards, which means it's negative. Then I'll say M is equal to the tan of theta. So for me to get the gradient, I'll use the tan of 101,31. Punching this into the calculator, I'm going to have -4. Okay, let's see. We're having -4,9999. How many nines? There are 4 nines. Then 6 9, which is approximately -5. There are no other values that I can think of. Okay, so if the gradient is, sorry, the y-intercept is a 4, then we definitely expect to have one particular value, which is a -5. Guys, that would be my approach, okay? But I beg to be liberated, just in case it doesn't make sense. All right, then the next question. Next question, they are telling us, they drew for us this shape, okay? And then what do they want us to do? Oh, they wanted us to use it. Okay, no stress. No stress. We're done with that. All right, so that was question number 3. Then question number 4, are telling us that in the diagram, the equation of a circle that is centered at B is given by x plus 1 squared, and then plus y minus 1 squared equals 20. df is a tangent, beautiful, at a, d, and f. The x-intercept, the y-intercepts respectively, okay. There we go. C is -1 and 6. Okay, point on BF with BC that is parallel to the y-axis, and then this angle is a theta. Okay, so that's a theta, even this one is a theta. Beautiful. They want us to get the coordinates of B. Okay, so for us to get the coordinates of B, what we know, okay, what we know is that if this is a, I don't know, let's just get them from the equation of the circle without wasting time. So it's -1 and 1, period. Because we can get them from there, extract them straight away from there. Then 4.2, can we show that AC is square root 5? Show that AC, this distance here, is given as the square root of 5. So since we have this at 20, this 20 represents our r squared. So we need to find the radius itself, which is going to be the root of 20. I'm not going to simplify it. Let me leave it there like that. Then if the points here are -1 and 1, okay, let's get this off. We say -1 and 1, we can get the distance of BC. And since the line is part of the y-axis, which means this is 5 units, because it's 6 minus 1, which is 5, okay? Then we can find our AC using the theorem of Pythagoras. Why are we using the theorem of Pythagoras? Because we know that DAB is going to be a 90, because this is tan perpendicular to the radius. So I'll start by saying DAB, okay? DAB is a 90 degrees because tan perpendicular to the radius. Okay, then we said BC is 5 units. So for me to get the AC, if I use my Pythagoras theorem, this is going to be the longest side, which is 5. So it's going to be 5 squared minus root 20 squared. This must be under the square root sign. So we know that 5 squared is a 25, root sign falls off, minus 20, and then that gives us the root of 5. So that is 4.2. Then 4.3, they want us to get the value of theta. Okay, 4.3, we must get the value of theta. Not theta, tan theta, the tan of theta. So since we've got this as a root 5, we know that the tan of theta is the opposite of adjacent. Okay, so our opposite is a root 5. So I'm going to say that the tan of theta is the opposite, which is root 5, over the adjacent, which is a root 20. So we know that root 20 is the same as 4 times 5, which is 2 root 5. Okay, so root 5 over 2 root 5, this cancels that. That gives us a half. So tan of theta is equal to a half. And then can we show that the equation of AB is negative 2x minus 1? AB. Okay, so since we got the tan of theta to be a half, remember we say that M is also the same as tan of theta. So this half also represents the gradient of this line, because this is a theta also, and as much as this one is also a theta. So the gradient here, we're getting it as a half, so which means we can get the gradient of AB. These two lines are perpendicular, which means the products of the gradients must give us -1. So I'm going to say a half multiplied by the gradient of AB must give us -1. So gradient of AB becomes -2. then y minus y1 is equal to m into x minus x1. Which coordinates am I using? They want the equation of AB. Let me use -1 and 1. So it's going to be y minus 1 is equal to -2 into x minus -1. Open this up. That's going to be -2x minus 2. Move the one that side. It's -2x minus 1. So that is how we would have showed that. So that is 4.4. And then 4.5, they want us to get the coordinates of A. Coordinates of A. All right. How many marks is this question? Question is 4 marks. Okay, we can solve the two simultaneously. Since we have the equation of this line, which is -2x minus 1, we can find the equation of this line since we have the gradient. And then we equate the two, and then we're good to go. So what we're going to do, or what I'm going to do, I'll say that the gradient of BF is a half. And then one set of coordinates on this point is -1 and 6. It's going to be y minus 6 is equal to a half into x minus -1. So y is going to be a half x plus a half. Okay. I'm saying a half x because x minus -1 is giving us just a half. And then if we take the 6 that side, it's going to be plus 6. Okay. So that's going to be a plus 6. So which means the equation is going to be a half x plus 13/2. Now, this is the equation of DF. The equation of AB is say -2x minus 1. Okay, y is equal. So let me just equate the two and say -2x minus 1 is equal to a half x plus 13/2. Move this one that side. -2x minus a half x is equal to 13/2 plus 1. So 2 plus a half is -2, so it's -5/2. The -5/2x is equal to, and I simplify this, I have 15/2. Cancel the 2 out, then our x is going to be -3. So if x is a -3, we can substitute this into that equation and get the value of y. So it's going to be -2 times -3, which is a 6 minus 1, which is a 5. So the coordinates of A are -3 and then 5. Okay, so that is 4.5. Then let's see, do we have a 4.6? Yes. They want us to get the ratio of ABC to the ratio of ODF, just the areas. Ne? So let me look at ABC. So if I focus on ABC, this is going to be my base. And then this √5 represents the height. Okay. So that's going to be, let me just break it down, area of ABC. It's a triangle, so it's a half times the base times the height. So a half times √20, we said √20 is the same as 2√5. Okay. And then our height is also a √5. Okay. Then, if I simplify that, this √5 and 5, that's a 5 times 2 is 10 divided by 2, which gives me 5 units squared. Then for me to get the area of ODF, the big triangle, I need to get this distance to be my base. And then I know that my height is a 6, since the y, no, it's not a 6. It's not a 6. I need to find my y here. Okay, because that 6 is for the point C there. So what I'm going to do, let me get the equation of DF. Okay, the equation of df, we agreed that it's a half x plus 13 over 2. Okay, a half x plus 13 over 2. Okay, if I equate this to 0, which means my x is going to be 13. Okay, so which means this point is 13. If this point is a 13, which means our base is a 13, and then the y-intercept is going to be 13 over 2. So that's going to be area of ODF. That's a half. The base, we said 13, and then times 13 over 2. Simplifying this, I'm going to get 169 over 4. Okay, so that is 169 over 4. Then since we want the ratio of ABC over ODF, that's going to be 5 divided by 169 over 4, which becomes a 20 is to 169. Okay, 20 is to 169. So we can't simplify this any further. So this becomes our answer. Okay. Then that is 4.6. And I think it's the last one for question number 4. Then let's look at question number 5. Question number 5, I think I'll just work it out there since there's space. So simplify this into a single trig sum. So we know that 180 plus is in quadrant 3, and in that quadrant, the sign is negative. So it's going to be negative sine x, but everything is squared. And then the negative angle of sine is the same as negative sine of that angle over sine of 90 plus, that gives me a cos x. These are complementary angles. And then I know that tan is the same as sine x over cos x. We are subtracting a 1. Okay. And then let's cancel what needs to be cancelled. So this cos can cancel that cos. This sine can cancel that sine. The negative and negative will give me positive. So this gives me sine squared x minus 1. Then which trig ratio is this? I know that sine squared x can be written as 1 minus cos squared x minus 1. This cancels that, and we get an answer of negative cos squared x. Alternatively, what you can do here is take out the negative sign. You'll be left with 1 minus sine squared x. And this becomes a negative cos squared x. 6 marks, done. So most of the marks will be given within the reductions here. We have something like 4 marks there. Okay. And then 1 mark there, and the other mark could be somewhere there, or the simplification. All right, 5.2. They want us to use the cos of a minus b, which is given as this, to deduce this kind of expression. So what I'm going to say, and what I'm going to do, is I know that the sine of a plus b is the same as cos of 90 minus a plus b. I don't know if that makes sense. Would that make sense? The sine of 90 of that, okay? Then I can expand this and say this is my cos of 90 minus a. And you put these brackets, 90 minus a, and then minus b. And then I can do the expansion here using what we were given. So that's going to be cos of 90 minus a. Okay. And then the cos of b plus the sine of 90 minus a, and then the sine of b. So we know that cos of 90 minus will just give us the sine of a, and that is a cos b. Then this is going to be, let me put a plus for now. The sine of 90 minus is going to give me a cos of a, and then that is the sine of b. So this is what they needed. It's basically what they have there. So that's how we would have gone about this question. Then 5.2.2. So since we're using compound angles, which means even this should be using compound application. So 420, let me just break this down. So 420 is in the first quadrant, which is a 360 plus 16, then cos 15. Sine 300 is in the fourth quadrant, which is 360 minus 60. And then 105 is in the second quadrant. I cannot use 180 because that's going to give me something like a 75. Okay. Let me use 90. If I use 90 plus 15, I'll get the 105. Okay. The reduction of 360 plus, that's going to be cos of 60 multiplied by the cos of 15. Okay, so the cos of 90 plus 15, that's going to give me a negative sign, 15. Okay, so this is going to be a cos of 60, cos of 15. This and that will give me a plus sine 60, and then the sine of 15. So it's a compound angle of cos. So which means it's going to be the cos. What is 60? Is it a minus or plus? That's going to be 60 minus 15, which is the cos of 45. And the cos of 45 is the same as 1 over root 2. So that would be the answer if we don't have a calculator. Alternatively, some people would have a root 2 over 2. Nevertheless, that should be how this question should be approached. Then 5.3, given tan squared x into 1 over tan squared x minus 1. Can we prove this? So let me start from the left-hand side. I'll start by opening through. So I'll have tan squared x over tan squared x minus tan squared x. Okay, so this is going to give me just a 1 minus, I can change that to a sine squared x over cos squared x. Do the cross multiplication, find the LCM. So that's going to be cos squared x minus sine squared x over cos squared x. Okay, so I know that if I have a cos 2x, is the same as cos squared minus sine squared. Okay, so automatically I have my cos 2x, then over cos squared x, which is equal to the right-hand side. It's 3 marks, which means it was just a bit straightforward. Then for which values of x in the interval of 0 to 180 is this expression undefined? So one thing we know is that an expression will be undefined if the denominator is equal to 0. No? So I'm not going to look at the entire expression, but I would rather look at this simplified format of it. So I'm going to look at the denominator. Which denominator? Is cos squared x. Okay, so when do I have the cos squared x to be negative, to be a 0? Okay, so I'm saying cos squared x to be a 0. You can find the square root, and then we shall have a cos to be a 0. So x is basically 19. That's what I have, because cos of 0 is going to be a 1. And then the cos of 180 is going to also be something else, a negative 1. So there's only one value, which is 90. Okay. And we know that even tan is undefined at that point of 90, where the graph will have an asymptote. All right, then 5.5 next, 5.4. 5.4. What's happening with my 5.4? They want us to find the general solution of the equation. Okay, so we have cos 2x is equal to the cos of x. So the easiest way to do this is by breaking down this cos 2x, this double angle of cos, into the format of cos. So we said it is cos squared x minus sine squared x. So that's going to be the same as 2 cos squared x minus 1. So let's express this in that form. So it is 2 cos squared x minus 1 is equal to the cos of x. Let's move this that side. So it's 2 cos squared x minus cos x minus 1 is equal to 0. Okay, we can factor this out, or you can use your quadratic formula, no stress. So I'll have 2 cos x. This is just cos x. So I can have a 1 and then a 1 is equal to 0. So since that's a negative, I'll put a negative here, and this will be a plus. So which means 2 cos x plus 1 must give me a 0, which means cos x is going to be negative a half. Alternatively, cos x must give us a 1. So if I look at the negative a half, my reference angle, okay, so the shift cos of a half is going to be 60, okay? But in the second quadrant, that's when cos is negative. So I'll say quadrant number 2, I'll have 180 minus 60, that is a 120, plus k times 360. K is an element of integers. And then which other quadrant is this thing negative? Is quadrant 4. Quadrant 4 is going to be 300, because it's 360 minus 60. Let me put it aside. So negative 300 minus, so 360 minus that is the 300. So 300 plus k times 360, k is an element of integers. When we look at this other solution, cos of x is equal to 1. So the reference angle is going to be the arc cos of 1. Okay, shift cos of 1 gives me a 0. Okay, so which means the other solution is 0 plus k times 360. K is an element of integer. So we don't need to write the 0. You can just say k times that. Then the other solution will definitely be 360 plus k times 360. Is that true? What's the cos of 360? It's a positive one. Perfect. Beautiful. So that is k is an element of the integer. So those are the 4 solutions that we probably expected. No, there's something wrong here. Ne? This 300 cannot be, because in quadrant number 4, cos is positive. So it's 2 and 3, which makes this a 240. Yes. So it's a 240. And then that. So those are the solutions that we would have used for that particular question. 5.5. Okay. Given that the sine of theta is a half, calculate the numerical value of sine 3 theta. So there are 2 ways to this, of getting the 7 marks. We can use a simple sketch, if you so wish. Call this a theta. We know that sine is opposite over hypotenuse, so that this can be a root 3. Okay, without using calculator. We haven't used the calculator there. So 2 squared minus 1 under root sine, that is it. So we can have this format, or we can express this entire sine 3 theta just in form of sine theta. So that will be the same as 2 theta plus a theta. Let's expand this using the compound angles. So that's going to be sine. Okay, let's change that. So we're saying it's a sine 2 theta cos theta plus cos 2 theta sine theta. Okay, we know that sine 2 theta can be broken down into 2 sine theta cos theta multiplying by another cos theta plus cos 2 theta will be the same as 1 minus 2 sine squared theta. Okay, let me just put it that way. Okay, 1 minus 2 sine squared theta. I'm multiplying by sine theta again. So this becomes 2. We know that this and this is going to be cos squared, which is the same as 1 minus sine squared theta. And then this is going to be plus sine theta minus 2 sine cubed theta. Open this up. I have 2 sine theta minus 2 sine cubed theta plus the sine theta minus 2 sine cubed theta. When you add up, you have 3 sine theta minus 4 sine cubed theta. That is if I want to express everything just in form of sine. And then I don't have to use this triangle. So this is going to be 3 times a half minus 4 times a half cubed. So that's going to be 3 over 2 minus, that's going to give me 1 over 8. 1 over 8 times 4. 1 over 8 times 4 is also going to give me a half. You break this down, it's 2 over 2, which gives me an answer of just 1. So alternatively, what I would have done, instead of me breaking this down and down, just from this step, I would have simplified this to have a 2 sine theta cos theta squared, and then plus sine theta minus 2 sine cubed theta, and then just substitute. So it's a 2 times a half, and then the cos is adjacent of hypotenuse, so that's a root 3 over 2 squared plus the half minus 2 times a half cubed. So this cancels that. I'll have a 3 over 4 plus a half minus, that's going to be an 8, which is 1 over 4. And then 3/4 minus a quarter, you get a half. And then a half plus a half, which gives us a 1. Okay. So that is question number 5.5. No? And then question number 6. Question number 6, let me have it here. Question number 6, they are telling us that in the diagram below, we have f, which is the 2 cos x, is drawn in this interval. On the same grid, they want us to draw the negative 2 cos. So when you punch this into your calculator, using mod, I'll go to table, say mod and table, which is 3. I have negative cos 2x, close brackets. I'm starting from negative 180, positive 180 is the end, and then my step is 45. Okay, so if I look at my drawing, or if I look at the diagram, let me do it this side. So negative 180 is negative 1. Negative 135 is 0. Negative 90 is a 1. Negative 45 is a 0. Then 0 is going to give me negative 1. 45 is going to give us a 0. 90 gives me a 1. 135 is a 0. And then 180 is a negative 1. Then connect these points with your free hand. Now remember, that's a turning point, so it shouldn't really be that sharp. It should be a bit smooth. Okay. So we have that, and then that is our G. Then the next question, they want us to write down the period. So when you talk about period of 2g of x, so if g of x is given as negative cos 2x, so where there is x, I'm going to replace it with x plus 10. Okay, so that's going to be negative 2, okay, cos of 2 into x plus 10. That has no effect. Okay, so the only effect or impact we have is this 2. This 2 and that will give us a 2x, which 2x affects the period. So get 360 divided by 2, which is 180. Alternatively, what we can see is that we have 2 graphs of cos. in this interval of 360. So after 180, we have one graph, of course. The rest is just a shift. Then 6.3, use the graph to determine the values of x in this interval between 0 to 180, where f of x, g of x is less than 0. Okay, between 0 up to 180. They told us f of x times g of x is less or equal to 0. Now, what this means that either f can be above the x-axis and g can be below. Alternatively, f can be below and g is above. So I can see g is below, okay, while x is above, just between 0 and 45, between 0 and 45. So I'll say that 0 is less or equal to x, less or equal to 45. That is scenario number 1. Scenario number 2, where f is on top and g is below. So from 90 up to 135, you can see that g is above. And then 90 up to that, this one is below. So I'll say 90 is less or equal to x, and then less or equal to 135. So that is what we were meant to do in 6.3. Then 6.4, determine the maximum value of f of x minus g of x. So when we say f of x minus, it's like the difference between. When I subtract at this point, I have just a 1. Then here I have something like 1,5. Then here it's a 1, that's a 1,5. And then I think this is the biggest difference between the two graphs, okay? So this is 2 units and then plus 1 unit, which gives us 3 units. How many marks is it? 3 marks. That's like 3 units. No? It's 1 mark for 3 units. All right, then next 6.5. They want us to get the range of y is equal to 2 cos x plus 2. So 2 cos x, remember that is the f, okay? Now the moment we say plus 2, which means this graph is being shifted 4 units upwards, okay? So no, it's 2 units upwards, okay? So which means the new turning point will be at a 4, okay? And then this is gonna be negative 2 plus 2, which is gonna be 0. So we can say that the range of 2 cos x plus 2 is basically 0 less or equal to y less or equal to 4. That is the top part. But then if we have now the exponent involved, so which means the range of 2 cos x plus 2 is going to be the same as 2 to the 0. I need to be liberated if I'm going astray. Okay. Is that 2 to the 0 or 2 to the 1? Let's go back. Let's go back. We're talking of f, ne? This is f. This is f. We're moving 2 units up. 1 and then 2 upwards. Let's just confirm the question. It's a plus 2. Beautiful. So if it's a 2, which means it's going to be at a 0. And then if it moves 2, that's 4. So which means I'm going to have 2 to the 0 is less y less 2 to the 4. That's a 1 less y less 16. So this will represent our new values. Okay. We can't say otherwise. It's 2 units. 1, 2. Beautiful. So this is going to be the range that they need. 1 and 16. Okay, then 6.5 will be the last for question number 6. We'll look at question 7, which is the 2D, 3D trig. Okay. Question number 7. I'm telling us that in the diagram below, we have 2 vertical poles, AB and BC. Point E lies in the same horizontal plane as the bases DC. The poles, they gave us all these values. Beautiful. That's Y meters. Then the first question. Can we express BE? BE in terms of alpha and Y. BE, this distance. So if we look at this is a right angle triangle. We can use our trig ratios. So this is the opposite, this is the hypotenuse. So we can use the sine and say sine of alpha is equal to the opposite over the hypotenuse, which is a BE. Make BE the subject, which should be y over the sine of alpha. So that is 7.1. Then 7.2. 7.2. So I said y over the sine of alpha. Let's look at 7.2. Can we show that AB is 2y for 5 marks? They want us to show that this is a 2y. So what we can do, let's start by finding this angle here. Since this is a triangle, we can say that this angle BAE, right? The Bay angle, it should be 180 minus the 90 minus 3 alpha. Minus 2 alpha also, no stress. So it's 180 minus, that's 90 minus alpha, which gives me a 90 plus alpha. The reason for this will be angles in a triangle. Okay, so if this is 90 plus alpha, I have this side and then I have to look for AB, so I can use the sine rules. Okay, then I'll say that what I'm looking for the side. So let me start with the side and say AB over the sine of AEB is equal to my BE over the sine of B. Let's substitute. AB is what we want. It's going to be the BE, the sine of AEB over the sine of B. When we substitute that, so our BE, we said it's y over sine alpha. We're multiplying it by the sine of AEB, which is twice alpha. Everything is divided by the sine of B, which is 90 plus theta. 90 plus alpha. All right, so we simplify this. So I'm going to break down this sine 2 alpha so that I have y into 2 sine alpha cos alpha, but I'm dividing this by the sine alpha, the sine alpha here, over, when I use my reductions, 90 plus will give me the cos of alpha. So this sine cancels that sine, this cancels that, then I'll be left with 2 times y, which is a 2y. Okay, so that is the approach for 7.2. Then 7.3. 7.3. If it's further given that AF is 7 over 4 BC. AF. Let's do this. Where is AF? This distance here is 7 over 4 BC. What is our BC? Our BC is y. So this is 7 over 4 y. We just showed that AB is twice y. What is the question asking for? They want us to give the angle of elevation BAF, BAF, this angle here. So we can use, since this is a right angle triangle, we can get, what we call it? Okay, so we said we're going to use the trig ratios. So if this is our BAF, we say this is 7 over 4y, this is a 2y. So we can use adjacent hypotenuse, the cos. So the cos of BAF is equal to adjacent 7 over 4y divided by 2y. So the 2's will cancel out, and then BAF, the cos, should give me something like 7 over 8. Then which means BAF will be the arc cos of 7 over 8. Okay. When I punch this into the calculator, okay, 7 over 8, what we get? Well, we get 29 plus 28. I'm getting, let's see, that's going to be 28,955, but the question said nearest degree. So which means it's a 29. Okay, that is 7.3. And okay, the closure of 7. Let's look at question 8. Wow. The diagram below the circle passes through the points A, B, C, and D. Okay. AD is a diameter, which means there's a center somewhere there. And then BD and AC intersect. BD and AC intersect at a point H. And then this angle is 58. What do they want? They want us to get the size of B2. Okay. So for me to get B2, what I can see is that this angle here, for as long as we've just agreed that AD is a diameter, then that's going to be a 90 because this triangle is touching the ends of the circle. So it's saying, I'm saying, let me put it aside. Say B2 is going to be a 90. It's saying angle in a semicircle. Okay, so that is 90. Let me just put it nicely here. Then they want us to get B1. Let's see what's happening with B1. Where is B1? B1 is this one. All right. So what I'm going to do, if I look at A, B, C, G, it's going to form a cyclic chord. So I can start by finding this entire angle here. Okay. Then if I have the whole of B, I can get now B1. So I'm going to say B is going to be 180 minus 58. The reason is going to be opposite angles of a cyclic chord. Okay, then that's going to give me 122. Okay, so if B is 122, but B2 is a 90, which means B1 is going to be 122 minus 90, which is a 32. Okay, that becomes a 32. So if B1 is a 32, we agree. If B1 is a 32, they want us to get A2, this angle here. So we know that A2 is also going to be a 32. Angles in the same segment, because we can see the bow tie that is formed. So that is also a 32. The next, what do they want? They want that if it's given, let me just use this one. Okay, so if it's given that AB is the same as BC, okay, AB is the same as BC, where is AB? This one is the same as this one, okay. And then can we prove that AB is a tangent to a circle that is passing through AHD? Okay, we're saying AHD. Let me draw my circle here. AH. And what type of circle is this? Okay, it's fine. We don't care what type of circle it is. Let's see if we can have our AHB. So if we have a circle, we'll do that now. Didn't do that. It's a circle like that with a sharp point. Okay, guys, let's assume that's our circle of interest. They want us to prove that AB is a tangent. Now, the information that they gave us is very, very, very important, that those two sides are equal. So it simply means that this angle A3 should be the same as C1. Okay. Do we know those angles A3 and C1? We don't know. Let's get them. Okay. So we're going to say that A3 and C1, let's get, but why should we go through that? Okay, it's 122. It's 180 minus 122 divided by 2. The reason is going to be angles opposite equal sides. So that's 58, which gives me a 29. So if that is a 29, it simply means that A3 is a 29, and then C1, A3 equals to C1 equals 29 because of the condition they gave us. Now let me use this 29 to find this angle here, D. Okay, because now my focus is now on this big triangle, ABD. Okay. Let me get the angles in a triangle. This is a 90, remember? This is 32 and 29, which gives me a 61. So I'm going to say that D is going to be 90 minus 61, which is 29. Now, since our A3 is the same as D, okay, therefore AB is a tangent. What I'm saying is that if we look at our drawing, if this is a 29, and we say this one is also a 29, this becomes a tangent because it will form the tan chord within that circle of ours. Okay, so it's a tangent, the converse of the tan chord. So that's how I would have approached 8.2. Okay. Then question number 9. We were given this drawing where the center of the circle, points S, T, and R lie on the circle. QS is a tangent. Use the theorem to prove the tan chord theorem. So step number 1, you have to do the constructions, please. So our constructions, I'll just make it pass through the center. Let's call this M. And then let's connect this to that point. Okay. So feel free, remember it's a construction. And with the construction, you can even be allowed to label in your own format. So I can call this 1 and 2. I can also call this 1 and 2. No stress. Okay. Then having done that, we can say that MRS is going to be 90 degrees. Reason, angle in a semicircle. It's an angle in a semicircle. If that is true, which means we can get R2, which is going to be 90 minus R1. You can call this our first equation. And let's come down here. I'm going to say QSO is also 90. The reason is going to be the tangent must always be perpendicular to the radius or the diameter. And then, which means that my S1, let me find S1. It's going to be 90 minus S2. Reason, these are adjacent complementary angles, the same as the equation. I'll call that equation 2. And then I'm going to put a but and say that my angle S2 is the same as which angle? Is the same as R1. So this angle is the same as R1 because of the bow tie. Okay. The reason is saying angles in the same segment. Angles in the same segment. Okay. So we're saying S2 is the same as R1. So where there is S2, I can replace most with R1. So S1 is going to be 90 minus R1. And we're seeing that this is the same as the first equation of interest. Okay. That is going to be the angle of interest. Okay, so since we've proved that S1 is the same as the 90 minus R1, which is our R2. So S1 is the same as R2. Therefore, you just draw the conclusion that QST is the same as angle R. So that is the proof for the 6 marks. The statements and the reasons play a big role. Okay. Then question number 9. Question number 9. They're telling us 9.2. that in the diagram below, DEF are points on the circle, and as a center Q, that line is a tangent to the circle that is produced to meet tangent AB. C are points on AE such that these two lines are parallel, beautiful. GC is joined. And then let's pay attention to this. GCDF. Okay? GCDF. They told us it's a cyclic quad. Okay, and then this is 2x. First question. The first question is, can we give reasons why E is x? So why is this angle x? So this angle at the center, that's the angle at the circumference. So we're going to say that angle at the center is twice angle at the circumference. So that will be my explanation for that. Then 9.2.2. Can we prove that GC is parallel to FE? Prove that GC is parallel to FE. So what I can see is that they want us to prove that these two lines are parallel. If this is x, which means F1 is also going to be x, I'm going to use the turn chord theorem there. And if that is x, remember they told us that this is a cyclic quad. It's this side. This is a cyclic quad. So if that is x, automatically this is going to be 180 minus x. So I'll say that C2 is going to be 180 minus x. These are the opposite angles of a cyclic quad. Okay, so if this is 180 minus x, I can see that C2 and E, when I add them, I get 180. So those form what we call the co-interior angles. So we're saying C2 plus E, which is 180 plus x minus x, gives me 180. Therefore, GC is parallel to FE. Reason to be the converse of co-interior angles. All right, so that is how we were going to prove that. Use the cyclic quad and then the co-interior. Now we've proved that these lines are parallel. Okay, we've proved that the lines are parallel. Now they want us to prove that AB over that is the same as that. So let's. Okay, 9.3, I want us to prove that. So what I'm going to do, I'm going to say that my AG. Okay, so AG over GF should be equal to AB divided by BD. That is the proportionality theorem. Okay, because GB is parallel to FD. Let me look at the bigger triangle since we know that these two sides are also parallel. So if I have AG over GF, should give me AC over CE. So same reason, proportionality theorem, because GC is parallel to FE. Now, since both have AG over GF, I will equate both and say AB over BD should give us AC over CE. So that is what the question wanted. And then 9.2.4, they're telling us that if it's further given that our AB is 12, okay, AB is 12, CE from here up to there is 22.5, and then they gave us this ratio. Let's simplify that. So if we have AG over GF, that's going to be 4 over 5. So if that is 4, then this is a 5. I want us to find the distance, CD. So from the ratios that we had earlier on, let's just use them and see. So AG over GF should give us, let me say AB over BD. First of all, let me have this as my X. Okay, AB over BD. No, let me get the word. Don't worry about the X. So our AG is 4 over 5 is equal to AB, which is a 12 over BD. Let's cross multiply. So BD is going to be 12 times 5 divided by 4, which gives me 15 units, which means from B to D, I have 15 units. Ne? Then let me look at that other triangle, the big one, where I have AG over GF is equal to AC over CE. Okay, so if I do my substitution, our AG is 4 over 5. Our AC, I'm going to say now it's 12 plus X over CE, which is 22,5. Let's look for X. So it's going to be 4 times 22,5 divided by 5, then we subtract the 12. This gives me 6 units for X alone. Now remember we said BD is 15, BC is a 6, so we can find our CD, which is 15 minus 6, which is basically 9 units. All right, then question number 10, they're telling us we have this diagram, KHG, there's a point on the circle, we have tangents, the circle, there's a semicircle and all of that. They want us to give a reason why DC and CE are equal. So we know that both these lines are tangents, but for as long as they are coming from a common point, then the tangents must be equal to each other. So the reason here is going to be tangents from a common point. Okay, those are tangents from a common point. So that is equal to that. Then they want us to prove that DCE is similar to HEK, DCE. So what we can know, or what we can see, is that this E2 is going to be the same as C. Okay, so E2 is the same as C. Those are alternate angles because EH is parallel to BC. Okay, that we know, we've stated. Now, what we can see is that as much as these two are equal, so if this is also E2, then this angle here is going to be the same as that. So I'll say that E1 is the same as D. These are angles opposite equal sides. Okay. And then also from this triangle, I can say that EH is a radius and EK is also a radius, which means that K1 must also be the same as H. Those are still angles opposite equal sides. But now, if this is the same as that, and this is also the same as that, if I were to call this E2, which means this angle here will be 180 minus, we have E2, and then we divide this by 2, which would be 90 minus a half E2. So 90 minus a half E2, same applies to this, 90 minus a half E2. So same story here, if this is E2, then even this one is going to be 90 minus a half E2, same as K1 also. So if that is true, then we can just go ahead and finish up the proof and say that our D should be the same as angle H, and then our E1 should be the same as K1. Now remember, we started with the alternate where we said E2 is the same as the angle C. So those are 3 fundamental facts, and then draw the conclusion. Therefore, DCE is similar to HEK because of angles. Ne? So that is how we would have claimed those 6 marks. So remember, all started here, the alternate angles, angles opposite equal sides, and trying to find those missing angles. So if that is true, and then we have 10.3 where they are telling us to prove that DG is the same as GE. DG is the same as GE. So if this is a radius, as we stated, even this is a radius because of sides opposite equal angles, which means that even GE is a radius because from the center to the circumference of the circle. Now, since this is a tangent FG, which means that this angle here is going to be a 90. So let's start with that and say that FGE. Okay, let me just put it this way. Saying FGE is 90. Okay, we said FGE is 90. Reason, the tangent perpendicular, the radius. Yeah? And if this is a 90, then we know that this F is the center of the semicircle. So a line from the center of the circle that is perpendicular to the chord must bisect the chord. So we're just going to write that reason. That the line, I'll say FG, line FG from the center of the circle and then perpendicular to the chord, which chord is DE, will bisect it, bisects the chord. All right, so that is what they needed. So therefore DG is the same as GE, which is also a radius. So that is R. This is also R. Okay, then next question. They want us to show that 2HB squared is equal to that. So let me try to draw my triangles based on the corresponding sides and angles. So if this is our DCE, okay, DCE, then this is going to be EH, and then K, because they said DEC is the same as HKE, HEK, okay, HEK. Okay, so let's have it that way, because we know that these angles are basically the same. So this is what is common to that. Let's replace the radius. So DE is going to be twice R, but we said HE is a radius. Okay, that's a radius. So let me compare the sides by saying that if I have my DE, let me erase that and say if I have my DE divided by my HK, this must give me the same as having a DC divided by HE. Okay, so I'm going to say sides in proportion, because DEC is similar to HEK, or you can just give us the last part. Those triangles are similar. Okay, if we do the cross multiplication, we have DE multiplied by HE is equal to DC multiplied by HK. Okay, so we have the DC and HK. But we know that DE is twice of R, and of which R is the HE. So we're going to have twice of HE times HE. Should give us DC multiplied by HK. Okay, remember we said but. Let's put it here. But DE is twice HE. Okay, so that is 2HE squared is equal to DC times HK. So that is question 10, and that's where the paper stops. So guys, just wish you all the best as you go over this proposed memorandum. Remember that the exact memorandum is not yet out, but this is the proposed episode where we shall be going over the prelim mathematics paper 2 2023 for Houghton. Okay, so the paper was out of 150 for 3 hours, and then we have 10 questions that we need to really work with. Okay, I'll try to push as much as I can. Okay, so question number 1, they're telling us that a survey was conducted among a group of learners that to compare the time that was spent on Instagram, and then that time that is spent on TikTok. So remember, these are social media platforms. We want to see if there's any bit of relationship between them, okay? So they're telling us the time spent on Instagram in minutes is given as that, and then that of TikTok is that. Those are the values. They drew for us a box on this as well. All right. Then they ask us to calculate the correlation coefficient of the data. Remember, for us to get to the point of even getting the correlation coefficient, we need to know how to operate our calculators. So step number one, we need to choose the mode. Okay. And then from the mode, we need to look for start, which I think number 2, usually number 2. Then by the start, we need to look for the A plus BX, or sometimes it's just a small A plus BX. Then you enter the value. So the first row will represent the X values, and then the second row will represent our Y values. You enter those ones in a column format. Then we shall press the AC or the on button. Everything must disappear. You wipe out everything on the screen. That is done. Then we're going to press Shift and 1, and then look for number 5. We select 5. So this 5 will have the value of A, the value of B. Number 1 is A, 2 is B, and then 3 is R. So the correlation coefficient is number 3, which is the R. So the correlation coefficient that I got 0.96, if I'm to round off to 2 decimal places. Okay, then comment on the strength. So with the strength, we need to see, is it positive or negative? But looking at the pattern, the way the direction that the dots are taking, this is an increasing pattern, so it's a positive relationship. Then when you look at the size of the coefficient, it's a very big one. So we're just going to say that we have a very strong, okay, so a very strong positive correlation. Okay, very strong positive correlation. Then they want the equation of the least square regression line, which must always be in the form of y is equal to mx plus b, okay? But this will be in the form of a plus bx, okay? So from our calculators again, Shift and 1, then you choose number 5 for regression. We shall get our values of a and b. So I'm getting my a as 8,12. And then I'm getting my B as a 1,015 if I round up to 3 decimals. If you have 2 decimals, you have 1,03, which is still fine. So the equation in this case is going to be Y is equal to 8,12 plus the 1,015 with X. Or if you're using the 1,02, then it would be the other way around, where you have Y is equal to 8,12 plus 1,02x. Then 1.4, they want us to predict. Okay, so we're gonna use the equation that we got or obtained. So for us to predict the time that is spent on TikTok, remember initially we agreed that TikTok is gonna be the Y variable, okay? So if our X is 115 minutes, we just need to substitute. So Y is going to be 8,12 plus 1,02 times 115. Okay, so when I punch that into the calculator, 8,12 plus 1,02 times 115, I'm getting 125. Okay, so that's 125 minutes. It's 25,42. 125,42. If you used, let's say, 1,015, it would give us, let's see, 15. It's an approximation of 124. Okay, 8 something. So if I'm to round it off, roughly 125 minutes that will be spent on TikTok if we have 115 on Instagram. Then 1.5, it was noticed that 4 learners' data was not recorded, okay? And then the mean of the TikTok and the Instagram was 73.4 minutes. The researcher commented that the total amount of time spent on the two platforms was more than a full day. Do we agree or disagree? Okay, so we know that initially we have 6 pieces of data, 2, 4, and 6. Now, if we include the 4 pieces, it's going to give us 10 pieces of data. So I'm going to get the total. Remember, our mean must be the sum over the number of items. Okay, so if the mean of 10 data pieces is 73.4, is equal to the total there over the 10. Then I'll multiply both sides by 10, so that the total, let's say for TikTok, is going to be 73.4 times 10, which gives me 734. This is just TikTok. Then if I look at Instagram, remember it's the same thing. So I'm just going to multiply this by 2. So 734 times 2 just gives me a total of 1468 minutes for both platforms. Now, how long is a full day in minutes? So we know that one day has 24 hours. Okay, and then the 24 hours times the 60 minutes, I'm getting 1,440 minutes. So we can see that the TikTok and Instagram time is greater than this. So the question was asking us whether we agree with the researcher. And the statement is going to be, yes, I agree. As plain as that. Then question number 2, still under statistics, we are being told that the amount of money in runs that a group of learners spent at the park on a specific day was recorded. And then we have a cumulative graph. Okay, we have the starting point as 10, and then the last point as 250. So they're asking us that the data from the cumulative is represented within a table that is incomplete again. All right, let me just do that. Then they want us to determine the number of people that visited the park. So when you look at this from a cumulative graph, the last data point should be enough to give us how many people. So we're going to follow this cumulative and then read off the value where we find the data point, which is at 25. Okay? So in other words, we have 25 people that took part in this kind of survey or visited. Then they want us to get the values of A and B. So A must be the starting point as you're plotting the ogive. Remember, with the ogive, you plot using the upper class limits. Okay, so what is the number by 50? That's a 3. So the first cumulative is the same as the first frequency. Remember that. Then after getting the 3, we can choose to add up everything and subtract from a 25. Okay, because now that's a 10. A 10 plus 9, that is a 19. So 25 minus 19 is going to give us a 6, which will be our B. Alternatively, if you look at the interval of B, it's 100 to 150. Okay, we can subtract this 15 and then the 9. We're still going to end up with a 6. Okay, then the next question they're asking us is the ogive returning the percentage of learners that spent more than 175. So we go to the ogive, where do we find 175? So when I look at the intervals, I'm seeing intervals of 25 everywhere. Okay, so this is 125, and then this will be our 175. Then I need to follow this 175 up until I reach the ogive. Okay, I'm getting the 175 at a line that is just below, the line below the 20 mark. Okay, so if I look at the intervals that were used, we just 16, 17, 18, 19. Okay, so which means 19 people or 19 learners spent 175 on this. Now the question is asking for more. So which means if I look at the area that is above, the 19. That will represent the number of learners that spent on it. So I'm just gonna get, what is that? I'll get the 25 minus 19, which gives me 6 learners. The question wants the percentage. So it will be 6 over 25 times 100. So that is 24%. Then 2.2, they're telling us it's further given that there are 2 rides at the theme park. We have what we call the Intimidator and then the Terror Thrills. The mean amount of money that was spent is given below. Okay. So for the Intimidator, it was 13.2 cents or 13 rand 20 cents. And then for the Terror Thrills, it's 12 rands and 70 cents. Then the true standard deviation interval about the mean of the Intimidator was calculated to be 4.8 and 9.2. So what they mean is that if we get the mean plus twice the standard deviation, and then we also get the mean minus twice the standard deviation, that will give us that interval of the 4.8 and then the 9.2. So in other words, the mean minus twice the standard deviation is equal to 4.8. And then the mean plus twice the standard deviation must give us 9.2. Okay, let's see. If I use this interval, the first one, our mean is 13 rands and 20 cents minus twice the standard deviation is equal to 4.8. Okay. If the standard deviation of the Terror Thrills is double the standard deviation of the Intimidator, calculate the interval for one standard deviation above the operator. Okay, so we need to find the standard deviation value first. Okay, so if I transpose the 13.2, I have twice the standard deviation, the negative 4.8 minus 13.2. That's gonna give me negative 8.4. Divide both sides by negative 2. Okay, I'm getting 4.2 as my standard deviation. If I try to use the first one, I think I'm gonna have issues. Okay, because I'm gonna end up with a negative answer, and yet standard deviation can never be negative. I don't know if this 9.2 value is misleading or what, but I'm not buying it. So I'm taking the standard deviation to be 4.2. That is for the Intimidator. Then the standard deviation of the Terror Thrills is going to be twice. So 4.2 times 2, which is going to be 8.4. Okay. When they talk of one standard deviation, so it's like the mean minus standard deviation, and then the mean plus one standard deviation. This is the interval they need. So our mean for the Terror was 12 rand 70. That's what I'm gonna use. So 1270 minus 8.4, and then 1270 plus 8.4. Okay, 1270 minus 8.4, I'm getting 4.3. And then 1270 plus, I'm getting 21.1. Okay, so that is the interval that I'm ending up with. And then I'll stop with that. So about the 9.2, I don't know. We shall need to see what happens. Then question number 3, analytical geometry. Okay, they're telling us that in the diagram below, okay, in the diagram below, A is -1,4, B is P negative 2, and C are vertices of triangle ABC. E is the y-intercept of the line AB. F is that, which is also the midpoint. The angles of inclination are that, and then alpha respectively. They want the gradient of AB. So it's a 2-mark question. When you look at AB, there's something that we have A as -1, 4, B, we only have P and -2. So we can't use the points, but we can use the inclination, where we know that M must be equal to the tan of the angle of inclination. So which means my M is just gonna be tan of 135. When I punch that into, I'm getting a -1. So the gradient here is a -1. Then they want us to show that P is 5. So I'm going to use now the gradient formula. Okay, so I know that gradient formula is changing Y over changing X, must give me a -1. So if I use 4 as my Y2, so I'm going to have 4 minus -2 over -1 minus P should give me -1. So that's gonna be a 6. If I cross multiply, 6 is equal to 1 plus P. And then I move the 1 to that side, which means P is a 5. Okay, so from the gradient formula, we can get that. Then they want the coordinates of C. What is C? C, after getting P as a 5, we have this F as our midpoint. Then we can use the midpoint method to find the coordinates of C. So what I'm going to do, I'm just gonna say if I have my X plus my 5 divided by 2, it must give me this midpoint value of X, which is a 0. Do cross multiply, which means X is a -5. Okay, I do the same thing with the Y. So Y plus a -2 over 2, it must give me a -4. I cross multiply, Y minus 2 is gonna be -8, which means Y is a 6, negative. Okay, so which means my C is -5 and then -6. So that is our C. Then they want us to get the equation of the line AC. AC. So we have the coordinates of A, we have the coordinates of C. What we need is the gradient and then the y-intercept. So what we're gonna start with is get the gradient. Let me just try to use a different color. Let's get the gradient. So we know that gradient, we said, is changing Y over changing X. Okay, let me use negative, it's a 4, positive 4 for this Y. So I'll have 4 minus this -6 over what is the X value then? The X value that we're having is a -1. Okay, so -1 minus -5. We can put this in brackets. Okay, so when you simplify that, we have a 10 over, when you simplify this, it's a 4. Okay, so that is like 10 over 4. And I find the gradient, or when I simplify that further, it's just gonna give me a 5 over 2. Now this is our gradient. The question wants the equation. Then I can use that point of -1 and 4, find the equation. So I'll say y minus 1. Does that make sense? No, it doesn't. Remember, there's an equation or formula that says y minus y1 is equal to m into x minus x1. So my y, I'm taking it as -1. So it's y minus -1 is equal to 5 over 2 into x minus, I'm messing up. My y1 is not, it's a 4. So y minus 4 is equal to x minus -1. So y minus 4 is equal to 5 over 2x plus 5 over 2. Then I need to move this for that side, which is going to be like a +4. Okay, so when I plus the 4 there, I'm going to end up with 8 plus 5, which is 13. So my equation is going to be 5 over 2x plus 13 over 2. That's what I'm getting. Then 3.5. 3.5. They want us to get the size of CAB. Okay, where is CAB? CAB. CAB, where are you? Okay, so they want us to get this angle. But for us to get that angle, we need to start by looking at this triangle and getting the value of alpha. Okay, so if we can get the alpha value, then we can go on and get that answer. So for us to get the alpha, we need to look at the gradient, which is 5 over 2. So m is equal to the tan of alpha. For us to get the alpha, it's going to be shift tan of the 5 over 2. Okay. So when I use shift tan 5 over 2, I'm getting a 68.20. Okay, 68.20. So if this is a 68.20, then I need to subtract the 68 from the 135 because those are exterior angles of a triangle. Okay, so I'm saying this is going to be 135 minus 68.20. And what does that give me? Gives me 66.80. So that is the size of CAB. Then they want the area of BEF. We need to get the area of BEF. The area of BEF. Where is BEF? Let's use a different color to get BEF. So this is the BEF. Okay, so we cannot use the area rule. It's going to be a bit tricky. Oh, we can, but we need the distances. Okay, let me do this. If I flip this triangle around and have a line that is parallel to the x-axis to be my perpendicular, so I'm going to take EF to be my base. Okay, so EF is my base, so which means I need to get the coordinates of E. I need to find the coordinates of E. If I can get that, then I'll be guaranteed this distance. I know that from here up to here is equivalent to the value of P, which is a 5. So which means my height is going to be a 5. What is shorting is just the base. All right, so did we find the gradient of this? Yes, we got it as -1. So if that is -1, let me use this point again and get the equation of that line AB. So it's saying y minus 4 is equal to -1 into x minus -1. Okay, y is equal to -x. That's going to be -1 plus a 4, which is a +3. So -x plus a 3. So this E is 0 and 3. 0 and 3. So if that is 3 units from E to the origin, and then from here up to here is 4 units, so which means the base is going to be 7 units. Okay. So I'm going to say my area is a half base height. So that's a half. My base are tangents to the circle and at A and C respectively with BC. -108. Then I can divide through by 2. So T minus 3T, T squared, sorry, minus 3T minus 54 is equal to 0. So when I use my quadratic of factors, I'll end up with T as a -6, or I'll end up with T as a positive 9. But since they told us that t must be on the negative, or it's less than 0, therefore t is a negative 6. So that's how the gradient of the perpendicular line is, okay? It's 5 marks. Okay, so let me do this. I need enough space. Let me just take it to, say, 4.3. 4.3, 4.3. Okay, so they're telling us to get the gradient of AB. Okay, but we know we need the gradient of MA first. Right. So minus 3 over 4. Let's see, I'm getting 7 over 4. So minus 7 over 4. So that becomes the equation. Let's try to go back. 3 over 4 minus 7 over 4. So it's saying y is 3 over 4x minus 7 over 4. Then they want the length of ends. So from here up to here. But we already know the x-coordinate of B, which is negative 7. What is shorting is the y value to x minus 1. Okay, the y is equal to negative x. That's going to be negative 1 plus a 4, which is a positive 3. So negative x plus a 3. So this E is 0 and 3. 0 and 3. So if that is 3 units from E to the origin, and then from here up to here is 4 units, so which means the base. Okay. So I'm going to say my area is a half minus 7 over 4. So it's saying y is 3 over 4x minus 7 over 4. Then they want the length of BC. So that and that, so it's negative 7 and 3. All right, then since it's a tangent, touches the circle at one point. Then determine the equation of, so for us to get the equation, what do we need? We need the gradient of theorem that talks about the gradient of the perpendicular lines, okay? It's 5 marks. Okay, so let me do this. I need enough space. Let me just take it to, say 4.3. Something different. So 1 minus 0 is 1. And negative 1 minus 7 over 4. How did we do that? Negative 1 plus 7 over 4 squared. Getting 9 over 16 plus 1, which is 25 over 16. All right, guys, I don't know. Either 25 over 9 or 25 over 16. Because something is not making sense. Okay, so if I'm taking 25 over 16 or 25 over 9, for me to get the equation, I'm just going to say x minus 1 squared, and then y plus 1 squared is equal to 25 over 16 or 25 over 9. Something like that. Then 4.6. 4.6. They're telling us that there's another circle, okay, with a center N, which is P and 3. And the radius of this circle is a 4, and it intersects the other circle at M at 2 points. So let's go back. So if there's another circle that is using the same horizontal line as its center, okay? So if there's a circle that is meeting at 2 different points, let's say that is its center, They want us to get the possible values of P. Because they told us this is going to be a P and then a 3. Subtract from 25. Okay, because now that's a 10. A 10 plus 9, that is a 19. So 25 minus 19 is going to give us a 6, which will be our B. Alternatively, if you look at the interval of B, it's 100, 150. Okay, we can subtract this 15 and then the 9. We're still going to end up with a 6. Okay, then the next question they're asking us is the OJF return the percentage of learners that spent more than 175. So we go to the OJI, where do we find 175? So when I look at the intervals, I'm seeing intervals of 25 everywhere, okay? So this is 125, and then this will be our 175. Then I need to follow this 175 up until I reach the ogive. Okay, I'm getting the 175 at a line that is just below, the line below the 20 mark. Okay, so if I look at the intervals that were used, we just 16, 17, 18, 19. Okay, so which means 19 people or 19 learners spent $175. Now the question is asking for more. So which means if I look at the area that is above the 19, that will represent the number of learners that spent more. So I'm just gonna get, what is that? I'll get the 25 minus 19, which gives me 6 learners. The question wants the percentage. So it will be 6 over 25 times 100. So that is 24%. Then 2.2, they're telling us it's further given that there are 2 rides at the theme park. We have what we call the Intimidator and then the Terror Thrills. The mean amount of money that was spent is given below. Okay. So for the Intimidator, it was 13.2 cents or 13 rand 20 cents. And then for the Terror Thrills, it's 12 rands and 70 cents. Then the true standard deviation interval about the mean of the Intimidator was calculated to be 4.8 and 9.2. So what they mean is that if we get the mean plus twice the standard deviation, and then we also get the mean minus twice the standard deviation, that will give us that interval of the 4.8 and then the 9.2. So in other words, the mean minus twice the standard deviation is equal to 4.8. And then the mean plus twice the standard deviation must give us 9.2. Okay, let's see. If I use this interval, the first one, our mean is 13 rands and 20 cents minus twice the standard deviation is equal to 4.8. Okay. If the standard deviation of the Terror Thrills is double the standard deviation of the Intimidator, calculate the interval for one standard deviation above the operator. Okay, so we need to find the standard deviation value first. Okay, so if I transpose the 13.2, I have twice the standard deviation, the negative 4.8 minus 13.2. That's gonna give me negative 8.4. Divide both sides by negative 2. Okay, I'm getting 4.2 as my standard deviation. If I try to use the first one, I think I'm gonna have issues. Okay, because I'm gonna end up with a negative answer, and yet standard deviation can never be negative. I don't know if this 9.2 value is misleading or what, but I'm not buying it. So I'm taking the standard deviation to be 4.2. That is for the Intimidator. Then the standard deviation of the Terror Thrills is going to be twice. So 4.2 times 2, which is going to be 8.4. Okay. When they talk of one standard deviation, so it's like the mean minus standard deviation, and then the mean plus one standard deviation. This is the interval they need. So our mean for the Terror was 12 rand 70. That's what I'm going to use. So 1270 minus 8.4, and then 1270 plus 8.4. Okay, 1270 minus 8.4, I'm getting 4.3. And then 1270 plus, I'm getting 21.1. Okay, so that is the interval that I'm ending up with. And then I'll stop with that. So about the 9,2, I don't know. We shall need to see what happens. Then question number 3, analytical geometry. Okay, they're telling us that in the diagram below, okay, in the diagram below, A is -1, 4, B is P -2, and C are vertices of triangle ABC. E is the y-intercept of the line AB. F is that, which is also the midpoint. The angles of inclination are that, and then alpha respectively. They want the gradient of AB. So it's a 2-mark question. When you look at AB, there's something that we have A as -1, 4, B we only have P and -2. So we can't use the points, but we can use the inclination, where we know that M must be equal to the tan of the angle of inclination. So which means my M is just gonna be tan of 135. When I punch that into, I'm getting a -1. So the gradient here is a -1. Then they want us to show that P is 5. So I'm going to use now the gradient formula. Okay, so I know that gradient formula is change in y over change in x must give me a -1. So if I use 4 as my y2, so I'm going to have 4 minus -2 over -1 minus P should give me -1. So that's gonna be a 6. If I cross multiply, 6 is equal to 1 plus P. And then I move the 1 to that side, which means P is a 5. Okay, so from the gradient formula, we can get that. Then they want the coordinates of C. What is C? C, after getting P as a 5, we have this F as our midpoint. Then we can use the midpoint method to find the coordinates of C. So what I'm going to do, I'm just gonna say if I have my X plus my 5 divided by 2, it must give me this midpoint value of X, which is a 0. Do cross multiply, which means X is a -5. The same thing with the Y, so Y plus a -2 over 2, it must give me a -4. I cross multiply, Y minus 2 is gonna be -8, which means Y is a 6, negative. Okay, so which means my C is -5 and then -6. So that is our C. Then they want us to get the equation of the line AC. AC. So we have the coordinates of A, we have the coordinates of C. What we need is the gradient and then the y-intercept. So what we're gonna start with is get the gradient. Let me just try to use a different color. Let's get the gradient. So we know that gradient, we said, is change in y over change in x. Okay, let me use negative, it's a 4, positive 4 for this y. So I'll have 4 minus this -6 over what is the x value then? The x value that we're having is a -1. Okay, so -1 minus -5. We can put this in brackets. Okay, so when you simplify that, we have a 10 over, when we simplify this, it's a 4. Okay, so that is like 10 over 4. And I find the gradient, or when I simplify that further, it's just gonna give me a 5 over 2. Now this is our gradient. The question wants the equation. Then I can use that point of -1 and 4, find the equation. So I'll say y minus 1. Does that make sense? No, it doesn't. Remember, there's an equation or formula says y minus y1 is equal to m into x minus x1. So my y, I'm taking it as -1. So it's y minus -1 is equal to 5/2 into x minus, I'm messing up. My y1 is not, it's a 4. So y minus 4 is equal to x minus -1. So y minus 4 is equal to 5/2x plus 5/2. Then I need to move this for that side, which is going to be like a +4. Okay, so when I plus the 4 there, I'm going to end up with 8 plus 5, which is 13. So my equation is going to be 5/2x plus 13/2. That's what I'm getting. Then 3.5. 3.5. They want us to get the size of CAB. Okay, where is CAB? CAB, where are you? Okay, so they want us to get this angle. But for us to get that angle, we need to start by looking at this triangle and getting the value of alpha. Okay, so if we can get the alpha value, then we can go on and get that answer. So for us to get the alpha, we need to look at the gradient, which is 5/2. So m is equal to the tan of alpha. For us to get the alpha, it's going to be shift tan of the 5/2. Okay. So when I use shift tan 5/2, I'm getting a 68,20. Okay, 68,20. So if this is a 68,20, then I need to subtract the 68 from the 135, because those are exterior angles of a triangle. Okay, so I'm saying this is going to be 135 minus 68,20. And what does that give me? Gives me 66,80. So that is the size of CAB. Then they want the area of BEF. We need to get the area of BEF. The area of BEF. Where is BEF? Let's use a different color to get BEF. So this is the BEF. Okay, so we cannot use the area rule. It's going to be a bit tricky. Oh, we can, but we need the distances. Okay, let me do this. If I flip this triangle around and have a line that is parallel to the x-axis to be my perpendicular, so I'm going to take EF to be my base. Okay, so EF is my base, so which means I need to get the coordinates of E. I need to find the coordinates of E. If I can get that, then I'll be guaranteed this distance. I know that from here up to here is equivalent to the value of P, which is a 5. So which means my height is going to be a 5. What is shorting is just the base. All right, so did we find the gradient of this? Yes, we got it as -1. So if that is -1, let me use this point again and get the equation of that line AB. So it's saying y minus 4 is equal to -1 into x minus -1. Okay, the y is equal to -x. That's going to be -1 plus a 4, which is a +3. So -x plus a 3. So this E is 0 and 3. 0 and 3. So if that is 3 units from E to the origin, and then from here up to here is 4 units. So which means the base is going to be 7 units. Okay. So I'm going to say my area is a half base height. So that's a half, and then my height we got 5. Okay, so a half of 35, I'm getting 17.5 units squared. Okay, and then 3.7, they're telling us there's another point K with coordinates T and T, whereby T is less than 0, and then AK is 5√5. So if T is less than 0, which means it has to be somewhere here in this quadrant, and we call that a K. So if that is a K, they're telling us the distance from A up to K is a 5√5. So need to use the distance formula with the coordinates of T and T. Okay, so I'll just go to the next page. So I have my T and T, and then I have my -1 and 4. This must give me 5√5. So from the distance formula, we know that AK squared must be equal to, we're just gonna say T minus minus, which is +1 squared plus, and that is T minus 4 squared. Then that is 5√5 squared. I'll open this up. I have T squared plus 2T plus a 1. Open this up, plus T squared minus 8T plus a 16. I'll try to regroup. So T and T, that's gonna give me 2T squared. This and that is a -6T. Then when I simplify this, the 5 squared is a 25, and I open that brackets times another 5, which is 125. When I move that 125 to the right-hand side, it's like 125 minus 16, or 16 minus 125, I'm getting 109. Does that make sense? So it's 109. Okay, we're still subtracting. There's this one also. So which means just gonna be 108 negative is equal to 0. Then I can divide through by 2. So T minus 3T, T squared, sorry, minus 3T minus a 54 is equal to 0. So when I use my quadratic of factors, I'll end up with T as a -6, or I'll end up with T as a +9. But since they told us that T must be on the negative, or it's less than 0, therefore T is a -6. So that's how 3.7 would have been worked out for you to claim the 5 nodes. Then question number 4, they're telling us the diagram below the circle centered at M, which is -23, passes through A, which is 1 and -1, and C. B and BC are tangents to the circle and at A and C respectively, with BC parallel to the y-axis. Okay, so we have all of that. Then they ask us to determine the equation of the circle in this format. So what we need to know is that the general equation of the circle is x squared plus y squared is equal to r squared. That is if the center is at the origin. If it's in this format, we know that A and B represent the center coordinates. So what we are shorting with is just the r, which is the radius. But I can use the points M and A and get the distance. Okay, so I'm gonna say MA squared. I'll get -2 minus 1 squared plus -1. And then I square that. So that's gonna give me 3 squared plus 4 squared. So that gives me a 25. In other words, our r squared is a 25. So to answer 4.1, I'll say x, we change the sign to +2. we square that. Plus with y, we change the sign also, minus 3 squared is equal to 25. So that is 4.1. Then 4.2, they want the coordinates of C. Where is C? C is here. Okay, so since we have our radius as 5, which means from M to C, those are 5 units. If those are 5 units, so we know that from -2, you move 5 units to the left, you're going to have -7. Okay, so which means our C is -7, and then the Y will stay the same as a 3, since they told us it's parallel to the Y-axis. Okay, it's parallel to the Y-axis. So that and that, so it's -7 and 3. All right, then since it's a tangent, touches the circle at one point. Then determine the equation of AB. Okay, AB. Remember, AB is this tangent here. So for us to get the equation, what do we need? We need the gradient of the radius. We know that the tangent and the radius will be perpendicular. And then we use that theorem that talks about the gradient of the perpendicular lines, okay? It's 5 marks. Okay, so let me do this. I need enough space. Let me just take it to, say, 4.3. 4.3, 4.3. Okay, so let me just put it in. So they're telling us to get the gradient of AB. Okay, but we know we need the gradient of MA first, where we look at changing Y over changing X. Okay, so my gradient is going to be -1 minus 3 over 1 minus -2. So that's a -4 over 3. But I know that the gradient of the tangent times the gradient of the radius must give us -1. So which means the gradient of the tangent is going to be a 3/4 positive. Okay. Then I'm going to use the point 1 and -1, which is point A. And say Y minus -1 is equal to 3/4 into X minus 1. When I open this up, when I simplify it, I'm going to have a Y plus 1 is equal to 3/4X minus 3/4. Then I need to subtract. So which means the equation is 3/4X minus 3/4. Let's see, I'm getting 7/4. So minus 7/4. So that becomes the equation. Let's try to go back. 3/4 minus 7/4. So it's saying Y is 3/4X minus 7/4. Then they want the length of BC. Length of BC. So since these are tangents, so from here up to here. But we already know the X coordinate of B, which is -7. What is shorting is the Y value. So we can use this equation of ours of 3/4X minus 7/4. If we replace X with a -7, okay? The -7, subtract 7/4, what do we end up with? We get a -7. So 3/4 times -7 minus 7/4, I'm getting a -7, which means that B is -7 and -7. So the most important coordinate here is this -7. Okay. So since we are moving from this point where our y is a 3, okay, up to 7. So we have 3 units above the x-axis, and then we have 7 units below the x-axis. So 7 and 3, that's going to give us 10 units. Okay. So we said first substitute the -7 to get a -7. Then we say 3 units plus 7, we get 10 units. So that's how we're going to get that. Then 4.5, determine the equation of a circle centered A that has both x and y as tangents. So if we have another circle, let me just green this circle, where x and y are tangents. So which means the line AB will be forming part of the diameter of this circle. So the only thing that I need here is the radius. But for me to get the radius, I can get the y-intercept here. Do we know the equation of AB? Yes, we got it. Not so. Yes, we have it. So which means the values at that point are 0 and -7/4. Then I'm going to use these values and then the 1 and -1 and try to get the radius. Okay, so my radius, why don't I say radius squared? So it's going to be -1 minus -7/4 squared plus 1 minus 0 squared. So what do we get? What do we get? What do we get? What do we get? So we're saying -1 plus now 7/4 squared. Okay, then plus a 1. That gives me 25/16. I don't know if that makes sense. 25/16. If I try to look at this, what will be the coordinates of the x-intercept? If y is a 0, 7/4, so that's going to be 7/3. I don't know, why am I getting different things? Because now this is going to give us a different, okay, let's see. So if we have, we're doing the right thing. We said -1 minus 7/4. Paper 2, it's usually statistics. And they're telling us that Miss Murphy decided to research the effectiveness of her online classes. And then she divided the 12 pupils fairly into 12A and 12B. So 12A attended face-to-face classes, and then 12B attended the online classes. Then both classes were taught by the same person over the same period of time. And then they are telling us that the table below shows the time spent teaching in hours and then the average results of the learners' weekly tests as percentages. Okay, so this is a bivariant type of data. So we look at the time together with the results, and then the time together with the results. Okay, so time is the independent variable, whereas the results will be the dependent. Then they ask us to determine the equation of the least square regression line of 12A. So we just need to capture this within our calculators. Remember, the steps are quite clear and simple. So we said we always have to start with the mode. And then from the mode, you choose the start. Then after getting the start, we need to look for the A plus BX times it's a small a and a small b x. And then we shall get a table, which table will have the x on one side and then the y on the other side. So what we said was that the first row will always indicate the x values or the independent variables. So we enter this, we capture that. So 2 equals signs, 8 equals signs, 4 equals signs, 6 equals signs, 12 equals sign, 10, and 11. Then we also enter the y values, 42, okay, then we have a 62, and then a 48, then a 52, a 64, 63, and then a 67. So capture that. When all those values are captured, then we can use the on button or the clear all button so that everything disappears. Then we need to press shift and then 1. So shift and 1. Then we're gonna go to 5 that talks about the regression. And then that 5, we can look for the values of A and then the values of B. I think it's option number 1 and then option number 2. So if that is done, our A that we're gonna end up with is 38,26. That's what I'm getting, 38,26 from my calculator. And then the B that I'm having is a 2,456. Let me just round it off to decimals. So it's a 2,46. So remember, our regression must always be in the form of A plus BX. Okay, so when I write that out, it's going to be 38,26 plus 2,46 times X. So that's all they want there. Then 1.2, they want us to write down the correlation coefficient of 12A results with respect to the time. So what we need to know is that these values, since we entered the values of 12A, we can just go back, you press your shift and the 1, then we go for the 5, which is regression, and then we go for option number 3 on my calculator that is representing the regression symbol. On your calculators, look for that option, the small r. So my regression is 0,966, which is like 97. Okay, so that is what I'm having. Then 1.3, they want us to comment on the correlation between the time spent. So whenever we are commenting, we look at the value. Okay, the value itself is going to tell us the strength, and then the sign of the value must give us the direction. Okay, so in this case, since it's 0,97, that is a very strong, okay, but it is positive. So a very strong positive relationship. Okay, so that is what we have to do. Okay, so that is 1.3. Then when we look at 1.4, they're telling us that the equation of the least squares of regression of B is given as this. Okay, we need to calculate the difference in the result that is achieved by each class. had this lady spent an average time to complete a particular lesson. So the key statement here, because we need a value for the time, but they are telling us the average time. So we know that average is the same as the mean, and sometimes we denote it as X bar. So if we go back to our table, we go back to the table that we were given. We have 2, 8, 4, 6, 12, and so on. Let's quickly get the mean for those values. So it's a 2 plus 8 plus 4 plus 6 plus 12 plus 10, and then plus 11. Okay, and then I'm going to divide this by 7. So I got a 53 over 7. So our mean time that we're talking about is basically 7,57. Now they want us to use the 7,57, substitute it into this regression equation as well as this one, and let's get the difference between the two. So for the first case, for 12A, if I use that line, I'll have my y as 38,26 plus 2,46 times the 7,57. Okay, let me just get my answer. That is plus 2,46 times. That's giving me 56,88. Okay, then let me do the same for 12B. I'm having 15,74 plus 4,54 times the 7,57. Okay, so 15,74, 4,54 times 7,57. I'm getting 50,12 from the round off. Then we need to just subtract these two values since they asked for the difference. So guys, in maths, when they ask for difference, don't write explanations and tell us this is bigger than that, or it's just the subtraction. So 56, we're gonna have 6, having 76. Yeah, something of the sort. Then 1.5, they want us to identify any outlier or an outlier in 12B. So an outlier, we say it is an extreme value. It's either too small or too big compared to the rest of the data. So in this case, the outlier will be a 9 for 12B because it is basically the lowest mark. So how do we indicate that? You have to write us the time that it took place and then the 9. In other words, the time that was taken to teach this person and then the results that they got. Then indicate a valid reason for this outlier. Remember, the outlier is falling under the online classes, if I'm not mistaken, because 12B attended the online classes. So we can talk of any valid reason that could come up as a result of online classes. Okay, what problems do people face? Maybe this person couldn't even attend because of load shedding, because of poor connectivity, or this person had their own reasons. But what are those reasons? Okay, so we can just attach it to maybe lack of attendance. Just that. It's lack of attendance because of ABCD reasons. All right, so that is 1.6. That is the whole of question 1. Let's look at question 2. Formula 1, the race car drivers have to endure high G forces at extremely high temperatures, and then they tend to lose almost 4 kilograms of weight after every race. Oh, that's too much. 2.1. The table below shows the total weight that is lost by 40 different race car drivers after the duration. So we have this grouped data of ours. Okay, we have the classes of the weight loss and then the number of drivers that lost weight. Then they want us to determine the modal class. So a modal class is basically that class with highest frequency. Now remember, the number of drivers will represent the frequencies. So these intervals are representing our classes. So the highest frequency that we are seeing is the 15. So this interval becomes the modal class. So we're going to say 2.5 is less or equal to the weight and less than 3,000. Then they want us to calculate the estimated mean weight loss of the drivers. Okay. So remember, it's a process that was done way back in grade 10, but I'll just try to push it there first. Okay, so we had the x, which x was the midpoint of the class intervals. And then this was the f of x, the product of the frequency, and then that. So we already have the total number. So this is summation of f, the frequency. We know that the estimated mean, which is the mean of this grouped data, will always be given as the summation of fx over the summation of f. So in other words, we need to get the product of the frequency and the midpoint first, which is a bit different from the one variant kind of data. So how do we get the midpoints? Midpoints are obtained by just adding the upper class as low as and the lower class. So it's 0 plus 500, and then we divide by 2. So this is going to give us a 250. Same story, 500 plus 1,000, then you divide by 2. You're going to get something like a 750. So when you look at the trend that is happening, it's like we are just adding a 250, 250, a 250, a 250 everywhere. So this is going to be 1,250. And then this is going to be 1,750. And then it's going to be 2,250. And then 2,750. And then 3,250, something like that. And then if we multiply the 250 by the 1, we shall get a 250. 750 by 2, we shall get a 1.5. And then 1,250 times 3, we shall get that 750. And then 1,750 times 8, we're getting 14,000. And then 2,250. 2,250 times 6, that is 13,500. And then 15 multiplied by 2750, that is 4,1,250. Okay, and then 5 times 3,250, that's giving me 1,6,250. And then what I need to do is just add up. I need to get the total of all these items. Okay, so let me do that. 1.5, I have 3,750 plus 14K, 14,500 plus 4,1,250 plus 1,6,250. So my total here is 9,500. Okay, so my estimated mean, let me just write this side. This is question number. Okay, so estimated mean, it's saying summation of f for x over summation of f. So you have 9,500 divided by 14. Okay. So when I divide this by 40, I'm getting 2262,5. So this is basically the grams that were lost on average. All right. Then 2.2. They're telling us that the recording of the weight lost within the in a second race was made 1 month later. And the amount of weight lost in race 2 was kgrams more than in race 1. Okay. It is given that the maximum value of the ogive representing race 2 was 40 and 3504. And then the graph was grounded at 40. Okay. Then they want us to sketch the ogive or the cumulative frequency curve representing race 2 within the answer book. So this table is for which race? They don't tell us. Just looking at the second table. Okay, so what we're going to do with the cumulative frequency, we know that we normally use the cumulative values. Okay, I've used almost my table. Okay, I'll use this other one here. Try to decrease it and decrease it a little bit. Okay, so if this is my table, let me try to indicate the value of the cumulative. If that is gonna make sense. Let's see. Okay, so with the cumulative, we know that the first cumulative will always be the first frequency. Remember, we say this is frequency. So this is for cumulative frequency. And then 1 plus 2, we must get a 3. And then 3 plus 3, we must get a 6. And then 6 plus 8 is a 14. 14 plus 6 is 20. 20 and that, we get a 35. 35 and 5, we get a 40. So our last cumulative must be equal to the total frequency. Then, if we go back to what they told us, this condition of theirs, they told us, remember, these values are for race 1, but we want to play around with this to create the race 2 values. Telling us that the recording of the race was made 1 month later, and then the amount of weight lost in race 2 was kgrams more than in race 1. Okay, it's given that the maximum value of race 2 was 3504 as well as a 40. And then the graph was grounded at 4 and 0. What does this mean? It simply means that the lowest interval is going to be a 4. And then this one will be a 504. So that when you subtract, you still have the same thing. Then the process continues. Okay, so this will be a 504, and then this will be 1004. 1004, and then 1504, 2004, 2504, 3004, 3504. You can see how it's coming up. And then these numbers will be the side. So 1504, 2004, 3004. This is a 2, sorry. It's a 2504 and a 3004. Okay, so we have that. We have the cumulatives. We just need to plot our graph. Okay. So which means that's going to be, they say they are grounding it at that. Remember, when we are plotting our graph, we normally use the upper classes. Okay, so these classes are what we use against the cumulative values. Okay, so the first one, which is going to be 5004, goes with 1. 5004 goes with 1. 4, 6, 10. So 1 is somewhere there. And then 1004 is going to go with, we said it's a 3. Let me just reduce this that I can see nicely. It's a 3, 6, 14. Okay. So that is a 1. We need a 3. 3 is somewhere there. 6 is somewhere there. And then 14 is somewhere there. Okay, then from the 14, we have 20, 35, 40. So this is a 20. This is a 35. And then we have a 40. Somewhere there. All right. And then all you do is just connect this using your freehand. Using your freehand. And then you'll have the ogive as they want it, or the cumulative frequency. Something like that. Okay. Then they're asking us that how will the race of race 2, or how will the range of race 2 compare with the range of race 1? Now, the fact that we see that the intervals are just varying in the same format, just a -4 and then a +4, something like that, or +4 on either sides, there's not going to be any difference, because remember, with the 0, we added a 4 to give us this. And then even with 500, we added a 4. So if you ask for the range, which is the maximum minus the minimum, there's no difference. Okay? You can say it just remains the same. It remains the same. And then determine the average weight that is lost in race 2. Average weight that is lost in race 2. So since we got our average, remember mean is the same as the average. We got it as what? Someone remind us. We got it as 2262,5. 2262,5. But then remember, we are adding a 4 for the lower class, and then we are also adding a 4 to the upper class, which means overall 4 plus 4 is 8, divided by 2, it's 4. So overall, we are adding 4 grams. So you're going to say +4. And then that's going to give us 2266,5 grams. That will be the mean or the average. All right, question number 3, which is the analytical geometry. So in the diagram below, we have A, which is -3K. And then B, which is 48, C is 50, D is -4, are vertices of parallelogram. So when they talk of a parallelogram, please let's remember the properties of parallelogram. Okay, we know the opposite sides are parallel, opposite sides are equal, but what is very important is that the diagonals bisect each other. In other words, the midpoint of this diagonal is the same midpoint of that other diagonal. Okay, so diagonals do bisect at P, and then the angles of inclination AB are alpha and beta, respectively. AB cuts the x-axis at P, and then F is a point within the 4th quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. There is F. Okay. Then they want us to get the gradient of BC. So we know that gradient is normally obtained by the change in y over the change in x. y2 minus y1 over x2 minus x1. So when you look at the BC, we have 48 and then we have 50. So that's going to be, let's say, 8 minus 0 over 4 minus 5. So that is 8 over negative 1, and then our gradient becomes negative 8. So that is the gradient that they need here for BC. Then if the distance between A and B is root 65, can we determine the value of K between A and B? This is root 65. So when they talk about the distance between points, then we're going to use the distance formula. Okay. And we know that the distance formula is, I'll say AB is the square root, or AB squared is all of that. X1 minus X2 squared, and then Y1 minus Y2 squared, or X minus X1, whichever format you use it, guys. So where there is AB, I'm going to use root 65 is equal to the square root of, I'm going to say, negative 3 minus 4 squared plus a K minus 8 but squared. And then I'm going to get rid of the square roots. You square both sides, and then the roots fall away. Okay, so I have a 65 is equal to minus 3 minus 4. It's going to give me negative 7. I square that. I have a 49. When I open this up, I can use my FOIL, K minus 8, and then K minus 8. So that's a K squared minus 16K plus 64. I'm going to regroup this and create what we call a standard quadratic. So I have K squared minus 16K. 49 and 64 is 113. When I subtract 65, I'm getting a 48. I can factorize that out, or I can use my quadratic formula. So which numbers? 48. Can use 12 and 4. Can say K minus 12, then K minus 4 is equal to 0. So either K is a 12 or K is a 4. So we already have the K. Whoa. What's happening? What is happening? Did we mess up with the signs? Did we? Something is not right. No, it's fine. It's okay. We didn't mess up. Remember, K represents the Y values, and both numbers yeah, that's what it's giving us. Either K is a 12 or K is a 4. Oh, that's correct, guys. No need to stress. But when we look at where K is, this K is below the 8. So K cannot be a 12. This simply means at Y12, the distance between A and that point is still going to give us root 65. So in this case, since we are saying that K is below this 8, then we're going to take K to be a 4. Okay, so I'm saying K is a 4. That is according to the interpretation of the drawing. Then 3.3. Can we prove using analytical geometry methods that BP, where is BP now? BP, where are you? Okay, that BP is perpendicular to AC. We prove that BP is perpendicular to AC. So for us to prove that, do we need the coordinates of P? We don't need that. I don't know. We can even use the coordinates of D since it's still the same straight line. I suppose we can use that. But what we know about perpendicular lines is that the gradients, which means the gradient of BP times the gradient of AC, it must give us a -1. So this is the condition that we should aim at. Okay. So what I'm going to do, just gonna move this side and say that the gradient of AB, is it AB or BP? Say the gradient of BD, we use BD. Say Y2 changing Y over changing X. And then our BD is 8 and -4, 4 and -2. So I'm going to say 8 minus -4 over 4 minus -2. When I simplify that, I have a 12 over 6, which gives me a 2. And then the gradient of my AC, so changing Y over changing X, same story. So with my AC, I have a -3 and a 4. And then I have 5 and a 0. So that is going to be, so we're gonna say -4 minus 0 over -3 minus 5. So this is -4 over -8. Did I do something wrong? Say -4 minus 0, -3 minus 5. That is fine. Okay. This is giving me a half. With the previous one, did we do anything wrong? It was 8 minus -4, which is that. Something's not right. Something I did wrong here. Why am I using a -4 for the Y? It's a positive. And see that. So that's a positive, and then we end up with a negative. Yeah. Then if we get 2 times -1/2, that gives us -1. Then we can draw the conclusion that therefore AP, because that was they say, no, it's BP. Say BP is perpendicular to AC. All right, then calculate the coordinates of F. If it's given that ACFD, AC, just use a different color. Okay, ACFD, okay, is a pyrogram. Okay, so if this is a pyrogram and we need to find any missing coordinates, we have to use the midpoint. Okay, so we're seeing that this DC is a diagonal. So we need to find the coordinates of the midpoint here. So for us to get those coordinates, we shall say -2. Okay, let me just put it aside. So we're saying the midpoint of DC, will be x plus x1 over 2, and then y plus y1 over 2, or y1 and y2 over 2. Okay, so we see -2 and 5, -4 and 0. -2 and 5 over 2, and then -4 and 0, plus 0 over 2. Okay, so when we simplify this, we have a 3 over 2, and then we have a -1. That is our midpoint. Then, what we said was that if we draw this diagonal also, the diagonal AF, this is also going to be the midpoint, which means if I call the coordinates of F to be X and Y, if I get the -3 plus the x divided by 2, I must get the 3/2. And then if I get the 4 plus this y divided by 2, I must get -1. So let's do that. We're saying -3 plus the x of f over 2 must give us this x coordinate of the turning point. Multiply through by 2. So by 2 by 2. This cancels that. This cancels that. Move the x move the 3 that side. So x is a 6. And then we're saying y plus a 4 divided by 2 must give us -1. Multiply through by 2 also. This cancels. So y is -2 minus 4, which gives us -6. So which means f is going to be 6 and -6. So those would be the coordinates of f according to the question. So remember, you're looking for missing coordinates. In most cases, we use the midpoint, depending on the values that we have. Did we do this correctly? This was a 4. Whoa, 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 whoa. Is that true? Is that true? Is that true? Is that true? Someone is complaining, saying there's something we did wrong. So y plus 4 over 2 must give us, so, oh, the midpoint. Guys, let's go check our midpoint values. Someone is not happy. Happy. Okay, so with the midpoint, remember we said midpoint. What was our midpoint? We said -4 plus 0 divided by 2. That's all. This was our midpoint, which gave us a -2, not a 1. Yeah, it's making sense. So it's a -2, guys. Sorry. And then if this is a -2, then that's going to be -4. -4 minus that is going to give us -8. So that is -8. Thank you very much. Then 3.4 is done. Then they want us to get the size of EDO, correct to 1 decimal place. EDO. Where is EDO? Let's change this. Something like EDO. This is E. This is D. And this is O. EDO. So they want us to get this angle here. So for us to get this angle, we need to first of all get the angle alpha. Okay. And then we also need to get the angle beta. So we know that this angle beta is going to be the same as this angle. It's the same thing. Which means for us to get this angle of ours, we shall have to combine this angle and the beta to give us the alpha. So we got the gradient of BC, which was -8. But this gradient is the same as the gradient of AD. So let's use the inclination formula. So we know that M is equal to the tan of alpha. Our M is -8. So alpha is going to be the arctan of -8. Okay, if I substitute that, I'm getting -82,875. I will just add 180 to get the positive angle, which is a 97,13 degrees. Let's look at the beta. If this is 8 and it's passing through the origin, So the gradient is going to be 8/4, which is a 2. Someone can use 8 and -4, which will give you a 12. 4 and -2, which will give you a 6. It will still give us a 2. So I'm going to say that my beta is going to be the shift tan of a 2. So shift tan of a 2 is giving me 63,43. So this angle is a 63,43, and we say it's the same as this because they are vertically opposite. This we got as a 97, 13. So when we get this 63,43 plus this angle must give us that because of exterior angles of a triangle. So we can just quickly say that for us to get the ADO, okay, so ADO will be just the difference between the two, 97,13 minus 63,43. When we subtract that, 97,13 minus 63,43, I'm getting 33,7 degrees. Just that. Or is that 3.4? I'm just misaligning the questions. Yo, guys, I'm sorry. That is 3.5. That is meant to be 3.5. Okay, this is meant to be. Okay. Then 3.6, they want the area of ADC. A, D, and C. For marks. So what do we know? What do we know? What do we know? Remember from the area rule, we must have two sides known as well as an angle. And let me just clean up this drawing. Just clean the drawing up so that we have a clear view. Okay. So then they want us to get area of ADC. AD and C. So this triangle here. So since we got this as a 33,7, and they told us that this is a pyrogram according to the information that was given. So if it's a pyrogram, which means even this bottom part must be a 33,7 because this the diagonal bisects these angles. If that is true, we can find this distance AD, and we can also get the distance DC. What did they tell us? They told us that the distance was root 65. Okay, that is a root 65, so which means we have this as a root 65. We only need the distance of AD. Okay, so we shall say AD will be the square root of -3 minus -2 squared. K was a 4 minus -4 squared. Now I punch that into the calculator of -3 squared. What is happening? Plus, I'm getting also root 65. Does that make sense though? 3 minus minus, which is a 1, that is 8. Getting root 65. I don't know if that's going to make sense. If that is going to make sense. Oh, it's what I don't want to use is that other angle. Yeah, let's see, guys. It's a negative 3 minus minus 2, 4, minus minus 4. Let me just confirm it, guys, just to be sure. Minus 2 squared plus 4 minus minus 1. Questions of whole. We square that, which is root 65. No, it's okay. Let's go with it and say the area now is going to be a half times this root 65 times that root 65, and then the sine of these angles combined. So 33.7 times 2 is giving me 67.4. So when I punch that into the calculator, 67.4. I'm getting 30,000. So which means it's just 30 units squared. It's okay, guys. That will be the area that is needed. Then that is question 3. Then question 4, dealing with the circles. Telling us the diagram below, the equation of the circle N is given as that. And then QT is a tangent to the circle T. T and P is the diameter of the circle. Have point P, which is 5, and 4 lies on the circle. All right. Then the question is that, can we write the equation of the circle in this other format? And so in that format, all they want us to do is complete the squares. Okay, so how do we complete the squares? That we need to know. So we're going to say x squared plus y squared minus 4x minus 2y minus 13 is equal to 0. So step number 1, some people prefer to move the 13 that side. But it's no big deal. You can even work with it when it's this side. So if I take it that side, say minus 4x, why don't I just try to rearrange as well? So it's x squared minus 4x plus y squared minus 2y must give me a 13. Then when we are completing the squares, we just look at the b value for x and y. Okay, so the b value there is a 4. So we're going to half it. And then we square it. So that's going to be x squared minus 4x, a half of this. That's going to be 2, but squared. I'll do the same thing. This is y squared minus 2y, a half of that is just 1 when I square that. Is equal to 13. Now, since I'm introducing these squares, I must also do the same on the right-hand side. So that's going to be a 2 squared plus a 1 squared. Then that represents our quadratics, and then we can factorize that. So that's going to be x minus 2. So x with this sign, and then that number that you squared. And then plus, we're saying y with this sign, and then the number that we squared must give us, this is 13 plus 4, that's 17 plus 1 is giving us 18. So that is how we would have completed the squares. Alternatively, what we are always told, just as a quick approach, just x and then y, just get a half of this with a sign. So it's a negative with a 2. Then a half of this with a sign, -1, you square that. And then you just add those squares that side. You just get that fast without going through this long process of breaking that down. Okay, then write down the coordinates of n, which is the center. So n is going to be 2 and then 1. We switch the signs, +2 and +1. Then they want the length nt. Nt is the radius, but remember this 18 of ours is the r squared. So for us to get r alone, you must get the square root of it. Okay, so nt is square root of 18, which is 3√2. If I was to simplify that. Then 4.3, determine the equation of the tangent QT. Tangent QT. So we know that since we have the coordinates here as 2, 1, we want the equation of the tangent. We need the coordinates of t first. And then after getting the coordinates of this, we also need the gradient of P.2. Then we shall be in position to get the equation of the tangent. Okay, so I'm going to start with determining the gradient. So I'll say m of P.2 is going to be 4 minus 1 over 5 minus 2. So that is a 3/3, which is a 1. Okay. Then the equation, from try the equation, remember it's y is equal, okay, y minus 1 is equal to 1 into x minus 2. Or you can use the mx plus c1. When I open that up, I'm having y is equal to x and that is x. I'm going to have a -2 and then a +1. So it's x minus 1. This is the equation of the diameter. But then this equation or this line is meeting the circle at 2 points. So I'm going to work with this and then the equation of this circle and solve them simultaneously. Let's go that side, it's 4.3. Okay, so we said x minus 2 squared, y minus 1 squared is equal to 18. And then we have y is equal to x minus 1. So where there is y, I'm representing that or substituting. So I'll open that, not yet as, let me just substitute. So I'm going to have x minus 1, but squared is equal to 18. Open this up, I'll have x. Why should I waste a lot of time? Because I know that this is going to be also x minus 2 squared. So I have 2x minus 2 squared is equal to 18. Divide both sides by 2, x minus 2 squared is equal to 9. And then I find the square roots. So x minus 2 would be plus minus 3. When I move the 2 that side, x is a 5, which 5 is this one, the p. Oh, if I move the 2 with a negative, x is going to be a -1. Because this is going to be a 3 plus 2. It's going to be a -3 plus 2, which is -1. So we have the x coordinates. Okay. I have the x coordinate of this t, calling it a -1. Then let's get this -1 and substitute it into this equation of the line, which means y is -1 minus 1, which means the y is -2. So t is -1 and -2. Okay. Since we got the gradient to be 1, and we know that a tangent and the diameter, or tangent and radius, must be perpendicular from our Euclidean geometry. If that is true, which means the equation, the gradient of the tangent, okay, I'll just say gradient of the tangent must be -1. Since we say that the two gradients, the products of the two gradients must give us -1. So it's like a -1 times another gradient of the tangent must give us -1. This was a positive, sorry. And then when you divide both sides, you get a -1. Okay. So -1 as a gradient and the coordinates as that. So I'll say y minus -2 is equal to my gradient, which is -1 into x minus -1. I'm using this kind of format to determine the equation of the line. Like we said, mx plus c can also work perfectly well. So y plus 2 is equal to -x minus 1. When I move the 2 that side, y is going to be -x minus 3. That is what I'm getting for the equation of the tangent. If you have a quicker way, you can always share it with us. Thank you. Then 4.4, they are telling us that a circle with S, that is AB, touches the circle with N externally at point T. Just to refresh this, that I clear. Okay, so we have another circle that is touching at T. I don't know whether it's big or small, but it's fine. Let me use that. Okay, so if this is extended, that's going to be S with A and B. What they are telling us is that this tangent is tangent to both. If NS, the distance from here up to there, is 3nt, can we determine the coordinates of S? So guys, we got the coordinates of T, which were -1 and -2. Okay, we got the equation to be y is equal to -x minus 1. And we also got the radius to be a 3√2. Okay. Let's go back and fix this, because I see that 3nt is in a wrong place, telling us that NS. Okay, guys, so with 4.4, what we're going to do, we said NS is 3nt. Okay, so if we square the NS, we're going to end up with 9nt squared. We're squaring it so that we simplify that whole thing. Okay. But since we already have, what is that thing? Remember, if this circle were to be drawn, that is N. It told us that this distance is 3 nt. Okay, when you simplify the 3 times the 3 root 2, you get the 9 root 2. When you square that, that's how you're getting the 162. Okay. So this 9 nt squared, okay. If we apply the distance formula, it's going to be a minus 2 squared plus b minus 1 squared must give us the 162. So we're looking at the distance from here up here. Remember our n was 21. So a minus 2 squared, b minus 1 squared. Okay, let's call that equation number 1. But we know that nt and qt, those are perpendicular lines. Okay. If they're perpendicular, the product or the gradients will be -1. So if this is perpendicular, even this line will be perpendicular. Remember, our t was a negative. Was it -1 and 2? No, it was a -2 and -1. So let's try to get the gradient of this and equate it to the gradient of that line that we got as a +1. So we're going to say b minus -2 over a minus -1 must give us 1. So b plus 2 over a plus 1 must give us a 1. Let's try to make b the subject, which is a minus 1. Or alternatively, even from that equation of the x minus 1, if you replace b and a, you just straight away get to that. Then we need to substitute this b with that. So it's a minus 2 squared plus b, which is a minus 1 squared, is equal to 162. Okay. Let's open this up. We have 2 into a minus 2 squared is equal to 162. Divide both sides. That's going to give us 81. Square root of 81 is plus minus 9. That's going to give us a minus 2. And then we can move the 2 that side. So either a is 11 or a is going to be a -7. Okay. Then we substitute these values into that. So which means b is going to be the -7 minus 1, which is -8. So which means s is -7 and -8. All right. Question 5. They're telling us that in the diagram below, point P is this and it's having a reflex angle, which is 2 theta, as shown in the diagram. And we can see that it is in quadrant number 3. So one thing that we need to do, one thing that you need to remember is completing this triangle. So this -3 is for the x, and this -3√3 is for the y. Now we need to find the hypotenuse. That has to be our first priority. So from Pythagoras, we know it's x squared plus y squared. So I'm going to say square root of -3 squared plus -3√3 squared. Now punch that. We have -3 squared plus -3√3 That's squared. So that's giving me a 6. So remember, this answer of yours should never be negative in any way. You must always have positive values. Then from there, we can now answer the question of cos, because we know that cos is adjacent over the hypotenuse. So our adjacent is -3, and then the hypotenuse is a 6. So the answer becomes -1/2. All right, then they want the sine of theta. Sine of theta. So it will be your choice on how you come about with the sine theta. But remember, the question gave us a double angle. So we can use the double angle, of course, where we know that the cos of 2 theta from our formula page, let's just rush there. From the formula page, we can use this one. 1 minus 2 sine squared. So that's going to be 1 minus 2 sine squared theta. And let's try to make sine theta the subject. So it's going to be 2 sine squared theta is equal to 1 minus cos 2 theta. Then we can divide both sides and take square roots. And so sine theta is going to be the square root of 1 minus cos 2 theta over 2. When we substitute our cos 2 theta, which is -1/2, so it's going to be 1 minus -1/2 over 2 under the square root. You can go bit by bit or just at once, no problem. Okay, we're dividing by 2. I'm getting a √3 over 2. So we need to see all these workings out. Then 5.2. They want us to simplify this. Okay. Let me just do it this side. 5.2. So we have cos squared 180 plus x. Cos squared 180 plus x. And then we also have a cos of -x. Okay. And then we multiplying by the tan x. Multiplied by the tan x. Multiplied by the cos of 90 plus x. So we need to apply our reduction rules. So 180 plus, that is quadrant number 3, where the cos is negative. So it's going to be negative cos x, but we're squaring it. And we say the cos of a negative angle is the same as the cos of a positive. So we ignore that and use it as a positive. We could change this, the tan, into something like sine x over cos. Okay, and then the cos of 90 plus, this must always give us a negative sine x, since those are complementary angles. So what we see is that this is going to give us a cos squared x. This is going to cancel that. That time that we have negative sine squared x. So cos squared x minus sine squared x, this is a double angle of cos. So that's the same as cos 2x. That's what I would get. Then consider the equation 5 tan theta minus 6 cos theta. Can we show that this equation can be written in this format? Now with this format, we are only seeing the signs there. We don't have a tan, we don't have a cos. So what I'm going to do, let's see. We have 5 tan theta. We are subtracting 6 cos theta is equal to 0. So this question would have also come in the form of, can you prove that this can also is the same as that? So step number 1, since we don't have a sign by, we don't have a cos or a tan by our answer, we need to change. That's going to be 5 sine theta cos theta minus 6 cos theta is equal to 0. Then we're going to multiply through by the cos. So cos theta times cos theta times cos theta. So this cancels. You have 5 sine theta minus 6. This is sine. Why am I saying sine so fast? That's cos squared. Theta is equal to 0. Then let's change the cos squared into sine. That's going to be 1 minus sine squared theta. Then just open this up. You'll have your 5 sine theta minus 6. And then this and this will give you plus 6 sine squared theta. Rearrange this. So it's a 6 sine squared theta plus a 5 sine theta minus 6 is equal to 0. I think that's what they had. It's a plus 5 sine minus 6. Correct. Then they want us to determine the general solution. So with general solution, since we've already changed these to just one trig ratio, then we can use the quadratic formula to determine our reference angles. Or we could just vectorize it out. Whichever one would be quicker and easier. Okay. So if we use the quadratic formula, that's going to be our A, that's our B, and then that's our C. So if I try to use that quadratic formula, I substitute that. I have 6. Come on, I have 6. Okay. All right. Okay. So I'm having the first X. Now remember, our X's are representing the sine theta, because that is the X. So you can have sine theta as a negative 3 over 2, or the sine theta as a 2 over 3, after using the quadratic formula. B squared minus 4AC over 2A. This is minus B. When I substitute my 5 plus minus square root of the B, which is a 5 squared minus 4, the A is a 6, that's a negative 6 over 2 times 6. That's what I get. So then for the first reference angle, shift sine of negative 3 over 2. I'm getting negative 90 plus what. But by virtue of the fact that this is negative 1,5, it's going to give us an error. So it's not applicable when it comes to sine, because I'll be ending up with imaginary values or imaginary numbers. Okay, which means I'll be left with the 2 over 3. So the shift sine of 2 over 3 is giving me 41. Okay, so our reference angle is a 41,8, and this is quadrant 1. So we shall say 41,81 plus k times 360, which is the period, and then k is an element of integers. This is quadrant number 1. And then quadrant number 2, because we know that sine is also positive in that quadrant, it's 180 minus this 41,30. So 180 minus 41,81 plus k times 360. I simplify that, I'm getting 138. plus k times 360. K is an element of integers. So that's what would have been done. So start with the quadratic formula, the solutions. So this is not going to give us any solutions. And then we end up there. Okay, then 5.4. 5.4. 5.4, they want us to prove we have enough space down. Not that much. Can we prove that this is the same as that? Okay, let me just rewrite it again. To rewrite this again, as much as it's going to take a lot of time. But I remember this question was cut out last year. This question was cut out. But it's fine, let's give it a try. So we have a cos 2 alpha plus 77. Okay. And then you have a cos alpha plus 47. Okay, and then this is minus sine alpha plus 47. And then sine 2 alpha plus 283 is equal to cos alpha plus 30. Okay, so there's nothing much I can do about the first ratio, this one. I just need to play around with this. In which quadrant is 407? That is the first quadrant. And which angle? We know that first quadrant is the same as 360 plus theta. So which angle do I add to 360 to give me 407, which is a 47? So 47 plus 360 must give me this. So if I'm to reduce this, because now it's going to be a cos of 360 plus the 47 plus the alpha now. Okay. I'll keep my 2 alpha plus the 77. When I reduce that, I'm only going to be left with just the cos of this. Then I'm going to keep the alpha and the 47 there. Where do I find 283? 283 is in the third quadrant, which is 180 plus something. So 283 minus 180. I won't use that. That doesn't make sense, man. No, 283 is in the fourth quadrant, not third. Low. So 360 minus 283. It's 77. Okay, so that's the same as the sign of remember in the third quadrant. So in the fourth quadrant, it's a 360 minus theta. So I'm gonna say 360 minus our 77. Is it gonna be minus again, the alpha? Yeah, it must be a minus. So that we keep it as a plus. All right. So let me just simplify that. So I'm gonna have cos 2 alpha plus 77. And then I'll be left with the cos alpha plus 47 minus, I have the sine of alpha plus 47, and then the sine, this is gonna give me negative sine, because the sine is negative within the fourth quadrant. So it's a negative sine. I have alpha plus 77. So this negative and negative will make that a positive. So cos 2 alpha plus 77 times the cos alpha plus 47 plus the sine alpha plus 47, and then the sine alpha plus 77. So this is a compound angle, but it's a compound angle of cos. What happened? There was a 2 alpha, man. It's meant to be a 2 alpha somewhere here. So that this is also 2 alpha and 2 alpha. Okay, so then, because we can see 2 alpha 77, 2 alpha 77, alpha 47, alpha 47. So it's just a compound angle, of course. And if there's a plus, if I call this my A, and I call this my B, it's gonna be the same as cos of A minus B. Okay, so I'm gonna say cos of 2 alpha plus 77 minus, this is going to be alpha plus 47. Because when you open these compound angles, you end up with that. Then I can open this up. I have the cos 2 alpha plus 77 minus alpha minus 47. Then 2 alpha minus alpha, that will give us just an alpha. Then 77 minus 47 will give us a plus 30, which is the same as the right-hand side that they wanted. All right, so that is that. Then 5.5, they want us to solve for alpha and beta. The sine of 3 alpha minus beta is equal to 1 over root 2. If 3 alpha minus beta is between 90 and 270, quadrant 2 or 3. And then at the same time, they're telling us the tan 2 alpha plus beta is equal to this. So let's get rid of these ratios and just focus on the variables alone. So for me to get rid of this, I must find the shift sign of 1 over root 2. Okay. So what is 1 over root 2 shift sign? Okay, the arc sign of 1 over root 2 is going to be 45. But they're telling me that the focus is 90 and 270. That's where the focus is. So which angle is that going to be? We're seeing the sign to be positive here, the ratio to be positive, which means it's going to be in this second quadrant. And in this second quadrant, it's 180 minus. So I'm going to say 1 minus 45. So we can say that 3a minus beta is equal to the 180 minus 45. Remember, first step was to get the reference angle. When you subtract that, 3a minus beta will give us a 135. Then when you look at the tan is also positive. They're telling us with the same ratio. So between these intervals, where do we find tan to be positive? It's in the third quadrant. Third quadrant is 180 plus. So what is the shift tan of 1 over root 3? Shift tan of 1 over, come on, root 3. I'm getting a 30. So here I'll say 180 plus 30, which will give me a 210. So I have 2 alpha plus beta is equal to 210. Then I can subtract the 2. Does that make, why am I saying minus here? Yes, it's a minus, because that's what they gave me. Then equation 1, equation 2. I can just plus this so that this dies out. So I have 5 alpha is equal to 135, and that I'm having 3, 4, 5. Divide both sides by 5. So 3, 4, 5, divide by 5. I'm getting a 69. Guys, getting 69. Okay. Then for me to get the beta, I can just go back to either equation 1 or equation 2. So if I use equation number 2, I'll have 2 times 69 plus beta must give me 210. So it's a 210 minus 2 times 69. That's 138. So 210 minus 138, I'm getting the 72 for beta. All right, so that is 5.5. Then question 6, which is the trig functions. In the diagram, we have f of x, 2 cos x, that is drawn in this interval. Can we draw the graph of g, which is negative tan x within this interval? So guys, it's up to you. Either you use your table or you use the calculator. Okay, whichever one just gives you the results quickest. So that is that. They don't have a g. I'm starting from negative 90. I'm ending at 180. And then the steps of it. What did I do wrong? Let's do it again. Table, that's the function. I'm starting at negative 90. I'm ending at 180. Steps of it. All right. So my calculator, are you in the right mode? So I have a lot of values, but they seem to be too small. They're very, 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 very small. Something is wrong with my values. Because it's the same thing. Say negative 2. Oops. Perfect. Okay, so negative 90 is giving me a negative 1. Then negative 60 is an error. So which means that's an asymptote. Whenever we have errors by the time, it's an asymptote. Then negative 30 is a positive 1. 0 is a 0. Then 30 is negative 1. 60, it's an error. Then 90 is a 1, positive. 120 is a 0. 150 is a negative 1. And then 180 is an error, which means it's an asymptote. Okay, so remember the direction of the tan graphs, or the shape moves towards the asymptote. And then this can move towards, come there, and then towards the asymptote. And then this one will also do the same thing, just in the format, and then move towards the asymptote. Remember the asymptote is at 180. Okay, so that is the G for max. Then they're asking us to determine the period of G. Now remember, normal period of a tan graph is meant to be 180. But then the moment we have something extra there, it will affect the period. In other words, we can just divide the 180 with this. So if I get 180 divided by 3/2, it should give me 120. Is it 180 divided by 1,5? Come on, calculator. Divide by 1,5. I'm getting 120. So my period is 120. So after 120 degrees, I should have a full graph of tan. All right, then 6.3. They want the values of x in the interval for which f is decreasing. Where is f? This is f. So where is f decreasing? So from this point, because that's the turning point, the maximum, it's slowing down, slowing down, slowing down, slowing down towards 180. So we're going to say 0 is less x is less 180. Okay, so 0 is less x and then is less 180. So those are the values for which the graph is decreasing. Then use the graph of G to determine which values of x will G of x be greater or equal to 1. So where do we find the graph of G to be above positive 1? So we can see that from here, because that's a 1. So this area, the G is above 1. Same story here, the G is above 1. So we can talk about the interval of -60 and -30, or 60 and 90. Those are the intervals that they need. So we're saying -60 is less x or equal to x, less or equal to -30. And then the other one that we said was, why am I saying equal to with 60? Come on. It's an asymptote. It's not going to cut. So that is not meant to be there. Then this is going to be the same story. We have 60 is less x is less or equal to 90. Something like that. We'll give you the mass. Then 6.5. They're telling us that h is a function that is obtained by translating G 30 degrees to the right. Okay, they want the equation of h. So we are translating G. G is this tan graph. 30 units to the right, we're moving it in this direction. That's not really relevant to us now. But let's just look at the equation itself. So it's going to be negative tan. Remember, it was 3/2x. Now, if you shift the graph to the right, you shall subtract it from there. So that's going to be h of x is going to be negative tan 3/2 with the x, I'll say x minus 8. That would be my equation. Okay. Then if you want, you can open this up. That's if you want. But that is still perfect for me. If somebody opened it up, it will be 3/2x minus 45. That is if everything's together, but this just enough for the 2 marks. Okay, question 7. The trig application, which is the 2D, 3D trig. They're telling us that in the diagram below, AB is a pole that is anchored by 2 cables at C and D. And B, C, D are just in the same horizontal plane. B, C, D, B, C, D, horizontal. Okay. And then the height of the rope is h. A is a theta. The angle between CAD is 2 theta. AC is the same as that, okay, indicated. Then they want us to determine One mega question. They want the distance CD. This distance is what they need between the two anchors in terms of H. So what I need to do, I can start by finding this distance, the AC, in terms of H. Because if I have this H, I have the theta, and then I have this 90, I can use the trig rules or the trig ratios. So this is the opposite, this is the hypotenuse, so we can use sine. So you can say the sine of theta is equal to the opposite, okay, which is H, over the hypotenuse, which is AC. Can make that over 1 and cross multiply, which means my AC is going to be H over the sine of theta. I don't need to name it, but it's fine. So this side is H over sine theta. So even this is H over sine theta. Now they want us to get the distance between. So for us to get this distance, we don't know this size, as much as we know that this angle must be the same as this angle. Okay. You can work it out that way, whereby if this is 1, this is 2 theta, then these angles are going to be 180 minus 2 theta divided by 2, which is basically 90 minus theta. So this is a 90 minus theta. That's also a 90 minus theta. We can use that. And then we use the sine rule. I don't know, I think that's quicker than using the cosine rule, because squaring those things, it will be something else. But let's see. Yeah, I think that's better. So after getting this, let's say that B is the same as D. Angles opposite, equal sides. And then we're saying 180 minus 2 theta over 2 must give us 90 minus theta. Okay, so A, no, it's B is equal to C. Why am I saying P? It's a D. Malumio. Okay, so D is the same as C, which is 90 minus theta. Then I'm going to apply my sine rule. Remember from the sine rule, we said if you have A over sine of A must give you C over sine of C, or B over sine of B. We're looking for the side, so I'll prefer using this kind of format. So I'm going to say CD over the sine of 2 theta must give me my, if I use this, I can use this too, either this or that, doesn't matter. So let me use AB. That is AB, which is H over sine theta divided by the sine of 90 minus theta. Okay, so since I'm looking for CD, I can multiply both sides by sine 2 theta. So CD is going to be H over sine 2 theta times sine 2 theta over the sine of 90 minus theta. Then I can reduce this, which is H over sine theta. We know that the double angle of sine is 2 sine theta cos theta. When we simplify this with the reduction, that's going to give us just the cos theta. So this can cancel that. I'll be left with 2H cos theta over cos theta. And then the cos theta and the cos theta will also cancel, which means CD is twice H. I don't know, guys, but that's how I would have gone about it very fast, because that cosine rule was going to show me flames, because it's long and squaring the top and the bottom. But if you can use it, I'm not discouraging you. Please go for it. Question 8, Euclidean questions, are telling us that in the diagram below, points P, Q, R, and S are points on a circle with center O. UV is a tangent. Okay. This is it. And then PQW is 106. SP is the same as SR. This is produced to intersect at T. This is produced to create a W. All right. There we go. Then they ask us the first question, can we calculate with reasons? Let's reduce this. Will people see? That's better. So they want us to get PSR. PSR, this angle here. Now, one thing we need to know is that PSRQ is a cyclic quad because it is touching the circle. Okay. And this angle here is exterior. So we know that the exterior angles of a cyclic quad will be equal to the opposite interior. Okay. So I'm going to say that PSR is 106. Reason, exterior angle of a cyclic quad. That is the reason. Then they want us to get R3. So if this is 106, how do we get R3? We know that this side is the same as that side. So that's an isosceles triangle. So we're just going to say that R3 is the same as P4. So for me to get R3, I'll get 180 minus the 106, and then I'll divide by 2. So 180 minus 106 divided by 2, which is a 37. So my R3 is 37. So reason for that will be angles opposite equal sides. Angles opposite equal sides. Then we have this as 37. We have this as 37 as well. Then next, they want P5. P5. Where are you? So when you look at this P5, remember this is a tangent. And then this triangle covers the whole or touches the circle. So you can use a tan chord because this is the tangent, this is the chord, and the angle opposite. So I'm going to say P5 is a 37. Come on, why are you rushing? This is a 37 because of the tan chord theorem. And then they want us to get O1. So if this is a 37, they want us to get this angle O1. Now O1 is at the center. Which angle is at the circumference of O1? It will be this 106. Because this other part of the O will correspond with the Q, other part of Q. So this O1 must correspond with this. So the angle at the center has to be twice. So this is going to be 2 times 106. Okay, that is for O1. And then that is going to give us, I think, 212. Okay, we're saying 2 times 106, which is 212. Reason, angle at the center. Angle at the center must be twice angle at the circumference. Okay, and then P3. How do we get the P3? You want this angle here. So I think we can use the same thing. We can say that P3 is the same as R2. Angles opposite, equal sides, because we know that this is a radius and then that's also a radius. Or you can tell us that OR is the same as OP, because of radii. If that is true, if this is 212, we need to find the other angle that is shorting to make it 360. So 360 minus 212. What do we get? 360 minus 212, I'm having 148. Okay, so this is 148. Then for me to get this missing 2, I'll get my 180 minus 148, divide by 2. 180 minus 148, divide by 2, which means it's a 16 each. That is 16 degrees. I don't know. Am I using a long process to get 16? Was there a shorter way? Why are the marks too small? Yeah, there was actually a shorter way. Because if you get the, what is this? We say 2 is 148. When you divide this by 2, you get your 72. And then what is shorting of 72 to give you 90? Because we know that this is already 90. Yeah, that made sense, but it's fine. We move. 8.2. In the diagram below, A, B, C, D, and E are points on the circle centered O, telling us that AC is AC. OC and ED are drawn. BC is the same as CD. Let's see ED be X. Yeah, these are X. And then they want us to determine two other angles that are equal to X. So when you look at your bow tie, this is X, this must also be X. So you tell us A2 is going to be X. And what is going to be the reason? What's going to be the reason? It's angles subtended by the same chord, or angles in the same segment. Doesn't matter. So angles in the same segment. Or equal chords subtend equal angles would be the same story. So that is A2. But they're telling us that this A2 must be equal to some other angle because this side is equal to this side. So if this side is equal to this side, which means the angles that are also created by this side will be the same. So which means A1 is also going to be equal to X. What is the reason? We're saying equal chords, they subtend equal angles. So A2 and A1. And then those are reasons. Then determine ABC. Determine ABC. They want this angle in terms of X. What do we see there? It's a 3-mark question. ABC in terms of X. All I see is ABCD is a cyclic chord. You know that this is a 90. I think I should start from there. How do people see that? If I just say that my angle ACD is a 90, angle in a semicircle. Angle in a semicircle. So if that is a 90, then what is D1? D1 is going to be 90 minus x because of angles in the triangle. Okay. So if D1 is 90 minus x, we know that D1 and B are opposite angles of this cyclic quad. Okay, so the opposite angles have to be supplementary. So I'm going to say B1 plus the 90 minus x must give me 180 degrees. Why am I saying B1 is just a P? Okay, let's just write it out for people nicely. Okay, we're saying B plus D1 must give us 180, the opposite angles of a cyclic quad. Okay, so B plus the 90 minus x must give us 180. Then we move this 90 that side, we move the x that side, which means B is going to be 90 plus x. I think it's fair enough. Then they want us to prove that AB is parallel to CO. AB, this line, is parallel to CO. So for us to do that, you need to find those angles that are created by parallel lines, either co-interior, alternate, or corresponding. Okay. So if we got this as a 90 minus x, which means C3 and 4 will also be 90 minus x. Let me just write it somewhere here. Okay, this is 8.20. We're saying C3 plus C4 will be 90 minus x. Reason angles opposite, equal sides. Why are we saying that? We know that OC is the same as the OD because both of them are radii. Then if it's a 90 minus x and 90 minus x, then what is O1? Alternatively, helps God. Why did I even go through this? We're seeing that this O1 from this x, O1 is twice x. Angle at the center. We got twice angle at the circumference. Why? If this is a 2x, and the whole of this, the whole of A is 2x. Okay, therefore, you can just recognize that AB is parallel to CO. Reason, the converse of corresponding angles. The converse of corresponding angles. Whoa, what was I looking at for me to go calculate those things? But it's okay, guys. You would still get the same things. You would still get the same marks, and you would end up still with the same results. If you use the 90 minus x and all of that, just the same thing. Whichever format you use, you still get the results. Or someone could also see that, oh, this is a radius, so which means this is x. And then they use this as alternate angles. Bingo. All right, then question number 9. In the diagram below, BOA is a diameter. At O, B is a tangent. There we go. And then EA cuts the circle at D. All right, F is the midpoint. Thank you. Prove by giving reasons. There we go. There we go. That OBEF is a cyclic quad. OBEF. Can we prove? Did they tell us any parallel lines? No. How do we prove that that is a cyclic quad? So remember, when you're proving a cyclic quad, one, either the opposite sides must be supplementary, or the opposite angles, not sides, sorry. Then you could look out for also the exterior angle. And then we could alternatively look out for the bow tie. something like that. If just one pair of angles is equal, then we can draw a conclusion that the figure is a cyclic quad. Okay. So where do we start from? OB, EF. What do people see? What do people think? Is there anything they give us? We only have a tangent. Not so. Yes, just a tangent. If it's a tangent, we know that this is going to be a 90 degree because of the tan radius. Does that make sense though? That's what I'm thinking. And radius. Then it's okay. Let me just write that down and say that B1 and 2, which is the same as B, is 90. The tangent perpendicular with the radius. Then we consider this is the center and this is a chord. So a line from the center perpendicular to the chord. Did they tell us that? I don't know. I don't know. Did they talk about a midpoint? Anyway, the diameter, blah, 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 blah. Yes, they talked about the midpoint. F is a midpoint. Thank you. So we have it. So we're going to say that F2 is also 90. Reason, line from the center. It must be perpendicular to the chord. Line from the center to the midpoint of a chord must bisect the chord. Line from the center. This reason is vague, man. Reframe it, bruh. Okay, we're saying line from the center. Line from the center. Bisecting the chord is perpendicular to the chord. So F2 is a 90. Now, if that is a 90 and then this is a 90, so we're seeing that the opposite angles are supplementary. So F2 plus B gives us 180. Therefore, OBEF is a cyclic quad. And the reason is going to be the converse of the opposite angles. The converse of the opposite angles. All right. Should we add the word cyclic? It's okay, no problem. No problem of a cyclic quad. People must be happy. All right. So that is 9.1.1. Then 9.1.2, they need us to prove that ADB is similar to BDE. Let me use different colors. ADB is macula triangle. Is it macula or macula? Macula one. And then BDE, is small one. Can we prove that they are similar? So when you're proving similarity, just look out for the angles in most cases. So which angles do we see that are going to be the same? So I can see from this triangle that D1 is going to be the same as D2 because D1, number one, is a 90 degree. Why? Angle in a semicircle. Okay, because this is a diameter. So the angle that is opposite the diameter must always be 90. That's a 90, which means D2 is also 90 angles on a line. Okay, so D2 is a 90 angles on a line. Therefore, D1 is the same as D2. All right, so that is fact number one. And then the other fact that we see is what do we see? both sides are, okay, both triangles are having this one side that is equal. So which means the angle that is opposite to those sides will be the same. So E must be the same as A. So I'm gonna say E is the same as A. Reason, you can say equal chords. They There's nothing like that. You can just say angles opposite equal sides. I don't know. What would be the best reason, guys? I don't know. D1 is D2. That's fine. Saying E and A. But refusing that it can be E and A. Okay, I'll take it out. I'll take that out. Okay, let's see. We proved the turn code somewhere. Eh? Oh, we didn't, but we can prove. We can prove it. It's not true. This one of the equal sides, we are rejecting it. It's fine. I've taken it out. My apologies. So let's take the turn code. So this and that. So B2 is the same as A. Correct now. Turn code. So B2 is the same as A because of the turn code. And then, which means this angle E must be the same as B1. E must be the same as B1. The reason is going to be the remaining angle. The remaining angle of the triangle. So if we have prefix, then we can draw the conclusion. Therefore, ADB is similar to BDA. Reason, normally use angle, as well as the angle. So conclusion, and then the reason must be given. And then they want us to prove again that OB is a tangent to the circle passing through BDE. B, D, and E. So if we have another circle that is passing through these points, forgive my drawings. If we assume that's a circle, they want us to prove that OB, where is OB? This line is a tangent. So since we said that B1 is the same as E from the previous question, which automatically makes this a tangent, and it will be the converse of the turn chord. Okay, so what you need to tell us is that your B1, now Lord, where am I going to write this? First. Can write it on top there. It's 9.1.3. Don't worry. That's 9.1.3. We're saying B1 is the same as E. We proved that from the previous question. Therefore, OB is a tangent. And the reason is going to be the converse of the turn chord. All right, so that is question number 9, and then question number 9.2. Let me take this out. 9.2. 9.2. They want us to prove that OF squared is given as AD times DE over 4. Why is it a square? So if we have squares involved, what's happening? Are we going to use Pythagoras? I don't know. Are we going to use the theorem? I don't know. Let's see. So OF, you want us to prove that OF squared is equal to AD. This distance times the DE. the distance. How do we go about that? How do we go about that? We can use since we proved that these triangles are similar, I think we can just use the same approach. And what that is going to be is this side and then that side and so on. Okay, so what did we say? We say that AD, if we get our AD and then divide it by the BT, this must give us the DB, the DB or BD, same thing. And then I'm going to divide that by the DE. Because I'm trying to compare the ratios using the similar triangles. Then if that is true, we can do the cross multiplication so that we have BD squared is equal to AD times DE. Okay. But one thing we know is that our AD is twice the DE. Okay, we're saying AD is twice the DE. The reason as to I'm using DE is because question does not have AE. So remember, this is a midpoint. So this must be 2 times, or must be a half. So AD is twice just one of them, which is okay. So if I try to substitute that, so BD squared is equal to my AD now, which is 2DE times another DE now. We are finished now. We are finished. Is that true? No, man. What am I doing? Where am I even going? That side of the midpoint. Remember, we've proved. Did we prove? No, we didn't prove. But we saw this is a line from the center. That's a 90. This is a 90. Automatically, these lines will be parallel. Okay. And if those lines are parallel from these theorems of ours, this must be a half of that. This is a half of that from the midpoint theorem. Yeah, it's making sense now. So BD, this is out. That's out. So we said BD squared is equal to AD times DE. So BD is twice OF. And then we just square it. So BD squared is going to be 4OA squared. And then substitute. So 4OA squared is equal to AD times the DE. Then divide both sides by 4. So AD times DE over 4. All right, then question number 10. They just want us to prove this theorem. So in this diagram, ABC is shown or drawn. And then D is a point on AB. And then E is a point on AC, such that these two lines are parallel. Okay. Can we use the diagram below to prove the theorem that says AD over DB same as AE over EC? So guys, in such cases, we need to do constructions. It's a must. Okay. So what constructions do we do? Just from this end to that end, and then from this end to that end. Then also we need to construct from this end, we create a height that is perpendicular. And then also a height that is perpendicular. So if I call the first height maybe h, and then I call that height k. Okay. So constructions, we said it's a must. Just construct. You get a mark at least for constructing. Then let's do the proving now. So when you're proving, we always look at the areas. Okay. Just make this there. Okay, so we're going to say that the area, if we look at the area of triangle ADE, let me just focus on this top triangle first. Okay. Over the area of the DEB. But this let me just highlight it. Let's see this triangle length together with this triangle. Okay, over the area of DBE. So that's a half times the base. So with my top triangle, let me. Okay, so we have 16a plus 32. That's going to give us 48a is equal to 96. Then 96 divided by, oh, that's it. I'm not mistaken. Yeah. So that's it. Then I'll get this 2, replace it there. So which means 128 times 2, we get the 256. Okay. So that is how that question would have been done. Okay. Then question number 9. Okay. You're telling us that the graph of h, which is negative x cubed plus x squared plus bx plus c sketched below, give us the values of a and b to be 6 and 0, which are the turning points. Then t is 3 and y is a point on h. Then the graph of h passes through the origin. Okay. So having read that, they're telling us to show that a will be a 12 and b will be negative 36. Okay, so we have number 1. B is a turning point. And also A is a turning point. Okay. Then we know that since the graph is passing through the origin, the C is going to fall out since C is going to be 0. So we only going to be having negative x cubed plus ax squared plus bx. Okay. If I use this point first, and then I substitute. So 0 is equal to, what is 6 cubed? Which is 216. Plus 6 squared, it's going to be a 36a plus 6b. And I just make this an equation. I'll have 36a plus 6b must give me 216 positive. I can divide through by 6. 6a plus a b must give us, we can get 36, which is true. Then make b the subject, which is 36 minus 60. Cover the first equation. And then marks are there. So if that is the first, there are 3 marks. Oh, why are we doing? Okay, it's fine. Let's see if we can get them. Then let's find the first derivative. First derivative. which is dy dx. That's going to be negative 3x squared plus 2ax plus a b must give us a 0. Okay, having done that, I feel like this is a long route. Yeah, it's a long route, but it's fine. Let's see. When I replace x with a 6, that's going to be negative 3 times 36, which is 108. It's negative 108 plus 2 times 6, which is 12a, plus a b must give us a 0. But we said our b is this. So negative 108 plus 12a plus 36 minus 6a must give us a 0. So this and this is going to give us a 6a. Negative 108 plus 36, getting a 72. Then I'll divide both sides by, wait a minute. This is positive 6. That's a negative. Okay. So 72 divided by 6, we're getting 12 for A. Then I can replace this 12 here. And then my B is going to be negative 36. Okay, so that is one way of getting that, in as much as the marks look too small for all that I've done. Alternative number 2 could be using the factor method. Since we have this as a turning point and an intercept as well, which means I'm going to have x minus 6 squared. And then this point also is an intercept with the root, which means I can also have x minus 0. Must give me 0. If I try to open this, I'll have x squared minus 36. Oh, 36, man. It's 12x plus a 36. And then I'm multiplying by x, which is x cubed. Something's off here. Because with this opening, it's meant to be negative. It's fine. Let me keep an a there, just in case. Okay, x cubed minus 12x squared plus 36x. That is my y. Then if I try to substitute 6 and 0, is it going to make sense? Because now this is meant, with this opening, the a is meant to be a negative. That's what I'm saying. With the way the, oh, it's already here. What's wrong with me? So that's a negative. Okay, so if that's a negative, then it's negative x cubed plus 12x squared minus 36. I think we can use that and then get those answers directly. Whichever way, all we need are the answers. Then they want the coordinates of A. We found the first derivative, didn't we? It's fine, let me just find it again. So coordinates of A, we need the first derivative, which is gonna be dx, which is negative 3x squared plus a 24x minus a 36 is equal to 0. And then we solve using either the quadratic or the factor method. You can even start by dividing 2 by 3 if you want. So if I use my quadratic, that is negative 3, we have x squared plus 24 minus 36, getting x as a 2 or x as a 6. So since we're focusing on a is going to be a 2. And get this 2, we replace it into the original. So when that happens, our y that we end up with is going to be negative 2 cubed. That's correct. Plus 12 times 2 squared minus 36 times 2. I'm getting negative 32. Okay, so negative 32 becomes answer. Then they want us to get the value of y around about here. So if x is 3, what is y? So just replace that. Negative, we have 3 squared, no, 3 cubed, plus 12 times 3 squared, minus 36 times 3. Okay, so that is giving me negative 27. And they're asking us, is this graph concave up or down at point T? Okay. What do you think, guys? So we need to find the second derivative. And then at the second derivative, where there's x, we're going to replace it with a 3. So this is going to be, let me just say f double prime x. That's going to be negative 6x plus a 24. When I replace x with a 3, it's going to be 6 times 3 negative plus a 24, which is a 6, because that's negative 18 plus 24, which is a 6. We can see that 6 is greater than 0. Okay, so which means the graph is concave up. So we can say graph is concave up, since the second derivative of x, let's put 3, is 6, which is greater than 0. Okay, just at point B. Then determine the coordinates of the point of inflection. So the point of inflection is okay, so we're saying for the point of inflection, we need to find the second derivative. We need to solve, we need to find the second derivative and equate it to 0, which we got. Okay, so we said negative 6x plus 24 must be equal to 0. Move the 24 that side, negative 6x is equal to negative 24, which means x is a 4. Then we need to get this 4 and then substitute it into the original. So we're going to have negative 4 cubed plus 12 times 4 squared minus 36 times 4. And then that is going to give us negative 16. So which means the point of inflection is 4 and negative 16. Number 10, which is also calculus. They're telling us that a hotel has 72 rooms that it can let to clients. The daily rent per room is 500. Then if the rent is now increased by 100 rand per day, 2 rooms are going to be left vacant. And then the rent is around X per room per day. X must be greater than 500. Can we show that the total daily income is given by that? So what we need to know is we need to set up equations or expressions just for what might be happening here. So an example, if you look at the rooms and the income that is coming through. An example, if I talk about rent being 500, and then there was another scenario where they said if the rent is increased, so if we increase it, it's going to be 600. So what's going to happen? How many rooms are there that are rented? We're saying there are 72 rooms. Okay, and then if the rent was increased to 600, then it will only be 70 rooms available. Not so. Yeah. Then what would be the income? What total will be collected? So if it's 600, that's going to be, does it make sense though? Because it is 600 by 500. The rent is 500. Now the rent is 6. With this much. Let's see what we have. So what we're saying is that originally, if we have 500 and all rooms are rented out, it would give us the 36,000. And then if it is 600 and only 2 rooms are left empty, we could have the 42,000. Okay, so how do we now work this out? Where X is greater than 500. So we need to look for the total increase or the rate at which the increase is taking place. So we can say if we have X minus 500 over 100. Okay. X minus 500 over 500, and then this is going to be multiplied by okay, so I'm going to say 7.2 minus the rate that is causing everything to decrease, because now if 2 rooms are left vacant, then the rate kind of decreases. If we try to open this up, it's going to be 7.2 minus what's 2 times x? That's going to be 2x minus 1,000. We're dividing it by, this must be plus. We're dividing it by 100. Is that true? Yes, it's true. Then if we divide that, it's going to be so 7.2 minus, I'll say 2x over 100, I'll say x over 50 in this case, plus now 1,000 divided by 100, that's going to be a 10, and then 7.2 plus 10, that's going to be 82. What happened to the x?